Hi everyone. I welcome you all to the live session on AWS Cloud Practitioner by Intellipaat. This session is conducted by multiple cloud experts who are having more than 15 plus years of industry experience.
But before we begin the session, make sure to subscribe to our channel and also hit on the bell icon so that you will never miss an update from us.
Now let's see the agenda of the day. Firstly, we will begin with Introduction to AWS Cloud Practitioner. Post that, we will tell you why certification is so important. Then later on, we will see what are the job roles for AWS Cloud Practitioner. Post that, we will be introducing you to cloud computing and its benefits. Post that, we will be learning about the different services provided by AWS. Post that, we will tell you how to become a cloud engineer. What are the skills, role and job prospects of a cloud engineer? Then finally, we have covered AWS interview questions and answers. So guys, this is the agenda of the video. Now let's begin the session.
Let's move on and talk about why certifications are important. And for this, let's take a very short example. Let's say you apply for a job and let's say this is your employer and these are the number of people who have applied for the job, right? Now, how do you think you can make a hiring manager's job easy? Right? The way you can do that is by basically getting yourself recognized in a way that the hiring manager will basically the hiring manager's job becomes easy to basically hire you. Now, how would you do that? Right? Let's say there are 10 people who have applied for a job profile. Now, what happens? Right? What happens is when there are 10 people, the hiring manager would first go ahead and ask the people who have applied for the job that who all among you basically have a certification, right? And the people who have certification, they basically call them first and take their interview. Now, let me relate it to the real world. Let me relate it to what basically happens when you apply for any job in a company, right? What happens is, let's say you apply to Infosys or Capgemini or any MNC for that matter from their website. So you upload your resume, and once your resume is shortlisted, they call you back. Now, what is the process of shortlisting a resume? What happens is they have an HRMS tool where basically your resume basically goes, right? And your resume is basically rated with respect to the relevancy of the job. Right now, how is it rated with respect to the relevancy of the job? They see the keywords which are included in the resume. They see whether you have the required experience or not in your resume. And obviously, they also see if there is any related certification that you have in your resume or not. Right? Once they rate your resume, now for a particular job profile in an MNC, there are hundreds, if not tens, of applicants who apply for that job profile, and there are only 2 or 3 job openings which are there. Right? Now, having said that, now this is not a fool. So rating resumes is not a foolproof way of hiring people, but what they do is they prioritize resumes according to the rating. Right? So if a person has a resume whose rating becomes 9 out of 10, their interview call will go first than a person whose resume's number would be around 7 or 6. Right? So what I mean to say over here is that certifications is a very important criteria for hiring managers to rate your resume. If you have a relevant certification, the chances of you getting an interview call faster becomes 3 times more than you not having that certification. So having your resume up to date and having yourself certified is very important in order to get or in order to expedite the process of job hunting when you're going out for a specific job role, right? Having said that, now let's talk about the AWS Cloud Practitioner certification. What is this certification all about, and who should basically apply for this certification? So let's go ahead and talk about it. So this is the AWS Certified Cloud Practitioner page, guys, and all you have to do is just type in Google AWS Cloud Practitioner and you will reach this page. So let's discuss this page and understand what all things do we understand from this web page, which is basically given to us by AWS. So the kind of things which are validated from this certification are these. So you basically, if you pass this exam, what you're telling to your employer is you know what AWS Cloud is and you understand its global infrastructure. Okay, you understand the AWS Cloud architectural principles. you basically would know about various AWS services and where to use these services. What are the common use cases where you can use these services, right? You would be able to implement basic security and compliance aspects when it comes to AWS infrastructure. You would be able to understand the billing, how these services will be billed. You can also forecast, what are the amount of, bill which will come in a specific month based on your usage. I mean, this AWS does for you using some services, but it's important to know how to access those services. So that is what you will be validating once you clear the AWS Cloud Practitioner certification, right? You will also be able to describe basic characteristics uh, for deploying and operating in the AWS cloud, right? So these are the things which an employer gets to know that you are aware of if you pass this certification. Now, how is it going to help you? Let's talk about that, right? So first, let's talk about what are the things that you should know before you're applying for this job role, right? So if you're applying for this job role, this is not going to certify you as an expert in AWS. So this certification is an entry level certification in AWS, right? After this certification, you have the associate level certifications, then you have the professional level certifications, and in the end, you have the specialty certifications. So this certification is a gateway to for people who want to shift their domain into the cloud industry, or people who already are working in the cloud industry but basically want to switch their job, and in order to switch their job they're looking out a way so that the process can be expedited. And this is the way you can do that, guys. You can basically apply for this certification, get yourself cleared in it, and that will validate all the things required to basically apply for a job. Now, having said that, now let's talk about the prerequisites for this particular certification, right? So recommended knowledge and experience. We recommend candidates to have 6 months of experience with AWS Cloud. Now, what does that mean? It does not mean that you have to have a job in which you're working where you need to have 6 months of experience in the AWS cloud. What it basically means is you should have the knowledge which is equivalent to a person who will be working on AWS for 6 months. So if a person works on AWS for 6 months, the kind of knowledge that he should have, the equivalent knowledge you should also have when you are basically appearing for this certification, right? And they should also have an understanding of IT services and the uses in the AWS cloud platform, which again is coinciding with the first point. Basically, you need to be aware of what AWS is, what are the AWS services, etc., when you are applying for this exam. Now, what I just told you is not very particular. So let us get into the nitty-gritties of what exactly you should know when you're applying for this job, when you're applying for this certification, right? So what you can do is just click on download the exam guide, this section over here. When you click over here, the exam guide basically opens, and here you get an in-detail overview of what you should know when you're applying for this job, right? So you should be aware of cloud concepts. You should know about what AWS cloud is. You should talk about, about cloud economics, that is the pricing details and everything. You should also talk about cloud architecture design principles. So this is nothing but a white paper that is available on AWS. You should go through that white paper. Then you should understand AWS shared responsibility model. This is again a white paper that you should know about cloud security and compliance concepts. So you should know about the cloud security services, and you should know about the compliance concepts in AWS. You should know about the access management capabilities. So there's a service called IAM in AWS. You should be well versed with that service, right? And you should also be able to identify resources for security support. In the sense, let's say some company is going ahead to implement their AWS infrastructure, and they want to secure their AWS infrastructure. So you should be able to identify resources which will basically help you to secure the architecture which you're basically trying to build. Okay. Then also you should know about the methods of deploying and operating on the AWS cloud. So what are the various methods to deploy applications? What are the various methods to use applications on the AWS cloud? You should know about the core AWS services, which are basically the compute, the networking, the storage, right? And various other domains as well. So AWS has around 1,000 plus services. So you don't have to know about all those services. You basically have to keep your focus on the services which are there in compute, services there which are there in networking, services which are there in storage, and services which are there in applications domain. Okay, so if you go through only these services, it would be enough to crack this exam, right? And finally, you should also be knowing the billing and pricing of the AWS products. So for this, if you go through the free tier, if you go through what are the things that are available in free tier, what are the things every month, even after the free tier we get free, what are the different kind of pricing models which are available in AWS with respect to deploying a resource. Going through these pricing models, going through the caps on the free limit should be enough to understand the billing part of AWS. And at the same time, there's also AWS Cost Center. So you should be knowing what AWS Cost Center is, should have seen what the Cost Center is, etc. Right? So guys, these are the things that you need to learn in order to basically crack this AWS Cloud Practitioner certification. Now let's go back and talk about the most important part. What kind of job roles can you apply when you basically have got yourself certified in the AWS Cloud Practitioner service, right? So let's talk about that. So again, going back to the browser, if you go to a website like Indeed, right, and all you have to do is search for the job profile AWS Cloud Practitioner, right? So when you do that, these are the kind of jobs that you get. Now, all these jobs have a prerequisite of the AWS Cloud Practitioner certification, right? So for example, you have the Cloud Migration Planning and Execution by Accenture, right? This has a prerequisite of AWS Cloud Practitioner, and this is basically a tech support role when you're applying, right? Similarly, when we are talking about AWS architecture, this is again by Accenture, right? And this also is a tech support role, and this also requires you to have an AWS Cloud Practitioner certification. Then there's a company called Shelby Shielding Futures. This also basically requires you to have AWS Cloud Practitioner certification. And at the other end, if you are a developer who also wants to move into the cloud domain, right? Getting that certification will get you this job, which basically expects Java and the AWS skill sets, right? But not it's not like only developers should go for this certification. As you read, this is a tech support profile. Now, in this, you are only required to have that certification in order to basically apply for this job, right? Ignore this part which says 15 plus years experience. Now this is one of the criteria which will be used to basically rate your resume. So if you don't have 15 years of experience, it is okay. A 2 or 3 years of experience or 4 years of experience will also work, given you can match all the skills which are mentioned over here, right? Now when you talk about skills in the cloud domain, there are a lot of skills that a particular person might want to have, right? For example, if you're and it all depends on what kind of salary bracket you're applying to. For example, if you're applying to a salary bracket which is near 20 to 25 lakhs per annum, right? You would be expected to know a programming language, you would be expected to know DevOps through and through, and you will have to know AWS along with other cloud providers as well. When we talk about the salary bracket of 12 to 15 lakhs, in that case, having a knowledge of a programming language is not required, but strong Linux skills and expertise in any one of the cloud provider, that is AWS, Azure, or GCP is there, right? And if you have these skill sets, then a 15 10 to 12 to 15 or a 15 to 20 lakhs job you can apply to and can crack, right? Then comes the third category when we talk about 10 to 12 lakhs of range. So this range is suitable for people who might not have an IT background, who might have an IT background also, but they want to basically grow in their career and want to apply for cloud jobs. So in that case, you can basically just go ahead with the certification, right, and learn Linux, and then you can apply for cloud support engineer roles. For example, in Amazon also, if you uh, go ahead and search for cloud support engineer, Amazon gives the starting package of 10 lakhs. It's not mentioned here, but I was seeing it in the morning that AWS also is offering a cloud support engineer associate role, which basically expects you to have a cloud practitioner prerequisite, right? And the starting salary is 10 lakhs, right? And what they need is not DevOps. You don't require any DevOps knowledge. You don't require any programming language, or only requirement is having the cloud practitioner certifications and of course experience in Linux programming, Linux operating system, right? So guys, these are the job roles that you can apply for, and I told you the salary range that if you are not from an IT background, or if you are from an IT background, and when you want to switch your profile into cloud, and let's say you are not a developer or you're not a system admin, and you're applying for the cloud role, in that case you will have to get yourself certified in cloud practitioner, and you'll have to learn about Linux before applying for the job role, right? If you are aiming for 12 to 15 lakhs of package, you guys are either developers or administrators since the past 3 4 years, and now you've started to learn AWS, and now you are, when you are applying for jobs, your job roles would be around cloud engineers or cloud architects, right? A cloud architect would require a solutions architect certification, but a cloud engineer you can apply for, and you can expect a package of around 12 to 15 lakhs when you're applying for jobs, right? If you're already a developer, a full stack developer, or you're already a system administrator who has more than 10 years of experience, right? And you're good at what you do, now you're trying to shift your domain to the cloud. In this particular scenario, you can expect a salary of 20 to 25 lakhs, but your prerequisite would be that you have to have knowledge about DevOps, you have to have knowledge about programming language, and at the same time you also have to have knowledge about AWS along with one more secondary cloud provider such as Azure or GCP. Okay, so guys, this was about the job roles. And when we talk about AWS certifications as well, there are a lot of AWS certifications that you can basically look at. So let me just talk about all the certifications which are there apart from cloud practitioner, so that you know that you know what you are applying for when you're basically appearing for an exam. Okay, so let's go to certification. aws.amazon.com, and now where you have to go is certifications. One second guys, let me open the right link. So these are the different certifications that are given by AWS. So the foundational certification is the cloud practitioner certification. Then when you talk about the associate certifications, you have solutions architect, developer, and sysops administrator. When you talk about professional certifications, you have solutions architect, DevOps engineer, and then you have specialty certifications as well. So we are talking about the foundational certification in AWS right now, right? When you go a notch higher, you also have associate certifications, and this you can apply to when you have basically an idea about cloud, when you've worked in the cloud industry, you want to grow in your career in the any of these three profiles, then you go for these certifications. For example, you want to apply for the cloud architect job profile, then it makes sense that you go ahead and apply for solutions architect profile. If you want to become a cloud developer, then developer profile. If you want to become a sysops administrator or basically a VM administrator, in that case, you go ahead and apply for sysops administrator profile, right? So this is an overview of which certification to basically apply to when you are preparing yourself for the certifications which are there in AWS, right? So we are talking about the cloud practitioner certifications.
Cloud computing. Yeah, please do understand. So this because a little theoretical understanding is definitely is needed. That's why I want to cover this cloud computing. What is the cloud computing and what are the benefits of the cloud computing? So you must have some idea about this. In this, in the easiest term, the cloud computing defines and programs over the internet from a remote locations. In other words, we can say the cloud computing term is used to deliver or delivery of hosted services over the internet. Or you can say the delivery of hosted services over the internet is known as cloud computing. Those hosted services could be the DNS service, storage services, could be web services, could be your compute services, could be your infrastructure services, could be your deployment services, could be your development services, could be your software services. So any sort of service I'm talking about. So any sort of service, if you hosting that service over the internet, so that is known as cloud computing. And cloud computing, by AWS definition, it refers to the on-demand delivery of IT resources and applications via the internet with pay-as-you-go pricing model, right? Because AWS is very, very reliable in payment scheme. They are saying you have to pay only for the used resources. If you have the resources, if your resources are stopped, so AWS will not charge for the stopped resources, right? But if you are using those resources, if the resources are running, AWS will charge for the resources, not for the services, right? So as per the pay-as-you-go pricing model, AWS charges on per hour basis. Depend what kind of the plan, the pricing plan you have taken. Okay, so we have a different pricing plan, but one standard plan, about the one standard plan I'm talking about. So, and that is the per hour basis. So AWS generally charges on a per hour basis. So let's say if you use the resources for 2 hours, if you have some resources which you are running in AWS, consider that you are using the resources for the 2 hours. So AWS will charge only for those 2 hours, right? So now this way you can control the billing amount. So if the services are not required, anytime you can stop those resources. So we will see in detail later on, by the way. So this is very clear. What is the cloud computing? The hosted services over the internet is called cloud computing. AWS only charge for the used resources. And the second is the host services or hosted cloud services. So cloud computing is a kind of or a type of internet-based computing. And without internet, cloud computing doesn't exist. So internet is mandatory. Internet is essential, where you can deliver the IT infrastructure and software application related services. So without internet, that is not possible. So however, before arrival of cloud computing, you used to deliver software application services from your own physical environment, right? Yeah, we used to deliver our own services from our physical data centers, but now the time has been changed. And therefore, you could see the two types of the services we had, the hosted services and the cloud services. So if you're talking about the hosted services, so I'm straight away talking about your data center. You have your own data center in a hosted services mechanism or technology. You have your own machines, you configure those machines, and you present those machines to your clients, to your data center. And for that, sometimes you are using internet to present your services to your client. Maybe he's existing somewhere in some remote location. So such kind of things can be considered in a cloud computing. Because in your physical data center, the resources belongs to you. Resources belong to your company. You are not hiring the resources from any cloud provider. So the hosted services what? So in this technology, in the hosted services, you configure and maintain infrastructure and a software application at your own environment or at service provider premises, right? And access of these services to your end users are often provided through a direct connection, and this can require internet connectivity. So internet connectivity is mandatory, right? So second, I was just talking about the cloud service. As you know that what is a cloud service? So the hosted services over the internet is called cloud service. But in such platform, you do not require the physical server. If you're talking about the cloud services, you do not require your data center. You do not require the physical server and infrastructure to run application. Means you are hiring infrastructure, you are hiring machines, right? You are hiring resources. So cloud computing serves you a simple way of access of servers, databases, storages, and other set of application services over the internet, right? Means you are not creating, you are not purchasing any hardware, you are not You are not setting up any data center in your organization. You are just hiring these resources through the cloud provider. And it could be the part of the cloud service, right? So in brief, you can say the hosted services over the internet is known as cloud computing. So the management of those data centers and the management of those resources are the part of cloud provider. So even if you are hiring some resources, even if you're hiring some machines from cloud provider, so cloud provider providing you only resources to create your machine, just like virtual machine, just like your servers, but you won't be able to directly work on their data centers. They do not allow such kind of facilities to their clients. The benefits of cloud computing. So we are starting with the flexibility, right? But before the benefits, remember the cloud computing is not a single piece of technology. It's a very complex, and hence we cannot limit its benefit in this topic actually. So we have a different kind of benefits, and you know that in cloud computing we have a different kind of cloud platforms like software as service, platform as service, and infrastructure as service. So almost every organization wants to use the cloud computing benefits either partially or fully. And according to one survey that was held this year in United States, and that was did by Forrester, right? So they are saying that it is estimated by the end of this year. So this cloud computing market can touch more than $200 billion. So this is estimated, of course, but this is very huge target. So big player of cloud computing like Amazon, Intel, HP, Microsoft, Alien, AWS, and even VMware. So they are making huge investment in cloud computing, correct? And AWS is a public cloud platform. AWS is a public cloud computing platform, and it is based on pay-as-you-go model. We have a public cloud, we have a private cloud. So you'll see later on. But if you're talking about the Google, if you're talking about Azure, if you're talking about AWS, so all these are public cloud platforms. So these platforms basically allows you to create your account on these platforms. You can choose business account here, and accordingly you can create infrastructure, and you can just serve your infrastructure or created infrastructure to your client, by the way. So we will start with the flexibility, right? So we are starting with the flexibility. You should understand the flexibility. So flexibility is a benefit, is one of the benefit, the major benefit of cloud computing. So here we go. So cloud computing is the best for businesses, right? So where you see a regular change and the resources requirement or the fluctuating bandwidth of demand. And accordingly, the resources can be scaled up or scaled down. And to scale down or scale up to meet the requirement, it's a matter of few seconds or few minutes with the cloud administrative knowledge. So in addition, AWS enables you to select the resources of your choice. Example, what are the flexibility you have? Right. So what's the flexibility you have? So if you're talking about the flexibility in cloud computing, you have enough flexibility to choose any operating system. You're going to choose Linux operating system. You're going to choose Mac operating system. You're going to choose even a Windows server operating system, your production server. Number one. Number two, you can work on any programming language like Python, Ruby, Node.js, Java. So all popular languages supports are there in cloud computing. Even you're going to choose any database. You're going to choose structured database, SQL database, as well as no SQL database. You're going to use even the caching services also for your database services. And all these are providing as a kind of a flexibility to choose operating system, languages, databases, and web application platform as per your own requirement, right? So you are free to choose any any variables like operating system, programming languages, database, and other application servers. So by the way, so that's why people find that it's really easy to create infrastructure here. Next benefit is reduced and controlled capital expenditure. Reduced and controlled capital expenditure. What is the controlled expenditure? Yeah, expenditure means how much you are paying for the resources, definitely. How much you are paying for purchased machines. So can you control them? Is it reasonable? Yes, it's reasonable in case of cloud computing, right? And you are not purchasing anything, you are just hiring those things. So think about the old and traditional way of running IT services. So you do require the servers, storages, connectivity, routers, switches, cables, connectors, database servers, many other things to run your own data centers.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
And if you calculate the overall cost of that infrastructure, it was really high, right? And to cut down the cost of that existing physical infrastructure, cloud provides an excellent opportunity. You have now an option called cloud computing. So why you are wasting your money, why you're investing your money in purchasing all such, all such expensive resources for your data centers? You can directly use a cloud platform to create resources. You can hire those resources anytime. You can stop anytime those resources. So you can now choose AWS service, which simply based on pay-as-you-go pricing model and enjoy the service model. So instead of heavy investment on hardware as well as on software, so cloud computing provides resources on cloud. Correct? And you can configure them as per your need to deliver to your end users. So you have a full liberty to create infrastructure. You're going to hire resources, compute resources, and if you don't need them, you can terminate those resources. You can stop those resources to control your capital expenditures. So that is there in cloud computing. But in physical infrastructure, this facility is not there. Right? Good. So guys, software updates. So pretty good, actually. This is I really like this method because AWS is now offering patch management capabilities. So which is a part of AWS EC2 System Manager, because in AWS we have number of services. Every service is a specific task in AWS. We will learn about those services first of all. Then we'll talk about how we would use actually those things bit by bit. So with the patch management capabilities, you can automate your patch process. Are you listening to me? Patching. What is the patching? Patching means, in a very simple way, I'll say that you have, for example, you have 1,000 server in your organization. Let's say you have 1,000 Windows server, and after every certain time or after every, let's say 7 days time, you need to update those operating system as per the updates you will have from AWS from Microsoft. So what you usually do, actually, you create a WSYS server. What is a WSYS? WSYS is a kind of a server which is basically keeping the repository, updated repository to update your servers that running in your environment. So this feature saves your time, and but it was manual actually earlier. But if you're talking about AWS provides the patch management features in AWS Cloud. So this feature saves your time. It saves the risk of non-compliance, right? And it reduces the risk of non-compliance, as well as it also saves basically the time for implementation. And time, as you know, that the time to time, the supplier, just like in an operating system you have in Windows. So the Windows operating system find actually some vulnerabilities in their operating system, and to fix them, they usually provide some security fix as well as some updates for their operating system. And what is your duty as an administrator? Your duty is as an administrator to update your existing servers running in your production environment, or update your servers as per the provided updates by operating system provider, just like Microsoft. But earlier it was manual actually. But in cloud computing, it is not manual, it is automatic. And you have not to create any server for this, right? So we have a service to update your existing production servers. So we will use those services just like in a system manager. So guys, stop guessing capacity. So when you decide to run an application over the cloud, you design an infrastructure as per the need. And at the time of the designing, you either end up sitting on expensive resources or dealing with a limited capacity. But if you're working on a cloud computing, you don't see the challenge, because the cloud computing allows you to tune the infrastructure as per the requirement. And you can define the minimum and maximum capacity of the resources, which can be scaled up or scaled down anytime as per the infrastructure. If you're working in cloud computing, you have not to tell anybody how much minimum resources required or maximum the resources required to manage your traffic or manage your request, right? You have not to tell anybody, because you can increase or decrease number of instances as per the requirement, right? So I'll tell you, we have some services like auto scaling. We have auto scaling in EC2 in AWS. If you're using auto scaling, you can increase or decrease number of virtual machines. That the increment and the decrement of those machines will depend on the condition you will apply. Means if you receive large number of incoming traffic from the internet, automatically the number of machines will increase. If the traffic is decreasing, the number of machines will decrease. Maybe it could be, the condition could be set on the consumption of the CPU resources. So we'll learn about later on in detail. This is a part of our course. But I'm saying the stop guessing capacity. If you're working on cloud computing, you have not to just calculate the maximum or the minimum capacity of the resources. Anytime you can increase or decrease. It does depend on your requirement. So you can put the condition, and on the basis of the condition, your resources could be increased or decreased. Correct or not? Right. So the next is data accessibility. What is data accessibility? Very important. So when you're working on cloud computing, you might be storing your data. You might be storing your data over the cloud. We have a different kind of storages. We have object level storage, we have block level storage, we have file system storages. So we'll talk about those storages in detail. But just think about the data accessibility. Accessibility, how you can access the data. If you're talking about AWS cloud computing or any cloud computing, means your data is stored over the cloud, right? On some internet storage or some cloud storage. But the data is accessible over the cloud very easily. And it is cheaper and it is highly available for the business team. If you're just comparing the storage over the cloud with the storage within the data center. So data center storage is very expensive as well as limited. However, the storage over cloud computing could be unlimited. So in case of AWS, we have an object level storage like S3. So that S3 has no limitation. There is no upper limit. Any amount of data can be stored. And the data can be stored, any amount of the data can be stored. And not only you can encrypt the data during the transit as well as in rest. So we have even a security option. So you can access your data stored over the cloud using internet connection from anywhere over the internet, right? From anywhere, you can access the data. Number one. Number two, cloud computing security feature is on high priority for cloud computing providers, right? And this includes the protection of critical information from data leakage, deletion, and theft. Means your data is safe. Nobody can steal your data. Nobody can see your data if the data is encrypted. Nobody can access your data if you do not provide your credentials. You should not provide the credential to everyone, right? So means you should understand the real purpose of the security, what comes under the security, encryption and credentials. If these two things are safe, are not shared with unauthorized people, it means your data is safe. So you have a data encryption, packet filtration, as well as data accessibility mechanism that can be controlled through identity and access management, IAM. So feature like data encryption is available in your cloud. So we have two different kind of encryption. One, the encryption is on is at rest, and during the transit of the data from one location to another location, data can be encrypted, right? It's up to you. So what kind of encryption you want to apply, that we can see later on. Right now, we are just talking about the features, the benefits of cloud computing. Next is disaster recovery. So these days, this term is very popular in IT department. If you're talking about the disaster recovery, so disaster recovery means if something happened bad with your location where the infrastructure, storage, your data, your resources are available. So that could be unavailable because of some accidental happening. So what we'll do, you must have some alternate link. You must have some alternate location to provide access to your client of the same infrastructure or data. So what I'm trying to say that the cloud disaster recovery is a method or kind of a strategy to take a backup of the cloud resources, including your data, and later on it can be recovered. So it ensures that you will not lose your information or infrastructure. So this provides the data recovery and the backup strategy, which has happened due to the man-made and or you can say the natural catastrophe. Means it could be happen. The war can happen, terrorist attack can happen, natural catastrophe, for example, some flood can come. So anything can happen, right? But you have an option to just manage disaster recovery in cloud computing. In some difficult times, you can easily recover your data as well as your infrastructure. So AWS also provides the kind of services that enables the fast recovery of your configured IT infrastructure as well as your data, right? Competitiveness. So what is the competitiveness? Earlier it was, very difficult for a new person who was just, if you start any new business. So earlier it was very difficult to hire or just configure all advanced level of application or to start your business with advanced level of infrastructure because you had to purchase everything. Because that time you had a manual or a data center, but these days we have a cloud computing. So when you run a business, so what is your ultimate goal? for your business, the ultimate goal is the product of the business, right? Means if you are a shoemaking company, so you should concentrate how many shoes in a day, the quality shoes in a day you can create. If you're in a pharmaceutical company, you will concentrate, you focus on your medicines, right? So this way, every business will have a certain product and you will focus on your product. So the business house needs to put all their efforts to maintain quality and the production of number of products, right? But AWS says, okay, no, you just focus on your product or the project. Please do not focus means how you can just configure or how you can just manage all the resources to run your business. So if you are hiring the resources from the cloud computing, you have not to set up their data centers, you have not to set up their power, you have not to set up their ACs, you have not to set up their infrastructure. Correct. So AWS or any other cloud computing provider, they will.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Provide you a kind of a platform, and using that platform, you can create infrastructure as per the need. And if it is not needed, you can squeeze down, you can close those resources. And if you have less budget, you can start with the less budget infrastructure. And if you later on, if your business is enhancing or increasing anytime, you can increase those resources, right? So you can start with minimum and later on you can expand your infrastructure. Earlier, it was not possible in your physical data center. That's why we are saying that it's now. It's very easy. So on cloud, you do not require heavy lifting of racks, servers, and other resources. Infrastructure, software, and the platform are just few clicks away on the cloud. If needed, you can just go open a cloud platform and just create the infrastructure. So it is easy to use for everyone, and you will have better experience and low latency resources. So in brief, I would like to say that the cloud computing allows even smaller businesses to act faster than the big and established competitors. Anybody now, if you have a budget, if you have a clear idea about your applications and development, whatever it is, you can just go to the cloud computing environment and you can just create for your business. It's very simple. So this was a pretty simple idea about benefits, right?
So next is, what is AWS? We all know that AWS is a cloud computing platform. That is, AWS, Amazon Web Services, is a cloud provider which provides a lot of services on the internet to the user. Many companies like Netflix, Unilever, Expedia are using Amazon Web Services for their own personal needs. Netflix have went all into AWS. That means all of their infrastructure right now depends on AWS. So think of AWS's capability. Now let me give you a few examples of other cloud providers. The first one is Microsoft Azure. Azure is owned by Microsoft and they also host their own products on it, like Office 365, and also you can do native integration of IDEs like Xcode, IntelliJ IDEA, and Visual Studio. Then Google Cloud. We all know Google is the biggest brand name in the internet industry. Google Cloud came around 2011 and it has become a hit, and it is now the third most popular cloud provider in the world. Alibaba Cloud. We all know Alibaba. Alibaba is a China-based company. Alibaba Cloud is also called as Aliyun. It basically provides services to businesses who want to host their services online. Next is IBM Cloud. IBM Cloud is also similar to Azure, Google Cloud, and Amazon Web Services. It also provides services like compute, networking, and storage services. Then comes VMware. VMware is a software virtualization company. So basically they provide virtual machines via the internet to users or companies. Finally, Salesforce. Salesforce is also a cloud platform and their main tool is CRM, that is Customer Resource Management, and they are considered to be the number one at it. So, why is Amazon Web Services so successful? They have started AWS in the year 2006 and it is still the number one cloud platform. Let us see why. Before even a cloud company thought of it, Amazon Web Services already revolutionized the IT industry by introducing a new way to use servers to the companies and the businesses. And there are three key points which made AWS successful. The first is its simple and per hour billing. The billing system of AWS is very simple that you will be only charged for the particular services which you use, and it is also based on the number of hours you use, not the days or the months. The second reason is Amazon's brand name. Amazon.com is a household name all over the globe because it is the biggest e-commerce platform. Third reason is its easy profile setup. The first thing you have to do is provide your details, your email address, your username and password, just like you create a social media profile. And the second step is you have to give your credit or debit card details, and that's it. Your AWS profile has been set up. But what makes Amazon or Amazon Web Services peculiar? So Amazon has its own leadership principles and it makes its employees follow that. Let me give you a few examples of them. The first is customer obsession. Customer obsession is that leaders start with the customer and work backwards. The first thing they follow is they need the customer's wants. That means whatever the customer wants, they want to give. Then they work backwards. They reverse engineer. The second is invent and simplify. Leaders expect and require innovation and invention from their teams and always finds way to simplify. They also need inventions and also they need to simplify it. The simplified, most easiest user-friendly manner is more attractive for a customer. Third principle is ownership. Leaders or owners, all the employees in AWS or Amazon need to have that feeling of ownership. And the fourth point, this point is common for anybody. So learn and be curious. Leaders are never done learning and always seek to improve themselves. So always keep on learning and be curious in what you do. The next is the future of AWS. So what is going to be the future scope and the job trends of AWS? Let us see. So the market share of 2018's quarter 4, that is the last 3 months of 2018, Amazon Web Services had 32.3% of the cloud computing share, and Microsoft Azure comes second with 16.5%, which is almost the half of Amazon Web Services, and then Google Cloud Platform, and then Alibaba Cloud, and after that comes the other services, other cloud providers like IBM Cloud, VMware, and Salesforce. And what are the AWS job trends right now? Let me give you few job trends. So the 4 job trends are AWS SysOps Administrator, Cloud Developer, AWS Solutions Architect, Cloud Software Engineer. So the salary of AWS SysOps Administrator is $111,000 to $160,000, and a Cloud Developer is $95,000, and an AWS Solutions Architect salary varies from $98,000 to $150,000, and a Cloud Software Engineers varies from $63,000 to $93,000, and these are all the numbers for a fresher. The salaries may vary with your experience. If you are an experienced person in the cloud industry or in AWS, you might be earning more than this. This is just the starting.
Moving forward, guys, now let's talk about the thing that we are here to learn for. Let's talk about the AWS services. Let's see what kind of domains does AWS gives its service into. So AWS provides its services in compute, it gives in storage, database, security, management, customer engagement, app integration, etc. So we're going to discuss each one of them one by one as we move along. So first up, the compute domain or the AWS domain is compute. Alright, so I think I have a question from Shubham. So Shubham is asking me, among these domains, what is the difference between storage and database? All right, Shubham. So storage is basically used when you have a workload wherein you want to upload binary files. Like, what are binary files? Files which like video files or MP3 files or photo files. All these files are called binary files because they're not data. It's basically, it's content, and that content is basically binary in nature. All right, so all your videos, all your music, right, any kind of file which you execute, your games, all of those are binary files. When you compare it with database usually deals with data which is textual in nature and has a proper structure. It could be unstructured as well, but basically textual data that a human can read is included inside a database, right? But on the other hand, files that run on computer, for example, any program or any video file, any music file, or any other file in that case, these kind of things cannot or should be stored on a storage kind of platform. It should not be stored on a database. It can be, but it should not be, because it unnecessarily makes the database, the size of the database big, which actually causes a problem when you're querying through the data when you're using a database. Alright, so guys, this is the difference between storage and database. Shubham, is your doubt clear about the difference between storage and database? Alright, so I've got a yes from Shubham. Others, guys, if you have any doubts in these domains, you can ask me. Let me explain you all these domains one by one. So compute domain basically deals with servers. So if you have, if you need servers, or if there is a workload which needs processing, the compute domain will have services that you can launch and implement that workload. More on this we'll discuss as we move along. All right. Then we have the storage domain, which, like I said, deals with storing binary files on the remote servers. So for that, we have a dedicated services, and we're going to discuss those dedicated services in storage. Then we have a service called database, a domain called database. In the database domain, you have a lot of services. So if you have structured data, you have one kind of database for that, or we have one kind of database service for that. If you have unstructured data, you have another database service for that. So we'll discuss more on that as we move along. Then there is a domain called security. So all security related to the application that you have uploaded, to the servers that you're using, to the account that you're using, for all those kind of things would be included in security. So there are specific services for each kind of workload that I just mentioned. We're going to discuss that when we reach the security domain. Then we have the management domain, which would include monitoring, which would include deploying the whole architecture at once, right? All those kind of services comes in management. Don't worry if you don't understand it. I'll explain you more as we move along in that domain. Then we have customer engagement. So sending emails, sending notifications, all those kind of services comes under customer engagement. And in the end, we have app integration. So services like queues, like for example, if you have an application on which you have to give a lot of jobs, it's better to have a queue where you'll store all your jobs, and that queue is separate from the server which will be executing your jobs, right? So these kind of integrations are called app integrations, and we'll be discussing the services in that domain as we move along. All right. So guys, these were the domains, the main domains that are there in AWS. There are a lot of other domains as well, but we'll be focusing more on these domains since, this is what is actually going to be asked for in your solutions architect exam. And at the same time, these are what you will generally be using when you become an AWS engineer. All right. So moving forward, guys, now let's start with the compute domain and let's see what all services are there in the compute domain. Alright guys, so let's discuss the AWS services in the compute domain. So here are the set of services which are included in the compute domain of AWS. So this particular service is EC2, Elastic Beanstalk, Lambda, Autoscaling, AWS Load Balancer, AWS ECR, and AWS ECS. Now for the sake of explaining you guys, I've taken the liberty of shifting some services from some other domains which I think should fit in this domain, right? But you don't have to worry, the explanation would be the same. It's just that you would find it somewhere else in the AWS management console. Like for example, autoscaling would not be under...
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
The compute domain, it would be under some other domain. I'll show you when we move on to the AWS Management Console as to where you can find each and every service. For now, guys, let's start with the first service, which is AWS EC2, and let's see what is it all about. So guys, Elastic Compute Cloud is nothing but a server. It's a raw server. It's just like a fresh computer that AWS gives to you. So what you basically do is you ask AWS for server, right? And that server service is called EC2. So what you do is you specify the kind of processor that you want, you specify the kind of RAM that you want, and then you click on launch. And what happens after that is you get a server which is basically of that exact configuration. Now what you will have to connect to it remotely. So if it's a Linux machine, you will connect through SSH. If it's a Windows machine, you will connect through RDP, right? And once you connect to it, it'll give you the UI of how an operating system actually is. If you installed it on your local, it'll be exactly the same. It's just that now it has been basically launched on the infrastructure of AWS, and that can be accessed using various tools like the RDP tools or SSH tools. I'm going to discuss more about EC2. I'm going to basically launch an EC2 instance in a moment. But before that, let's discuss all the services which are there in compute, and then we'll do that EC2 demo as well, right? So guys, Elastic Cloud Compute, like I said, it's just like a raw server that is given to you. And on this raw server, you can install anything, you can make it anything, you can basically build it, make it a web server, you can make it a database server, it can be anything, right? That is what EC2 is all about. Now in the diagram, as you can see, you can launch either a single EC2 instance or you can launch multiple EC2 instances. You also have an option of launching, of creating a EC2 instance and then installing some softwares on it, and then you can launch multiple copies of that particular EC2 instance so that you don't have to launch, or you don't have to specify, or you don't have to install all the softwares all over again. You can create multiple copies of the EC2 instance again, right? And at some point of time, if you feel you want to increase the configuration of your system, you can also do that, right? Let's say if my RAM was 8 GB over here and then I want to make it 16 GB, even that is possible in EC2. And that is why the name is Elastic Compute Cloud. Elastic means that you can increase the size of the instance or decrease the size of the instance configuration as and when required, right? So guys, this was about Elastic Compute Cloud, or that is EC2, right? Our next service is Elastic Beanstalk. Now Elastic Beanstalk, guys, is an advanced version of EC2. How is it an advanced version of EC2? In EC2, what you could do was you could just launch a server, right? And then you can install softwares on it. You can make it a database server. You can make it a web server. You can make it anything, right? With Elastic Beanstalk, you get certain restrictions on EC2, and there is a certain amount of automation involved. So what is Elastic Beanstalk exactly? Elastic Beanstalk basically is a web application server, right? You cannot install any other software on it. It is a web application server on which you can upload your website, and you don't have to install any software. You don't have to do anything. Like I said, we talked about what is infrastructure as a service and what is platform as a service, right? So infrastructure as a service is EC2, okay, where you get the whole server, you get the access to the operating system, etc. Elastic Beanstalk is platform as a service. So in this, what you get is a dashboard. You don't get access to the operating system. You don't get access to the softwares that you have to install on that server, right? Everything is pre-configured. All you do is you say that I need a PHP server. It'll launch a PHP server and it'll give you a dashboard where you'll have a upload kind of a button. You click on that upload button and you'll have to put or upload your website over there. So once you have uploaded your website files, they automatically go into the path where they have to go. And all you have to now do is just go to that IP address or the domain name of that particular Elastic Beanstalk instance, and you will be able to access your website. If you compare it with if the same thing you had to do on EC2, you'll have to first install the softwares, then you'll have to upload the file using FTP because there's no dashboard to upload it. So you'll have to download an FTP client, connect to the instance, upload your files like that in that particular folder. And then if you go on to the IP address of the EC2, only then you'll be able to access the website. With Elastic Beanstalk, what they did was, like, if you have a use case where you have to deploy a web application, You don't have to do all that manual stuff of installing the software, of installing or putting your files on the server. All you have to do is you have to open Elastic Beanstalk, select the environment that you want to deploy, and upload your website over there. That's it, right? So it's an automated version of EC2 in which you have certain functionalities of putting a website over there, but there is a limitation that only it can be a web application server, right? It cannot be a backend server for you. Elastic Beanstalk is only used to deploy your websites. Guys, remember that, because the next service of ours is a little different from Elastic Beanstalk, right? And it also has some limitations. Our next service is AWS Lambda. Now, AWS Lambda, again, guys, is an automated version of EC2. It's an advanced version of EC2, but with some restrictions. Now, what are those restrictions? It cannot deploy an application. You cannot upload your website on it, and it cannot host an application for you. What is AWS Lambda? AWS Lambda is basically just used for doing your backend processing. Now, what is backend processing, you might wonder. So let me give you an example. Let's say you have an image processing application. So what do? You have a UI or you have a website through which you can upload an image. And what that website does is it stores the image on its storage, and then it reduces the size of the image, right? And then you can download it again. Now, you might be wondering, this is one website, so ideally everything should be happening on one server in this case. But that is not the case over here, guys. So what happens is your web application is on a separate server. The processing happens on a different server, right? And AWS Lambda specializes in processing. Now, why is AWS Lambda preferred for processing is because when you launch a server, guys, you have to select the configuration that you want, right? You have to select the processor, you have to select the RAM. With AWS Lambda, you don't have to specify any configuration. You don't have to choose what server size should be for my application to cater to the workloads that are coming in. AWS Lambda, what it does is it sees what kind of workload it is being given. It automatically scales up if it has to in terms of its configuration, and then executes all your workload and gives the result to the server, which is the web application server, where it has to give the result on the website. So basically only processing happens on AWS Lambda. Only website deployment happens on Elastic Beanstalk, right? And AWS gave us these two wonderful services so that we can create a distributed kind of an architecture wherein, there is no fault. If there's a fault in one server, it's not like my whole application will go down. I have certain redundancies in place. I have distributed my work among multiple computer nodes so that even if one gets faulty, it's not like my application will go down. We'll discuss more on this as we move along and we talk about auto scaling. But guys, remember this, AWS Lambda is only used to run your background code. AWS Elastic Beanstalk is only used to deploy a web application. EC2 can be used for anything. It's your own private computer. You can install any software, make it a backend server, make it a web application server, make it a database server for that matter. Do anything with it, right? That is what AWS EC2 is. Now, if you see the diagram over here, as you can see that, let's say there's an e-commerce application, right? And that e-commerce application, there's a trigger for basically buying something. Let's say you order a package, right? So when you order a package, what happens on Amazon? That entry is made into the database. So that entry is stored, let's say, in DynamoDB, which is a kind of database in AWS, right? Now what happens? Now, once the data is stored in DynamoDB, you want to do some processing on that data and then go ahead and store it somewhere else, right? So once the data has been stored in DynamoDB, I need the processing to be done. Now, the one way to do it is you do everything on the same server, where basically, let's say my package order confirmation happened on the web application, right? The web application server triggered this particular action that I have, my package order is confirmed. And that's when it issued a command to store the data in DynamoDB. That is all done by my web application server. Now I can also, this server itself can also do the processing for DynamoDB and then store it on Redshift warehouse. But the processing takes a lot of time. And that is the reason I differentiate my processing on a different server, or I make my processing happen on a different server so that there is no overhead on my website so that my website is not becoming slow, irrespective of the fact that what kind of workload is running in my backend, because that workload is being managed by AWS Lambda, right? So my website can be up and running. It will always be available to all the users, irrespective of the fact how huge of processing I have to do, right? So that happens by AWS Lambda. One more thing, guys, one more cool thing about AWS Lambda is that whatever job you give to AWS Lambda, it's not one server which does the job. AWS Lambda takes a job, executes it in one server. If it gets one more job in the meanwhile, what it does is it launches a second server on which that job will be executed. Similarly, if there's a third job which is coming, it will be executed on a third AWS Lambda server. So that's how it works, right? And once the processing is done, it can also give the communication back to the web application, and that's how you get the message that the operation is done. But what you don't understand is how many computers or how many servers are working in the backend, right? So now you know. So AWS Lambda, wrapping up, guys. So AWS Lambda is used for executing a backend code. AWS Elastic Beanstalk is used to deploy a web application. And AWS EC2 is a raw server which you can use to make that server anything, right? It could be a web application, it could be a backend server, it could be a database server, etc. Our next service, guys, is load balancing. Now, what is load balancing basically, and why do we need this kind of a service? Now, guys, I told you that whenever we create a production grade application, we basically deal with distributed computing, right? So when we talk about distributed computing, we also have to talk about redundancies so that my application is highly available. Now, what does that mean? Imagine these three servers are your web application servers. Now, if you just had one, imagine you just had one. In that case, what will happen? If there is any kind of fault in this particular server, my application will go down, right? So what I do, I launch 3 exact copies of that server, right? And what happens in that case is, if this server goes down, my user can view my website on this server. If both these servers goes down, my website can be viewed on this particular server, right? But now you might be wondering, how will the user know which server to go on, right? And that is exactly what Elastic Load Balancer is all about. So Elastic Load Balancer, what it gives you is, it will give you one domain to go on, or it will give you one IP address to hit on. You hit that IP address and Elastic Load Balancer will automatically analyze where to send the requests. So the Elastic Load Balancer constantly keeps a check on all the instances which are running in your cloud environment, and it sees which of them are healthy and which of them are unhealthy. If there is a server which becomes unhealthy, what your load balancer will do is, it will stop routing traffic to that particular server, right? And it'll start routing server to your traffic to other servers. And this is the main job of Elastic Load Balancer, which is to distribute traffic among all the healthy instances which are out there, right? Also, one more important thing over here is, guys, if all the 3 servers are functioning in the healthy state, what will it do in that case? So it will distribute the data equally among all the servers. Now you might be wondering, how will that help? So let's say I just have one server over here with around 16 GB of RAM and let's say an i5 or an i7 processor, right? So it will be able to serve a limited amount of users. Let's say there are 10 people, right? So who are there on the website. Let's say the server will be able to serve 10 people. Now what happens if there are 20 people tomorrow? In that case, you always have to plan ahead and you have to keep more servers in your group, so that, or in your architecture, so that if there is more traffic, my requests can go on the other servers, so that the load is actually decreased on the first server, right? So what load balancer does is, it will never make one server max out on its performance. It will always distribute the traffic equally among all the servers, so that the processing or the overhead on any server does not go up and my application should not become slow, right? Now you might be wondering that how do I constantly keep a check on how much traffic is coming on my website and accordingly deploy servers? So that answer I will give you in my next service, which is AWS Autoscaling. So what is AWS Autoscaling? It automatically scales up the number of servers based on how much traffic is coming onto those servers. Now, how does it do that? You can set a certain threshold. Let's say there are 4 instances which are running on my architecture. So what I can teach autoscaling is that whenever the collective CPU usage goes beyond 80%, launch one more instance in the group. and the load balancer should now route the traffic to the new instance as well, right? So this is what auto scaling is. Similarly, when the CPU usage collectively goes below 40%, let's say, decrease the size of my fleet, decrease the size of my server fleet. So in that case, what I'll do is, at the moment the collective CPU usage goes below 40%, it will decrease the number of instances in your auto scaling group, right? And that's how it works, guys. And the auto scaling service cannot exist alone. It always has to work in conjunction with AWS load balancer. Why? Because if the size of the fleet is increasing, if the size of the fleet is decreasing, there should be an entity on top of it which will distribute the traffic equally among all the instances, right? So if you are making use of auto scaling, you will always make use of AWS load balancer. On the other hand, you can just make use of AWS load balancer and you might not want to use auto scaling. That is fine. But if you're using auto scaling, you absolutely have to use a load balancer for your traffic routing. All right. So this is what auto scaling is, guys. Our next service is Elastic Container Registry. Now, what is Elastic Container Registry? For this, guys, you have to know what Docker is, right? So if I have to give you a brief about what Docker is basically a tool using which you can launch operating systems in the minimum size possible. So the minimum container size that I know of is 40 MB. So what you can do is, let's say we were talking about distributed computing, right? So in distributed computing, what happens is each of your server plays a different part in your application, right? So similarly, what we can do is we can launch containers. Now what containers do is they act as a virtual server, right? But they take the minimum resources possible. They take minimum space possible. Like I said, 40 MB is the size of a container which holds an operating system, right? So in those containers, you can deploy applications, okay? And these applications then run as if they were running on a separate server. They are isolated from the operating system on which the container is running. I'm sorry, guys, if I cannot go in depth of what Docker is right now because it's altogether a separate topic, but you can understand it like this, that it's basically a mini virtual computer that you can run in your system. And ECR service, basically what it does is it stores these containers in a repository. Like you have GitHub for storing code, you have ECR for storing your container images, right? For example, like I said, operating system 40 MB size, the image has to be stored somewhere, so it will be stored in ECR. Now, if you want to run those images, you have a service called ECS. So what ECS does is it runs any Docker image on the AWS infrastructure, right? And it orchestrates it in a way so that if there is anything wrong with that container service can again be launched. Now, don't get confused, guys, with what we do in EC2. Now, you might have a question that I can launch multiple EC2 instances. In spite of that, why don't I launch just multiple containers? Because in that case, what will happen is you're still the machine on which the containers are running. That becomes node point of failure. That means if there is anything wrong with that machine, any number of containers which are running on your particular system will go down, right? So this is also a redundancy that you can make in your architecture, that you can also run applications on containers which are running on an auto-scaling infrastructure, that is a machine on which Docker is running. But if the processing or if the CPU gets an overhead and the CPU processing increases, you can scale your machines and you can scale your containers as well, right? So if it's a little complex for you guys, you can just ignore this service, which is ECR and ECS. It's only for those guys who understand what Docker is. So guys, ECR is nothing but it's a repository on which you can store container images, and ECS is nothing but a service to run your Docker containers. If you don't know, guys, what Docker is, I'll just give you guys a link after this class. It's basically a video for introduction to Docker. It's a half an hour, 45 minutes video. You go through that, and then again you can go through this recording wherein you can find a description for what ECR and ECS is, and that'll make more sense to you in that case. All right. So guys, we have discussed ECR, we have discussed ECS.
Let's say you are creating an instance, and the instance in AWS is known as a virtual machine. So we are considering that you have AWS free tier account, and every AWS free tier account has limitations. Means AWS provide you a platform to just practice to see how you could use actually AWS platform with some limitations, of course, right? So those services will have some quota if you're using under the free tier account. So we have different plans in AWS. If you work in a production environment for companies, we have a different plan. But here we are just learner. We are a simple learner. We are not using AWS platform for a professional service. We want to learn it right now. So it means we are using only free tier account. Correct or not? So if you see this diagram, let's say this is an EC2 instance. An EC2 instance will have major 5 components. The first is AMI. AMI is a kind of template of the machine to create virtual machine. So you are not using any CD drive here. You are not using any pen drive here. You will have only template of operating system, which is known as AMI, Amazon Machine Image, right? So we'll talk about all these terms in detail in EC2 service. Or to create your machine is AMI, Amazon Machine Image, number 1. It's a template of a machine, right? A template of an operating system. Second is the configuration of instance is needed. What is the configuration? Because every virtual machine will have its own configuration, means how many RAM as well as how much virtual CPUs are required to run the machine. So you can give the compute resources. So that comes under instance type, or you can say it's the configuration of the virtual machine, correct? Third is EBS block. And every virtual machine must have a hard disk, right? But here we will not say it as a hard disk. We'll say it as the EBS volume, elastic block storage. So this elastic block storage is a block device, and we will install operating system on the top of EBS, elastic block storage, right? So where your operating system is launched in EBS. So the first component of the EC2 instance is AMI. Second is instance type or configuration. Third is EBS. And the fourth is security group. Do you see the fourth security group? What is a security group? Security group is an external firewall, which allows to filter incoming as well as outgoing traffic. Means if you want to filter incoming or outgoing traffic to machine, you could use this, security group. And security group is a external firewall, and it's a mandatory. Without security group, you cannot launch the instance. Correct? So these are few terms that you should understand. Okay, right, on board. Yeah, so I'm using Miro, right? So guys, very important. Let's say this is your instance, right? This is the instance. In this instance, the first thing you require is AMI. Second thing you require actually EBS volume, right? And third thing that you need to add it, which is known as security group. Okay, this is the security group, right? We'll see later on. Next is, let's say I'm just giving you a simple diagram. Let's say you have an internet, right? Let's say this is the internet. Where is gone the internet? Analytical AWS. This is your, let me show you. So this is the internet, right? This is the internet, and this internet, and we have a user, right? We have a user. Where is the user? This is the user. And user will access this machine from the internet, right? This is the user. You please see very carefully. So this is the EC2 instance. This is your EC2 instance. And this EC2 instance has one AMI. This is the EBS block, right? And this is the security group, correct? This is the security group, and this is the internet. The security group is connected with the EC2 instance, and this is also connected with internet. And internet is connected, so user is connected through the internet, right? So you can access the machine through the internet. Very interesting. So guys, this is a security group. What is a security group? Firewall, external firewall. Security group is an external firewall, right? And we have an AMI. AMI stands for Amazon Machine Image, right? And this is a kind of a template of operating system. Operating system, correct? So this is your AMI, and this is your EBS volume. EBS volume. So you can consider it as hard disk drive, right? EBS volume. So you can see this is the block storage. So you install your operating system in EBS volume. So this is the second component. So all these are the mandatory components, right? And every EC2 instance will have configuration of the machine, instance type, which can be known as configuration of the instance, right? Configuration of the instance. Yeah. So we have to create this one. Okay. Here the user, and the user will access this machine. So I'll tell you later on the method of accessing this EC2 instance. So right now I'm just going to create a Linux image or Linux machine, and then later on I'll just start, I'll create one Windows instance. Okay guys, so you go there and just write here AWS Amazon.com. Please do write aws.amazon.com if you already have your AWS free account with you, and press enter. As you press enter, what happens? You just go to my account right inside. You have my account. Over to this my account and click on AWS Management Console. As you click on AWS Management Console, so this sign-in screen will appear. So you will log in as a root user because you have an only default root user as of now. And you will write your registered email ID here. Press next. And at this time, it is asking you to just write this these characters in this image, right? And guys, now you need to provide the password for this login, right? Let me, so there's the password, of course. I'm fast, Elvis. I'm really slow, very, very slow. So not an issue. And MFA, maybe in your case, you will not see MFA. MFA stands for multi-factor authentication. This is an additional layer of security. But in my account, MFA is configured. And that's why I just read that MFA code from my mobile application. And I have to type MFA. Right. Yeah, MFA is an additional layer of security. It's not a VPN. Because your registered gadget or mobile will get a kind of actually rotating code. That code you will read from your mobile and type it here, because you have a match between your or the link between your account and your mobile. So by the way, AWS Management Console is open. So this is the very first screen when you log in into your account. So this is the very first screen you would see, called AWS Management Console. So this is a graphical intuitive interface through the browser you could see, right? So it's called the AWS Management Console. And you can see, so right now you logged in your AWS Management Console. So this is the very first screen when you log into your account, you would see this screen. So without any effort, I'm not explaining actually technically, but if you see, this is the very first screen. and you can scroll down in the list of services, all services. We have the group of services, like the compute is a group of service. So EC2, Lightsail, Lambda, Patch, Elastic, Beanstalk, all these are the services. However, in the containers, we have the services. What is a container? Is a group of service. In storage, what is a storage? It's a group of service. Under the storage, we have S3, EFS, FSX. So these are the services in storage. So similarly, we have the number of groups, and that one particular group can have multiple services. Okay, that we'll discuss about later on. It's not a big thing. But what exactly I want to do right now, I want to create an EC2 instance here, right? EC2 instance is what? EC2 instance is a virtual machine. So you are going to create a virtual machine in AWS, very fast virtual machine. So I'm not going to explain about the EC2 instance service. I'm not going to talk about the service. I'm just simply telling you with the minimum effort how you could manage or launch your EC2 instance, right? So go and click on EC2. EC2 stands for Elastic Compute Cloud. So we'll talk about in detail about this service, EC2, right? So this is the EC2 dashboard. As you click on, again, I'm coming here. So I was here in all services.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Either you can just click on EC2, or here in this search box, you can write EC2 only. As you write EC2, you will have EC2 service in front of you. Correct or not? So simply just click on EC2. Right. Deleting. Terminating means permanently deleting these machines. Right. So guys, you could see that now these both machines are now terminated, right? So very first step. So we are in this EC2 dashboard. Okay, if you just click on EC2, you will be on this EC2 dashboard. And now you are going to launch a new.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Instance with the minimum effort. So I'm not going to explain all these technical terms you would see during the configuration. So please just follow actually the steps, because the details I'll tell you in EC2 service. So what you will do, you will click on launch instance. You are going to launch your instance. So as you click on a launch instance, you are in a step 1, right? So in a step 1, you are going to choose Amazon machine image. As I told you that if you see the diagram, so this is the Amazon machine image. In a very first step, you would select Amazon machine image, right? So you would select. So we have a number of instance. If you see, we have a long list of instance types, but dear, please see the first one. So why I'm selecting this one, why I'm not selecting this one, all these questions definitely I'll answer you when we will study this service in detail, right? So by the way, I'm taking a very first instance type. We are taking a very first image, and this is your Linux image, right? I'm taking the first image. You know that image is required to launch the machine. Without image, you cannot launch the machine. It is a mandatory part. So you selected one AMI. Now you are in a step 2. So you would select an instance type. What is an instance type? Instance type is a configuration of the machine. So I want to add one more thing here. I will explain you about the families of instance type, about the different instance type configuration. But because you are using AWS free tier account, just please keep one thing in your mind. You have only this t2.micro configuration available free of cost for you. Means, and other configurations are not free of cost. Of course, you can choose other configuration even, but those configurations will not be free. You will pay for those resources. So t2.micro, you will have free of cost. And if you are choosing the t2.micro, it is very clearly written down here, means free tier eligible. And under this, you will have one virtual CPU and 1 GB RAM. And I'll explain what is a virtual CPU, what is a core of the CPU, that I'll just tell you. But if you're choosing t2.micro instance type, which is free of cost under the free tier eligible account, you will have only one virtual CPU and 1 GB RAM. So will it be sufficient for my machine to have a 1 GB RAM to launch a machine? I'll say yes, of course, it is more than sufficient, because we have a server-based infrastructure in AWS data center. So this one virtual CPU and 1 GB RAM is sufficient, correct? So go and configure next instance. So guys, so this is the configure instance detail. So this is the third screen. Third screen basically responsible to place your machine. So I'll tell you about how many regions we have, what are the availability zone, edge location, global infrastructure, because you are very new for this, but you must have some hands-on. And literally, I'll cover everything. Means I'll explain you about global infrastructure of AWS, but we are not touching right now. So we'll not make any changes in this step 3. So in this step 3, the configure instance detail, you are just going to create only one machine. You are taking a default VPC. VPC is a kind of a network in which you are launching this instance, and you are taking any random availability zone, but this machine will have public IP address. If your machine has no public IP address, you won't be able to take the remote of that machine from the internet. So every machine, if you want to access over the internet, must have public IP address, right? So this machine must have a public IP address if you want to take the remote of the machine from the internet, or you want to access the machine from the internet. So this machine has enabled public IP address, correct? Now, right bottom, you have add storage option. You will click on add storage. So right now you are in step 4, right? And you are being asked to add the storage. Means you are being asked to add EBS volume. So you are going to add EBS volume with your EC2 instance. What is an EBS volume? EBS volume is a block storage, and it will act as a hard disk with your EC2 instance. So what is the configuration type of this EBS volume? What is the volume type? And what is the different kind of the features we have? So we will discuss everything in detail in EC2 service. But right now we are taking the default setting. In the default setting, you please remember only the 8 GB volume is taken for this operating system. And because you are using the free tier, up to 30 GB volume can be taken. Means the one volume size could go up to 30 GB. You should not exceed more than 30 GB because you are using free tier eligible account, right? So if you're using the free tier eligible account, you should not exceed more than 30 GB. And because you are using Linux, you are launching Linux instance, and according to AWS for this Linux instance, 8 GB is sufficient. So we are happy. So means we are not changing anything here. We are saying that the 8 GB is okay, then it's okay. So we are taking an 8 GB volume to launch a machine. Okay. Later on, if you want to change the volume size, you can change the size of the volume. By the way, I'm not making any changes here. Add storage. Done. Now add tag. What is the tagging? tagging is a kind of method to tag your resources, to name your resources for auditing purposes, to maintain the inventory of your resources. The tagging is really important to your resources, right? So one resource can have multiple tags. So let's say, so you want to give the name of this machine. So you'll give the add tag. You just write the key. Let's say the key is name, and I'm giving the name of the machine. Let's say Linux demo. Linux demo. Okay, so this is Linux demo machine. And right bottom, we have configure security group. What is a security group? Security group is a kind of external firewall that you would connect with your EC2 instance. And without security group, you cannot launch your EC2 instance. Correct? So guys, you would select actually this one. And because you are using Linux instance here, it's saying that automatically the port number 22 from the internet from anywhere is allowed. SSH. So you can use SSH protocol to take the remote of the Linux machine. And it uses port number 22. It's great. So it means the port number 22 is opened. Very great. And if you want to ping this machine from the internet, you must allow one more protocol that is called the ICMP for IPv4. ICMP for IPv4. You can just add a rule here. One more rule you can add. You go and select all ICMP IPv4, right? All ICMP IPv4. And you would see in the source, just select from anywhere. So what this ICMP will do, it will allow to ping your machine. If this rule is not written in the security group, nobody can ping your machine, or your machine will not give the response of the ping command. But once this rule is added, now your machine will give the response of ping command. So you did download actually 15th May key here. So now, and this key is in a PAM format, correct? And finally, you can launch the instance here and just scroll down, and you would see in a few minutes, the machine will be launched. Right. So this is the machine, Linux demo, correct or not? And this is the public IP address. This is the public IP address of the machine, right? 3.85.120.52, and this is the private IP address. So this machine have two IP addresses. One is for private and another is public. So guys, I can also tell you, like, you just open the CMD. You can open the CMD, right? And here you can write ping. Okay, so this is the one thing. And how to take the remote of this machine. So today I'm going to tell you only the fast method. And you could use actually AWS Management Console direct connect. So means you can use a connect button. We have a connect button here. Right now, we are in AWS Management Console. You are the owner of AWS Management Console. You successfully logged into your AWS Management Console. You could see that we have an instance Linux demo here. And once you select this instance here, so you click on this connect button. Do you see the connect button here? Yeah. So we will click on this connect. We'll click on this connect. As you click on this connect, the second screen will appear. In the second screen, you should be an instance connect. You should be an EC2 instance connect, right? And here, this is the EC2 user. So this is the EC2 user of this, the user of this EC2 instance. And this user basically they came from AMI image. I'll tell you later from where it basically came. And you can just modify also in later stage. But right now, EC2 user is a username of your machine. And you just simply click on connect. As you simply click on connect, if everything is okay, you would see that you successfully took the remote of this machine, right? Correct or not? So now you are inside of this EC2 instance. In Linux machine, you are inside of your Linux machine. Correct or not? So this was pretty simple actually. This was pretty simple. So how many EC2 instances we have? We have one EC2 instance, right? We have a one EC2 instance. So this is the EC2 instance is running that you have created today. This one, right? So in a quick view, can I tell you how to create a Windows machine and how you can take the remote of the Windows machine? Yes or no? And I didn't stop this machine, let it be as it is. So I'm going to start and launch a new machine, but this time not a Linux machine. This time I'm launching a Windows machine. So click on launch instance. So this is the first step. So this is the first step. So you are watching, you will select only the free tier eligible, but this time Windows instance. Scroll down, scroll down, scroll down, scroll down, scroll down. So you can take this one. This is a free tier eligible. 2019, you can take this one. Okay, you can also take this one, 20HR Cobase. You can take this one. So I'm taking this Windows 2016 server, right? So this machine I'm taking. This image, not machine, this image I'm taking. AMI. AMI stands for Amazon Machine Image or template of the machine I'm taking. And this is free tier eligible. You click on select. This time I'm launching a Windows 2016 server. And there we have only one option for instance type configuration. That is T2.micro, which will have one virtual CPU and 1 GB RAM. We have no other option to select free of cost. Okay, so I'm taking this T2.micro. Just click on configure instance detail. And please don't make any changes in step 3. Let it be as it is. Correct? On a step 3, you'll not make any change. Let it be as it is. Go and add storage. And this time, instead of 8 GB, you would see the size is 30 GB because you are launching Windows operating system instead of Linux operating system. And Windows operating system does take quite more space as compared to Linux, right? So the Linux is 30 GB, and this is the ultimate limit to use maximum space, 30 GB. You cannot use more than 30 GB because you are using free tier eligible or free tier account. So 30 GB is okay for my EC2 instance. For this Linux instance, sorry, this Windows instance. Go and tab. You want to give the tab of your tag of your instance, tag to your instance. Let's say I'm just writing the name, and this time I'm writing Windows 2016 server. Great. And just click on security group. What is a security group? Security group is an external firewall. This time, automatically RDP was chosen, and we are using 3389. This is the port number for the RDP. Because if you are taking a remote of your Windows machine, you will use RDP protocol. And RDP using 3389 port number. And it is from anywhere, right? Anywhere means from anywhere from over the internet. And you want to write ICMP. If you want to open ICMP to ping your instance, you could choose this from anywhere, ICMP, and that's all. The 2 rules are enough. And you are launching the instance, and finally you can launch the instance. And you're going to use the same key that you have used with the Linux instance. The same key can be used with the multiple instances. So instead of creating a new key again, you can just go and just see existing key pair. What was the key name you just created? 15th May key, right? 15th May key. I acknowledge the term and launch the instance. I acknowledge the term and launch the instance. And you would see that this instance is almost done, right? So this is the instance. So this is the instance. So this would take another few minutes to launch. And I'll tell you how to take the remote of this instance. It's a little tricky. And the same, I'll be using the connect command once it is done, right? And I have a key to actually decrypt the password. You would use actually that private key for your Linux machine, correct? So the machine is done. So this is the Windows machine. Do you see the Windows machine? And this is the public IP address of the machine. And this is the private IP address of the machine, right? So what you will do, you first of all select the machine, select the instance. I'm talking sometimes about, means I'm saying sometimes machine and EC2 instance, both are same, or virtual machine. So all these are basically the different terms people are using. But if I'm saying the machine, it's an EC2 instance, right? So 2016 server, and just go to connect. And here we have the session, we have an RDP for what you want to do. So RDP client, yes, I want to take an RDP connection of this Windows server. So, but Windows server needs password, right? So first of all, you need to decrypt the password. So you will retrieve the password from the private key. So you click the private get password. The password is not available. Great. Why the password is not available? The machine is not yet, I think this is done. Okay. Get the password. So this is taking time. So we should give some time to this machine to launch. It is not yet completed. I can see it is being initialized, right? So it is not yet ready to take the remote. So we should give some time to this Windows machine. Actually, Linux is really fast enough as compared to Windows. So Linux doesn't take much time to launch the instance. But if you're talking about the Windows instance could take a few minutes to launch, right? It is not yet completed. It is still initializing, right? Let me try once again. I'm selecting this instance type, go to the connect, right? Go to the connect, go to the RDP, get the password. Yeah, get the password this time. You can see, you can choose your key. So browse the key, and where was the key that you have stored? The key was 15th May key.pem. Open it, and you could decrypt the password. So this is the password, right? This is the password of your Windows instance. You can choose this password. And now we have this download remote desktop file. Either you can directly use the RDP of from your machine, or you could download this RDP. You did download this RDP. This is for the Windows machine, right? And just open it. As you open it, you go and connect. You will provide the password of this machine here. You will provide the password of this machine here and press OK. As you press OK and press yes, it could take a few minutes time to show you the screen of Windows. But even though it's really fast, because you are running this Windows instance on one virtual CPU and 1 GB RAM. So you would see this machine is working. If you are using Mac, Akanksha, if you are using Mac, for Mac, you can download RDP application on your Mac machine, right? Windows RDP application, you can search Windows RDP application and you can download on your machine. You can use that application to take the remote of Windows or RDP, correct? So guys, this was easy, right? So I'm just closing this Windows machine, and this is the first screen, right? So we have the two running machines in my account. So I should not leave them like this. So I will select these machines, right? To stop these instances, first of all, you select these instances, go to the instance state and just click on stop. Do not terminate instance. If you will terminate instance, means you are deleting them permanently. So you are stopping the instances and you can stop the instance, right? Now, right. Let's say this is the EC2 instance, right? So I'm EC2 instance. Can I start this EC2 instance like this? Instance. Wow. This is of course is instance. So I can just create like this. This is the EC2 instance, right? So I can write, this is your virtual machine, EC2 instance. Great. So once you have this EC2 instance, so how you would take the remote of this instance, that I will try to explain you. Like you have a user, so you can use actually MobX term. It's a terminal emulation tools. So you can use a terminal emulation. You can use terminal emulation tool. You know what is the name of the terminal emulation tool? Just like PuTTY or MobX term, right? MobX term or PuTTY. These are terminal emulation tool. I can say PuTTY. So these two are the popular two. We have the Git bash also, right? So by the way, we are taking the MobX term and the PuTTY. You can use these tools to take the remote. Secondly, if you are working on a Linux machine, let's say you already have a Linux machine. Let's say this is a client machine, right? This is your Linux client machine. This is your Linux client machine, right? And the user is sitting here. So directly from the client machine, you can take the remote of this EC2 instance. So you can use a command line interface. You can use a command line interface and use CLI to take remote. Perfect. Very simple. Secondly, the PuTTY is what? The PuTTY, I was telling that the PuTTY is terminal emulations tool. You can use this PuTTY, or you can also use MobX term, right? Or if you have a Windows machine with you, if you have a Windows machine and you want to take the remote of this EC2 instance from the Windows machine, so let's say this is the Linux instance, right? EC2, I can specify, it will be easier for you, right? And let me just define this is a Windows. Windows host machine. Host machine. So your laptop is a Windows host machine, correct? So if you want to take the remote of this Linux instance from your Windows operating system, so you can definitely use a PowerShell here, right? So you can use a PowerShell, Windows PowerShell. Interesting. You can use the PowerShell to take the remote of this Linux machine. So I think these are some standard methods. So this is the Windows Linux machine. You can take a remote from the Linux machine. You're going to take off remote from Windows machine. You're going to take the remote using PuTTY, and you can take the remote using MobX term, right? This is great. So if you have any other method, and directly through AWS Management Console can be taken. If you're working on AWS Management Console, so using AWS Management Console, you can take the remote of this EC2 instance directly. So you have various methods. And if you're using AWS Management Console, you don't require actually any key, right? By the way, in other cases, you require key. So I can just write here, key. Yeah, the key is needed. What is this? This is the private key, correct? So the private key is needed. I'm coming on that. So you need a private key here. You need a private key. In case of MobXterm, you need a private key. In case of PuTTY, you need a private key. In case of Linux machine, definitely you need a private key here. Then only you will be able to take the remote of this machine. Even in case of the Windows machine, you need a this private key, right? But you don't need private key in case of AWS Management Console because you are already logged in as an administrator, or you have a privilege to actually manage machines, so you can directly take the remote of EC2 instances. And you do not provide actually this credentials of your AWS Management Console to any users. So your user could be on remote location, and if user trying to access the machine from the remote location, he must have or she must have this private key, right? So in case of MobXterm, the private key is needed, and the private key format is .pem format, right? Format. So private key in PEM format, in .pem format is required. This is interesting, right? So I'm just trying to just brief you so that you can understand. So the private key in .pem format is needed, and by default, when you create a private key in AWS, it does create in the .pem format. But interesting thing is, you do not use actually, or the PuTTY does not support to PEM format, right? I have no idea because Dhruv, it is related to cryptography actually. So what is the full name of the extension? You can just Google it, but it pertaining to the cryptography, right? So PuTTY needs a private key, but the PuTTY does not support PEM key. You need a private key in .ppk format. Wow. So this is interesting. You need a key this time in a PPK format. So in PuTTY, you need a key in a PPK format. But if you have the key already, you have the key in PEM format, so you have some tools to convert the key. So you want to convert, definitely you can convert, right?
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Yeah, this is second method. You can use a Linux machine. So right now we don't have the Linux machine, but definitely internally from another EC2 instance you can take. So this is third method, and this is your fourth method. Just a minute. Okay. Fourth. Right. And let me see. This is the fifth method. Will it work? I think now these are clear. But while you're using a PuTTY, you would change actually the .pem format into PPK format, right? Let's say you had the PEM format file. So you have a privilege to change. You have actually tools to change into .pem format, PPK format, PPK format. So you can just change actually from one format to another format, right? That can be changed, and for that you need some tools. And if you're using Putty, you're going to easily use all such tools, right? So guys, these are the few things, and we'll try to attend them practically. So will it be okay? I think this diagram is pretty clear to you. So I just tried to explain. So first of all, you must have an EC2 instance, right? So we are going back, and first of all, we are starting. We are logging into our account, right? We log into our account. Where is it gone? Where is it gone? Yeah, I was just looking for the username and password. Yeah, this is AWS Management Console. And it's better to write in chat. Only I can see. Don't use any other method like, so if you have a query, if you have a question, please do write on chat, right? So this is your AWS Management Console, and you will use EC2 dashboard. Just open the EC2 dashboard and see, do we have any instance? Yeah, we have number of instances. So this is the instance we have. So we are running with this instance. So let's say we're going to say this is the VM1, right? And this VM is, of course, is running, and you want to take the remote of this VM, right? So now to take the remote of this VM, to take the remote of this VM, you must have the private key with you, right? So you go to the security, and under the security, not the security, let me see, right? Yeah. In details tab, we have instance details. Within the details, we have instance detail. If you open it, you will find the name of the key pair. Key pair name is 15 May key. Can you see the key name here? 15 May key. So guys, this is the instance, right? The instance name is Linux server. This is the public IP address of the instance. And this is instance detail. And this is the key pair name, 16th May key. So these three informations are needed. And especially we needed two information, the IP address as well as this key pair name, right? And first of all, according to this diagram, so I'll be using a MobX term. First of all, AWS Management Console. You go and select the machine, select the instance, and go to the connect. So you have a connect button on this EC2 dashboard. And as you connect, you would see that under the EC2 connect option, we have a different option like the session manager, SSH client, EC2 serial console, but we are talking about the EC2 instance connect. So this is the instance ID, right? This is the instance ID. And this is the public IP address of the instance. And this is the user name of the within the instance, EC2-user. This was not given by you. Actually, you had used this AMI. So within the AMI, the user was defined, EC2 user. And as you click on connect, you would see without using that private key, you took the remote of this instance easily. Why? Because you were inside your AWS Management Console. You had already the credentials to access the resources which were running within the AWS Management Console. So that's why you were able to take the remote of this machine without the private key. So if you are using AWS Management Console, you don't require a private key to take the remote. Right? Okay. So, and a second method is we are just coming back. Go to the instances. And in second method, I'm just going to use a PowerShell. And at the time when I configured the key, I'd already downloaded the key. What was the key name? 16 May, right? So I already downloaded the key, and now I'm going to use PowerShell to take the remote of this instance. So you can just go there. See, you can just write PowerShell, right? So very first of all, I want to in the same directory where the file is, where the private key is installed or downloaded. cd dot, you can download, right? So you are here and just write directory. What was the key name? 16th May key, right? Is it here? Yeah. So this is the key you already have. Right? So you have the key in this downloads. So what you will do, you will write SSH -i, right? -i 16 May. So SSH is a command, take the remote of your Linux machine, -i to insert the key. The key name is 16 May key.pem, and you are using // to provide the path because you are in the same path. Secondly, username, EC2-user. So this is the user name of the instance. You are using the username EC2-user. And what is the public IP address of the instance? The public IP address of the instance is 18, right? So you would write here, this is the public IP address, 18.212.75.190. So this is your public IP address of the instance you want to take the remote. So this command is absolutely correct and complete. Did you see the command? The command is clear or not, guys? If the command has a proper information, correct information, if you hit enter, you can take the remote of this machine successfully. And you are taking the remote of this Linux machine from your Windows PowerShell prompt and press enter. As you press enter, it will ask you to say yes, okay, and see. Wow. Could you see that? Now you are in a Linux, you are inside a Linux machine. You took the remote of the Linux instance from your laptop, from your laptop's PowerShell. Correct? Yeah. So guys, this was the second method. Now I'll talk about the third method. And in third method, you need a MobXterm tool. What you will do, first of all, you will download the MobXterm. To download the MobXterm, you can just write download MobXterm for Windows, right? So this is the link we have, right? So you have two different kind of flavors of this application. One is a portable edition and there is an installer edition. So you would select a portable edition. It's a light in weight, right? So you would use the portable edition. Correct or not? That's all. So you just click and you will download one .exe file. So once you download that exe file, you can store that exe file somewhere in your directory. Like I'd use this MobXterm. Yeah, so this is a directory and this is the file we have. Right. So you can use this file. If you double click on this, the MobXterm will be open. If you double click on MobXterm exe file, so this application will be open, right? So you just click on session, left hand side, and the top and left hand side, we have an option session, right? You click on session here. Right now, we do not have any session. You need to create a session using a particular protocol. So what protocol you will use to take the remote of the Linux machine? Do you have some idea? So what protocol we should choose to take the remote of Linux machine? SSH. Where's the link? Link has been shared. Again, the link and you will write the public IP address in the host, remote host. So you will write the public IP address of the instance. You go back and just select the public IP address of the instance. So this is the instance. You go to the detail and just select the public IP address of the instance and just simply paste the public IP address of the instance and specify the username. What was the username of this instance? EC2 hyphen user, no spelling mistake. And as you know that Linux is case sensitive, so please understand that you should write everything in small or everything in right as it is, right? So you will not change the cases of characters. So I'm writing EC2 hyphen user, and it is using the port number 22. Let it be as it is. And here you will write, you will click on advanced SSH setting. And in this, if this option is open, you're going to see the last line in these options, use a private key, use private key, right? You will select this and select the private key of this instance. So what is the private key of this instance? May key.pem, the 16th May key.pem, and you can just click on open, right? So you selected the path where that private key was stored in your computer and just click on OK. As you click on OK and everything was correct, you're going to take the remote of this machine successfully. So you took the remote of this instance successfully. Did you see that? So I can see. Now it took the remote of this instance using mobexterm. Was it difficult or simple? So it was simple, right? So we close the session. Now it's time to use another method, putty. But if you are using a putty, you must have a private key in .ppk format.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
But right now, the PEM key we have available in my computer is in .pem format. So you have to convert first of all, that PEM key into the PPK format, right? So you just go, I downloaded the putty. I have a putty in my computer. So I told you these are the terminal emulation tools, and you can take the remote of these tools. You can use these tools to take the remote of this EC2 instance. So, and for that, either you can use RDP or SSH. So mobexterm is using, basically, it's a very complex tool. So we are using only SSH to take the EC2 Linux instance remote, right? But we have other options too. Within this mobexterm, it's a very big software. That's why I'm saying it's a terminal emulation software. So this terminal emulation software can work on various protocols. But here I want to use only mobexterm for SSH protocol. So that's why I'm just restricting its use for a specific purpose, right? So you can download, first of all, putty. You can download the putty.org, first of all. So once you download the putty, let me tell you, we have a putty. Let's say this is the putty. I downloaded in a folder, and it's very easy. You can go and just check the putty.org. You can check this putty.org. You can download the putty tool. It's available free of cost. There is no license issue. So you can download the putty. Putty is quite popular. Companies are managing those tools because they find the putty is safe and it's recognizable through their firewalls, application firewalls, they using putty. Okay, so guys, first of all, I want to convert that PEM file into PPK format. I'm converting one format file to another format in a support format. So you can just go and puttygen. We have a puttygen here. Very last option, very last file in the list, puttygen. You double click on a puttygen, and in this, we will load the key. We have generate and we have load. we will not generate the key. We already have the key. We want to convert its format. So first of all, we will load the key. And we will use the key. The key is in PAM format. So you will change actually the extension. You will take all extension files. And this is the key you want to change. 16th May key.pam, and you will open it. As you click on open, so you saw that this particular PAM file has been loaded in putty key generator. And you have two options here, save public key and save private key. So this is the private key with you, right? So this was the private key. So you will choose the save. You will click on private key, right? And what was the key name? Sorry. So of course you will take all keys. The key name was actually the 16 May key.pam, but the extension should be this time ppk instead of pam. So initial name will remain same, but after dot you will write ppk, not pam. You will change the extension of the file, you will save, and it is done. Wow, it is done. But if you want to confirm it is done or not, you go to the downloads and you would see that this the 16th May key.ppk format you have. Earlier we had a PAM format file, and now you have changed file ppk, right? To work with the putty, now we have a ppk file. Great. So what you will do, you'll go back to again putty, right? And you will open the putty.exe. So this is the terminal, right? And you will give the actually the information about your machine, just like in a public IP address. So here you must have, you will type the public IP address of the instance. So you go back to your instance, and this is the public IP address of the instance. You copy the public IP address of the instance, go back and just paste that public IP address here, right? And please check we are using port number 22. And now left hand side in this, we have connection. Under the connection, we have data. You click on data, right? And here, right hand side on the top, the auto login username. So your login name must be EC2-user, right? So you will write the name of the user, EC2-user, right? So in SSH, if you just open SSH here, left hand side. So in SSH, we have auth, right? AUTH. Click on auth. And now right hand side bottom, you have a browse option. You will select the browse option to select the PPK file. So click on browse, and this is the PPK file you had, right? So you have this PPK file, 16th May key.ppk. So select the right, absolutely correct key type, open, and just simply just click on open. If everything is okay, you will be able to take the remote of this machine successfully. Did you? So guys, according to this, now we cleared 1, 2, 3, 4 methods. And if you working on a Linux machine, directly you can just type the same SSH command to take the remote. Wow. No, even the updated version will work. There is no such restrictions, right? We are using the updated version. I don't understand. So what operating system you are using? Travesty. So what operating system are you using in your host machine? Okay. Now, the next topic of the day is virtualization. What is a virtualization? Virtualization is a technology, is a kind of a technique to create a virtual machine on the top of your hardware layer, right? So this way you better utilize your hardware resources. You can minimize the wastage of your hardware. Okay, I'll tell you that what is the wastage and how you would choose actually, how you can utilize your hardware efficiently using this technology, virtualization, right? So one thing is very clear. So virtualization is a kind of a technology or you can say the virtual machine is a software computer-based machine. And the virtual server operates at multi-tenant environment, means that multiple virtual machines run on the same physical hardware. In this case, the computer resources, or you can compute resources of the physical servers are virtualized, and you can use them in a better way. I tell you, so you would better understand if I'm just trying to explain you with the help of drawing. So infrastructure, or you can say virtualization, without virtualization. Server without virtualization, right? So let me take this one, the server without virtualization. So if you are using traditional method, so without virtualization means you are using traditional method, right? And you can say that this is your server. Let's say this is your blade server, right? This is your blade server, and on the top of this, you have one operating system, right? And on the top of this, you have an operating system. You have this operating system, and on top of this, you have some applications running on this. So let's say these are applications, right? You could say that these are the applications. Wow. So these are the applications. Right. So I can say that this is the bottommost is a bare metal. It's a bare metal, or you can say this is physical server. Physical server. Right. This is the physical server. This is a bare metal or physical server. And on the top of this physical server, you have an operating system, right? You have an operating system. This could be Linux, this could be Windows, but this is an operating system, right? This is an operating system. So this is basically the traditional method. And on the top of this, if you can launch multiple applications here. Applications are running on the top of this. Great. So what exactly I want to tell you here, if you see the performance of such infrastructure, you will find the waste is very high. If you see the bare metal physical machine configuration, so I'm taking a configuration, for example, this machine has, let's say, 16 core, okay, 16 core CPU. So 16 core CPU usually have 32 virtual CPUs, right? Virtual CPU. So one core is equal to 2 virtual CPUs. This is a kind of formula. And let's say you have the 64 GB RAM in this machine. So this is the configuration you have, right? You have the configuration of this machine. And if you see the performance of this machine, if you measure the performance of the machine, once it is launched, once it is configured, once the applications are running on the top of this physical infrastructure, one thing is there, how many machines you have on this bare metal? How many total number of machines we have? How many servers we have on the top of this bare metal physical server? We have only one server, right? And we have one server, and you could see that we have one server, and this one server is using 32 virtual CPU and 64 GB RAM. And it is not possible to consume entire resources by one server. And if you see the performance of the server, you would see that almost 80 to 90% of the CPU is being not used, and 40 to 60% the RAM is not being used. You would see these are the wastage you had in this infrastructure. Leave it about this. You just talk about my laptop right now, it's working on, right? So I'm working on my laptop, and I want to show you how much resources are free and how much resources we could have used, right? So let's say I have number of we have number of actually the applications running on my machine. But if you try to see, if you try to just let me show you the task manager of this machine. Yeah, so this is the task manager of my machine. You could see I'm lavishly using my resources, right? And for last 3-4 weeks, I didn't stop my machine. It is continuously running, even if some backend applications are running. So even then, you could see that only the 70 to 20% of the CPU is being used. And if you see the disk is used 1%, and the memory, almost 50% of the memory is being used. Right. So this is not a server infrastructure. I'm talking about, this is my laptop infrastructure. So this is not a bare metal. Of course, I'm talking about my machine. Even my machine, I'm wasting my more than 50% resources because I'm not using virtualization. So more than 50% resources are being wasted. So by the way, if you see this particular resource, where we have a server, we are not using virtualization. We have 32 virtual CPU, 64 GB RAM, and one operating system. On the top of the operating system, we have running applications. So if you could see the performance of this machine, you would realize that the 70 to 80% resources are not being used. Do you get this? So what is the use of purchasing the high configuration machine if you are not using their resources efficiently, properly? If you are wasting the resources, so it means there is no use of purchasing high configuration machine. Am I right or no? Yeah. So what technology or what method we could use to just access that resources efficiently, to use the resources efficiently? And that technology is known as virtualization. The technology is known as virtualization. In virtualization, we share the resources among virtual machines, the same bare metal resources. Of course, the bare metal resources are required. When the hardware resources are required. Once you have hardware resources, and if you are using virtualization technology, you can create a number of virtual machines on the top of the same hardware. And those virtual machines will share underlying resources. So this way, on a same hardware, you can have multiple virtual machines, multiple servers you can have, right? And this is a good thing. So this way, instead of creating one machine, one physical machine, you can create multiple virtual machines. And every virtual machine will behave like an independent server, right? So we have number of...
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
The virtualization types that we'll talk about later. But right now, the virtualization is a technology which allows you to create virtual machines on the top of the hardware layer, which shares basically underlying resources among virtual machines to better utilize hardware, to minimize the wastage of hardware, right? Okay, so guys, I'm creating one more diagram. Let's say I'm just writing this with virtualization. Infra with virtualization, right? So infra with virtualization. I think you're getting my point here. You're understanding what I'm just trying to explain to you. Yeah, this is the bare metal, right? This is the bare metal, and This is the bare metal. Now there is a shift. What is the shift? So on the top of the bare metal, you will install hypervisor. So this is the hypervisor, right? And at this time, you have an hypervisor, or you can say this is the hypervisor. So this is a hypervisor. Hypervisor is a software which allows you to create a virtual machine on the top of this layer. And a hypervisor is basically the kind of a layer which has a capability to create a virtual machine as well as to share the underlying resources among the virtual machines. So hypervisor is a kind of a software. So you install the hypervisor on the top of the bare metal in your data centers. I'm talking about. I'm not talking about your laptop, right? So I'm talking about in data centers, we have a bare metal machine. So on the top of the bare metal, you do not install any operating system. You do not install any other thing. You directly install a hypervisor. We have a different kind of an hypervisor. So if you're talking about a hypervisor in data centers, we are talking about the Zen hypervisor. We can install ESXi hypervisor, or you can use Hyper-V. So we have number of hypervisors, but one of them you can install on the bare metal, either Zen, ESXi, or Hyper-V. Zen is a product of Citrix, ESXi is a product of VMware, and Hyper-V is a product of Microsoft, right? So Zen is being used in AWS data center. So Zen hypervisor frequently is being used in your AWS data center. However, these days ESXi are also used. AWS is not basically rely on one hypervisor. They are using the different kind of an hypervisor on their data centers, right? Secondly, so once the hypervisor is installed on the top of the bare metal machine, now on the top of this, you would create a virtual machine here. Let's say this is the virtual machine, right? You immediately start the virtual machine on the top of this. So this is the virtual machine, right? This is the virtual machine. You're going to say this is the virtual machine, and every virtual machine will have its configuration. I told you the configuration of this machine was this. The configuration will remain same for my blade server, for my bare metal server. And from this resource, this is the total resource my machine had. But from this resource, I'm just giving some resource to my virtual machine. Let's say I'm giving, 2 virtual CPU, right? Plus 8 GB RAM. Okay, 8 GB RAM. So this resource I'm giving to my virtual machine. And this resource is taken from my underlying resources. And once the virtual machine is done, once the virtual machine is created, on the top of this, you will install host or the guest operating system on this, right? You will install the guest operating system on the top of this. So this is the guest operating system. So you could write this here. This is the guest operating system. Your operating system could be Linux operating system, Windows operating system, Mac operating system. It depends, right? But you have an operating system. And on the top of this operating system, now you can launch some applications. Let's say these all are the applications, right? So you can have a multiple application on the same machine. So guys, you see, this is the one virtual machine. So this way, because you had a lot of resources in your underlying resource or blade server, so you can create multiple virtual machine on a same blade server. You can create a multiple virtual machines. Wow, this is good. So you can create multiple virtual machines. So instead of using earlier, we had only one machine, but this time using virtualization, you can have multiple virtual machine on the top of the same hardware. So number one, you have a large number of servers, so you can handle large number of clients. Number two, you're going to provide the multiple facilities to your client. Number three, you will pay less amount for each server because this time you are using multiple machines on a same hardware. The cost of your running infrastructure for your client will be lesser this time, right? And second, most important part, which is not being yet discussed, that means if you are using virtualization will have some benefit. Your running machine can be migrated from one server to another server. Your machine can be copied. Your machine can be backed up. Your machine can be connected with other network. So, and you can move your machine, running machine, you can move from one server to another server while the maintenance is occurring, or maybe if your underlying resources are not working properly. So you can shift your machine from one resource to another resource without any downtime. So these features are available in case of virtualization. But if you're not using virtualization, you will not get those features, right? Let's just talk about data center virtualization. You please, I'm just writing here about the data center virtualization. Data center virtualization. In the data center virtualization, you deal with the multiple blade servers. Yes or no? You deal with multiple blade servers. Correct or not? So let's say this is a one server. I think you would be agreed that we will have multiple servers in your data center, because in data center we have a rack, and even one rack can have multiple servers. So let's say, so this I'm taking a very simple example here to just clear your concept. And let's say we have 3 blade servers, right? We have 3 blade servers in your physical data center, and on those blade servers you were using virtualization, right? And one more thing I need to just tell you that in physics, if you are using data center virtualization in your data center, you will have actually the blade servers that is in orange color in the bottom. So first of all, you will create a kind of a cluster of these servers. So you will create a cluster of these servers. What is a cluster? Cluster is a logical, the cluster is a logical grouping of the servers, right? So you are creating a cluster here. So let's say this is the cluster. Cluster. So the cluster of physical servers. At the top of this, you have the machines. Let's say, and this is not the only thing. One more thing, you will have a switch. This is the layer 2 switch or the connection switch. You have a layer 2 switch. In this layer 2 switch, let's say your machines are connected. Your blade servers are centrally connected, right? So you connected all these with this switch. This is layer 2 switch. You can write this. This is layer 2 switch. And now you can have some storage. You can have some storage. Let me just write storage. Did I write something? Yeah. Let me see. Let me see where it's gone. Sorry. I can see the storages. Yes. Let me take the storage here. I'm taking a pretty simple. Yeah. Let's say this is storage of your data center. Let's say this is storage of your data center. I can just write it here. Okay. Storage of data center. And this also is connected with the rest of things. And every virtual machine will have its block device. And those block storages are not on these hypervisors. Those block storages are within the storage, right? So this is the machine block device. So this is the machine block device. Okay. So your machine is working on the top of the hardware layer, but their hard drives are stored, their hard disks are stored in storage of data center. You can see, right? So even if you just delete the VM, your data is safe. Your virtual machine's data is safe. So let's say I'm just telling you, let's say this machine, let me connect so that you could better understand. You just give me two minutes. I think you're getting my point, what I'm just trying to explain you. That's why I'm using this digital board, because the PPTs are not actually, to explain you everything. It is static, and we should not use the static method. Correct or not? Right. So guys, let's say, for example, let's say this machine is not working. Okay, I'm saying this machine is not working. By chance, this machine had got down. And now we had 3 virtual machines earlier working on this, the top of this machine. What will happen in the data center? So in the data center, it will be easier for me to just explain, because we had the 3 machines running on this blade server. And now this blade server suddenly is absent. So what will happen? You would see that these machines will automatically jump from the bad hardware to good hardware, right? So these machines will jump automatically while these are working. So these will migrate from one server to another server. And you already had these were the data, or you can say the block device of virtual machines, or you can say hard disk drive of virtual machine or VMs. I'm just writing in short so that you can understand here, HDD of virtual machines. So this is not possible in your physical infrastructure, but while you're working on your data center virtualization, you would see this would happen. So your machines can jump from bad hardware to good hardware. Number one. Number two, the balance of the load can be occurred here. Means if data center is finding that you have pretty heavy load on one server, to balance the load, the machines can be migrated from one server to another server. So, and this can be done with the help of this server, and this server is basically data center management server. So this server is known as data center management server, and here we have this administrator of the data center. Okay, so we have a storage. The storage, we have a different kind of a storage. We have a different kind of a cluster. So this is a very simple diagram. I'm just explaining about the data center, because the data center is more preferred, and we are using hypervisor. We have the 2 different kind of an hypervisor. I think this diagram and the need of virtualization is completed. Now on the same blade server, we have a large number of virtual machines to utilize underlying resources. On the same investment, now you could have a large number of virtual machines that you can distribute to your clients. Correct or not? So guys, now I'm just talking about the type of hypervisor. As I already explained, the hypervisor you install on the bare metal on the top of this. So the hypervisor is this kind of a software you install on your bare metal, and on top of hypervisor you create virtual machines. Okay, so guys, here we have the type of hypervisors, right? Right. We are just writing the types of hypervisor. We have type 1 and a type 2. The type 1 installed on bare metal. So bare metal. So we are using type 1 in data centers. We used in data centers, right? Data center, number 1. And a type 1 example we have like VMware ESXi, vSphere, right? Second is Zen, is a Citrix hypervisor. Then we have Hyper-V, etc. We have many others. So these kind of the hypervisors you directly install on the bare metal. You don't require any operating system to just install these. So these hypervisors contains the properties of operating systems too, right? So we use hypervisor, type 1 hypervisor in data centers. We have another type. We have the type 2. We have type 2. So the first of all, you need a host operating system to install type 2. need a host operating system, operating system to install type 2 hypervisor. So what is a type 2 hypervisor? I tell you. For example, this is your laptop, right? This is your laptop. First of all, let's say this is the laptop. And the laptop, on the top of the laptop, the very first, you must have operating system, correct or not? So you have an operating system. Let's say this is an operating system. Let's say this is the operating system on the laptop. Let's say this is the Windows operating system. Okay. And on the top of this, you always launch the hypervisor. This is a type 2 hypervisor. Okay. This is a type 2 hypervisor. So type 2 hypervisor requires host operating system, type 2 hypervisor. I'm just writing hypervisor, right? And on the top of this, you would create some virtual machines. Yeah, this is a virtual machine. So I'm just creating. Let's say these are the virtual machines. So these are virtual machines. And on the top of the virtual machine now, you can just launch some operating system. And on the top of this, you can just run applications. So we have multiple layers here. So this is, of course, is good for practice. This is good for if you want to learn virtualization on your laptop. But such kind of thing we will not use on data center. For data center, the type 1 is recommended. Correct or not, guys? So this the concept of hypervisor is clear.
What is Amazon VPC? So guys, Amazon VPC is basically a service. It's basically a virtual private cloud, which is given to us by AWS when we deploy resources on its cloud platform. And what this Amazon VPC basically enables us to do is basically launch AWS resources into a virtual network that we define, right? So VPC is basically a virtual network that we define. This virtual network can have multiple subparts as well. It can have multiple configurable properties as well. And the whole service is called Amazon VPC, right? Now, the definition is not that important, but the working is the most important for Amazon VPC, through which you will be actually able to understand what you can accomplish and what all is possible when you are basically making use of the Amazon VPC service. So let's go ahead and understand how Amazon VPC service basically work. So guys, this is the skeleton diagram for Amazon VPC, and you can imagine how you can basically, how internet basically works at your home system or in your office system by looking at this diagram. So what basically happens is, first there is the internet, right? So you are first always on the internet, and from the internet, there is a request which comes in. So let's say you are at your home system, and if somebody has to, reach out to your computer, let's imagine it like that. How will it work? So first you have the internet, and from the internet there will be a request which will come in. Now in AWS, what happens is, like I said, you have a virtual network that you create. So first of all, any resource in AWS that you create is enclosed inside a virtual network. It could be EC2, it could be any databases. So it has to be enclosed inside a network, right? So we will have this network. Let's say this is the network of ours, which is called the AWS VPC service. And any network or any internet connection which has to come inside this VPC service will have to come in through something called as a internet gateway. Okay, so when you create a virtual network, for that virtual network to have internet access, you basically need to create a resource called internet gateway, and this internet gateway is going to be a single point through which internet requests are going to go out, and internet requests are also going to come in, right? So the internet can basically be accessed using the internet gateway, and whenever a request is coming in through the internet, the first place that it goes to after the internet gateway is to a resource which is called routing table. Now, what is a routing table? Now, when you create an AWS network, what happens is you also have something called as the sub parts of the network or sub networks, let's say, right? So let's say you create an AWS network, and in that AWS network, you create two subparts, which are basically called subnet 1 and then subnet 2. So these two subnets will have their own resources inside it. So let's say in subnet 1, you have a database which you have deployed, and in subnet 2, you have a EC2 machine or a virtual machine that you have deployed. Okay. Now let's say if the internet has to reach to this machine, which is there in subnet 2, the way it is going to work is, first the request is going to come in from the internet gateway. From the internet gateway, now the request does not know how to reach the machine. So what it will refer to is basically something called as a routing table. So in the routing table, basically you will have all the details with respect to which how can you reach the resource. So this resource will basically have a private IP address, right? And this private IP address can be reached out to using the routing table, right? Or in other words, you can also imagine it something like this, that how will the internet gateway know about these resources? The internet gateway knows about these resources when it is basically a part of the routing table. So when the routing table is visible to the internet gateway, then these resources are also visible, right? And from the routing table, basically you reach the subnet 2, and in subnet 2 you have that resource. Okay, so this is a skeleton of what AWS VPC is. First, the request comes in through the internet gateway. The internet gateway refers to the routing table, and from the routing table you basically go through the subnet where you have the resource, and from the subnet you go to the resource. Okay, now there are something called as firewalls in this architecture. Now you will ask, okay, you just told us that the request just comes in, so how is it filtered? So that filtering process happens using firewalls, and there are two kinds of firewalls in VPC. The first firewall is called NACLs, right? And this network access control lists, these are called, and these basically operate at the subnet level. That means that there is a firewall at a subnet level, and there is a firewall or the instance level, which is basically, or the resource level, which is basically called security group. So there are two levels of firewalls in a VPC network. Okay, so that basically means that when the request is coming in, there is no filter which happens on the AWS VPC level. The only filter which happens is on the subnet level, which is the network ACL. Okay, from the network ACL, if the request gets filtered, then it basically goes to the security group of the resource. So if I were to include these two firewalls in the diagram, it can be imagined something like this. That first the request will come from the internet. From the internet gateway, it will look for the instance that it has to go to in the routing table. From the routing table, once it gets to know where the resource is, it will go there. And in the subnet, it first has to basically go through the first level of firewall, which is the network ACL. From that firewall, it then goes in if the request is filtered out. And when that request is filtered out, then it encounters another firewall, which is basically called a security group. And if it filters that out, then only it is able to access the resource. Okay, so this is the flow diagram of how a request flows in a VPC. And now what I'm going to show you guys is basically how to create this kind of an architecture in AWS, right? So what we're going to do is I'm going to quickly jump on to my browser and let me open AWS Management Console. All right, guys. So first you have to basically go to aws.amazon.com, and on aws.amazon.com, you basically will sign in. And this is where you will reach your AWS Management Console. Now on the AWS Management Console, what we have to basically work with is virtual private cloud. And let's try to now create the architecture. So this is how our architecture looks like. So first what we'll do is we'll create AWS VPC, right? So let's go ahead and create a VPC. So we'll click on VPCs, we'll click on create VPC, and whatever I've explained to you guys, we will try and test it out by doing the hands-on. So that is what we are going to do. Okay, so first let's name our VPC something. So let's call it VPC demo 1, let's call it that. And now let's give it a IP address range. This IP address range will basically mean that all the resources in this VPC are basically going to have an IP from this particular range, which we are now going to define. So let's go ahead and define a range. Let's say it's 192.1.0.0/16, right? Let's say this is the range. And now we'll basically go ahead and click on create VPC. So our VPC has now been created, and what we have done is we basically went ahead and created a simple network. We have not defined any of these resources as of yet, right? We have just created an empty box, which is our AWS VPC. Now, whenever you create a VPC, guys, what happens is automatically, when you will go ahead and create subnets, it will automatically create some resources, and I will tell you that. So right now, these subnets are of some other VPC that they are not of the VPC that I created, right? So what I'll do is I'll go ahead and create two subnets, which is subnet 1 and subnet 2. So let's go ahead and create that. So let's click on create subnet. Let's call it subnet 1-demo. And the VPC obviously is going to be VPC demo 1. This is the one that I created. Now, this subnet can be deployed in 3 availability zones. These are basically different data centers that AWS has in the region that we are working in. Let's deploy it in the first data center, 1A, right? And now we have to specify an IP range, which is basically going to be part of the main range, which is there of the VPC, right? So let's specify a range 192.1.1.0/24. So this is going to be the range of the subnet that we are basically creating right now. So we'll click on create. And now the VPC1 subnet 1 has been created. Similarly, we'll create one more subnet. Let's say it's VPC1 subnet 2. Right? The VPC is going to be VPC demo 1. This time, let's say the data center is going to be of 1B. Right, and specify the IP range as well. So this is going to be the IP range. Okay, let's click on create. Okay, so my second subnet has also been created. So if we refer to our diagram again, so we basically created a VPC, we created 2 subnets, and now let's create the routing table. Okay, now right now I have not created any routing table, but if you go to your routing tables, you will be able to see that this is your VPC's routing table. As you can see, it's VPC-demo1, and this is automatically created. Okay, so this is whenever you create subnets, a routing table is automatically created, and this routing table, if you want to look, what subnets it is basically associated to. So you can just click on subnet associations. It is not, basically created by, or it is not basically connected to any subnet as of now, right? So a routing table is automatically created. And why is it created? Let me show you that as well. So if you go to routes in this, you will basically see that there is already a route which has been added, which basically says that all the IP address from this range can basically talk to each other in this virtual network. So this is the default rule, which basically says that if I deploy this resource and if I deploy this resource, they can talk to each other. Why? Because that is the default rule which is present in the routing table. Okay, so these two will be able to talk to each other. Why? Because this rule is present, and this rule is by default, and this rule you cannot delete as well. Okay, so this is one thing. Now what we want to do is, since these two subnets can talk to each other, but they cannot talk to the internet as of now. So that is something that we are going to configure. But how does the routing table know that which subnets can talk to each other? Okay, so for defining that, what you'll have to do is you'll have to click on subnet associations, click on edit subnet association, and include these two subnets over here. So when you do that, now this routing table says that both these resources can talk to each other via the routing table, And now what we want to do is we basically want internet to be available in this routing table as well, right? So we are going to configure that, but right now let's not configure the internet, and let's see what will be the behavior in case we don't add the internet, right? What we are basically going to do is let's go ahead and define the firewalls now. So let's first define the network ACL. So again, in this case, if you go to NACL, this is basically the subnet level firewall. So over here, you can see there's already a network ACL which is created for VPC demo 1, right? So this is also created by default. And if you look at the inbound rules or the outbound rules, so what is this firewall saying? That all traffic is right now allowed. So anyone who wants to have access inside this subnet, inside both the subnets, because both the subnets are associated to this NACL or this firewall right now, all traffic is enabled to all the subnets in this particular network. Okay. Similarly, if you look at the outbound rules, you can basically request anyone on the internet from within these two subnets. So that is what our network ACL is right now saying. Okay, so we're not going to touch that. So let's move on to security groups now. And when we move to the security groups, over here as well, you will be able to see that there will be a default security group which will be created, and which VPC is ours, we can basically make out by looking at the IDs, right? So our VPC is of the ID 69D, right? So that's what we have to look out in the security groups. So we'll go to security group 69D, right? This is the VPC ID of us, and this is the security group that is basically created by default. So let's name this as default security group or default demo 1. Let's name it that. So this is our security group which has been created, and if you look at this security group's inbound and outbound rules, they are going to be very limited, right? So all traffic is allowed, but it is only allowed from within the resources which are connected to this security group, right? So we can change this if we want. So we want anyone to be able to go through this firewall. So I'll just specify anywhere, and we'll click on save rules. Okay. So now what we have done is we have opened both our firewalls, that is the subnet level firewall and the instance level firewall, right? One last thing that we should do before we can go ahead and deploy these resources inside these subnets is basically to tell these subnets that these resources can have public IP addresses. Okay. So how do we go ahead and configure that? So just select your subnet. So let's say this is subnet 1 demo 1 that I have basically went ahead and selected. So what I'll do is I'll click on actions, click on modify auto assign IP settings, and here I will say auto assign IPv4 address. So by this, now what is going to happen, that any resource that I'm going to create inside this subnet, it is automatically going to have an IP address. Similarly, I'll do that for my subnet 2 as well. So let me specify the name correctly. This is subnet 2 hyphen demo 1. And in this, again, I will say that basically any resource which is deployed in this should have a IP address, a public IP address. Okay, all set. So now what we have done is we have not configured the internet gateway yet, but we have created a network. Inside this network, we have a routing table, and this routing table has a default rule, which basically is allowing both these subnets to talk to each other. We have created this firewall, which is allowing all traffic. We have created this firewall as well, which is allowing all traffic. Okay, so let's go ahead and test this architecture out. So what I'll do is I'll go to EC2. And now I'll basically go ahead and launch two machines, one in subnet 1 and the other in subnet 2. Okay, and there is a behavior that I want you guys to notice. So first I'll go ahead and create an Ubuntu machine I create a t2.micro, which is basically going to be a part of VPC-demo1, right? It is basically going to be in, let's say, subnet 1. And other than that, everything can be left at default. In the security group, we are basically going to configure or select the default security group that we created, right? And now let's go ahead and click on review and launch. So now what we'll do is we'll basically select a key that we already have. So I'll select Mac-Mumbai. I already have this key and I click on launch instances. So with this, I have launched a machine in subnet 1. Now I want you to notice something. This is subnet 1 machine. And this is being deployed. While this is being deployed, let's deploy the second machine as well, which is again going to be an Ubuntu machine, t2.micro. It is going to be a part of our demo 1 VPC. It's going to be in subnet 2, going to be a part of the default security group. Let's review and launch. It's also going to have a key pair, which I already have. And now this machine is also launched, and this is going to be a part of subnet 2. Now, what is something that I want you to notice? So first of all, this will have an IP address because we specified in the subnet that the machine should have an IP address. But now if I try to connect to these machines, you will see that I will not be able to connect to them. So if I open my terminal really quickly, and let me try to go ahead and connect to these machines. You will see I will not be able to connect to them. It will basically give me a connection timed out kind of a request. And the reason for that is because I am on the internet, I'm trying to connect to these resources, but this internet gateway is not there. Right? This internet gateway is the only way that this VPC will be able to talk to the outside world. Okay, and because it is not there, you will see I'm getting a connection timed out kind of a thing. So how can we fix this? So now let's go back to our VPC console and let's go ahead and create something which we call as an internet gateway, right? So we'll go to VPC. Inside VPC, we will go ahead and go to Internet Gateways. And in this Internet Gateway, I'm going to create this. This is a default Internet Gateway which is attached to the default VPC that we created. And what we're going to do is we're going to create one more Internet Gateway. Let's call it IGW Demo 1, right? And let's create it. Once it has been created, what we'll do is we will attach it to our VPC. So right now it's in the detached state.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session. Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So I'll have to do and click on Actions, click on Attach to VPC, and attach it to VPC-demo 1. Attach it. So it's attached. So now that it's attached, guys, we should be able to see this internet gateway in our route tables. right? So if I go to my route table, so this is my route table. This is the demo one route table, right? So if you go to routes, we can click on edit routes, and now we can add a route for the internet gateway, which is IGW-demo1. We'll add that, and the whole internet can be accessed using this internet gateway. We'll click on save routes, and now if we go ahead and try to run the same command, you can see I'm able to connect to my machine. Isn't that great, right? So now, since we are able to connect to this machine, we should be able to connect to the other machine as well. So let me connect. And let's go to our second machine's IP address. So this is a subnet 2 machine. Let's connect to it. This is the IP address. All right. So now, as you can see, I have successfully connected to these two machines. And now let's see if these two machines are able to talk to each other, right? So how can we check if they're able to talk to each other? So if we try the public IP address, obviously they will be able to talk to each other because this is going to be via the internet. But what we want to see is whether they can talk within the network. And for that, we are basically going to make use of the private IP address. Okay. So this is the private IP address of subnet 2. So what we are going to do is from the subnet 1 machine, I'll try to ping subnet 2. And as you can see, I'm able to ping the machine in subnet 2. Why? Because in the route table, we have that entry wherein they're able to talk to each other. Great. So now let's try something out. So what we can do is we can go to, since subnet 1 is able to talk to subnet 2, let's go ahead and go to network ACL. That is basically the subnet level firewall. And there, let's try something out. So we'll go to VPC. And in VPC, we will now go to network ACLs. So let's create a new network ACL. It will basically be subnet 2-demo1. And this is going to be a part of VPC demo 1 VPC. Right, and let's say this is for subnet 1 and this is for subnet 2. So in this, what we can do is we can remove the subnet. Let's remove the second subnet. Let's say in this subnet, I go ahead and I specify that only network connection from subnet 2 is possible from subnet 1, but subnet 1 from subnet 2 is not possible. That means that let's say only this machine can ping to machine 1 and machine 1 is able to ping to machine 2. Now, how is that possible? I will just specify that all traffic from machine 2 is allowed, but from machine 1 is not allowed. So we'll specify something like this. So 1 second. Okay, so I basically just have to add /20 over here, save it. Okay, so now what I've specified is that only subnet 2 is able to ping into the network ACL. Now, what does that mean? That basically means that if somebody is trying to go ahead and ping subnet 1 to subnet 2, it should not be able to do it. Let's try it out. And now you can see, since I have edited the network ACL, I am not able to use these machines from my personal system as well. And the reason for that is now the subnet is not allowing my machine as well to connect to these machines. Okay, so let me make you understand that using the diagram over here. So what we did is basically these firewalls, these subnet level firewalls, have only allowed connection from machine in subnet 2. Only this IP address I have added in this firewall. Now, because of that, what is happening is from the internet, I'm not able to reach this subnet. Why? Because this firewall is blocking me. So I'll not be able to SSH into this machine now. Okay, so let's try to change what we were doing. Let's again go back to network ACL. So I'll go to VPC and we'll again click on edit inbound rules. We can again make it 0.0.0.0/0. Save it. And now again, if I come back to my terminal, I should be able to connect, right? Similarly, I should be able to connect over here as well. Okay, so instead of, let's say, changing the subnet level firewall, let's go ahead and change the security group firewall, right? So in the security group firewall, what we can do is we can tell that only my machine should be able to ping it, right? And then only subnet 2 should be able to ping inside it. Subnet 2 machine should be able to ping inside it. So how can we do that? Let's go to security groups. So our security group is this one, 69D. So let's go inside it. Click on edit inbound rules. And all traffic is allowed only from my IP. This is my machine's IP. And only from, let's say, I want to go ahead and allow only subnet 2 to be able to ping inside it. Subnet 2 machine to be able to ping inside it. Okay, let's click on save rules and let's see how this is going to work now. So now in this case, my SSH is going to work perfectly fine, right? So if I will try anything over here, it will work perfectly fine. If from my first machine, I try to ping machine 2, let's see what happens. So according to the rules that I have configured as of now, if I try to ping subnet 1 to subnet 2, according to the rules that I've configured, it should not connect, right? But let's see if our assumption is correct or not, and then I'll explain whatever the behavior is happening over here. Can you see we are not able to ping the first machine, that is subnet 1 machine to subnet 2 machine. Okay, this is the subnets to private IP. This is not able to ping, or on the diagram, this machine is not able to ping this machine, right? And why is that so? Because in the firewall for these machines, what I've configured is that only this machine, the subnet 2 machine, can go ahead and ping the other machine, or only this machine's IP address is allowed in the firewall and no other machine can ping, which basically means if I go ahead and go to my second instance, and if I try to ping the first machine, I should not have any problems. So if I select subnet 1 machine over here, select the IP address from here, come back, set the IP here, hit enter, you can see the ping is working, right? And why is that so? Because in the security groups, I have specified that only my subnet 2 machine connections will be allowed. So if I go ahead and change this, if I go ahead and make this 192.1.0.0/16, if I make that to basically work, now what will happen? So let me just verify if this is a CIDR range. Yes. So this is a CIDR range for all the instances or all the resources in this VPC. If I click on save rules now, you can see that this ping now again started to work, right? Why? Because this particular rule is now allowing everyone inside the VPC to be able to ping each other, right? And hence this ping started to work. Again, if I go ahead and if I change it to, let's say, only subnet 1 machine being able to ping each other, then it will be a different story. Just give me one moment. Okay. All right. Okay, guys. So now if I go ahead and change this to only subnet 1 machine's IP address, what is going to happen then? In that case, only subnet 1 machine will be able to ping subnet 2 and the other way will not be possible. So if we save the rules, so now you can see both of these are working, right? So let me clear the screen once more and let me start this command. Right? So now if I go ahead and save the rules, you will see that this is going to stop now in a few moments. So what we have now added, that we have added that only subnet 1 will be able to talk. So if we try this out. So subnet 1 connections are allowed and subnet 2 connections are not allowed. So if I try to ping from subnet 2 to subnet 1, this should not be allowed now. Can you see? The ping has now stopped. And why is that stopped? Because we have changed the firewall rules so that only one machine should be able to talk to each other. All right, great. So guys, I hope this particular diagram is clear. So what we have done so far is we have created a VPC, we created two subnets. These two subnets, we basically had a routing table associated with it, which is created by default. This routing table did not have access to internet. So we created an internet gateway and we included that internet gateway in the routing table. And then we were able to basically access both the subnets from the internet. All right, then we went ahead and configured the two types of firewalls that we learned. First, the network, the subnet level firewall, and then we try to configure the instance level firewall. Right now, let's go ahead and understand the different kind of subnets right now. So the only thing that we understood is that we could create two subnets, but there can be two types of subnets which you can basically go ahead and create. The first subnet is basically called a public subnet, and the other subnet is basically called a private subnet. So a public subnet is a subnet which can basically be accessed by the internet, and a private subnet is a subnet which cannot be accessed by the internet. Now, what do we mean by that? So right now, both our subnets are being able to be accessed by the internet. But what I want is only one subnet should be able to be accessed by the internet, and the other subnet should not be able to access by the internet. Now, how is that possible? How is that possible? So it is possible using an architecture like this. So what we are basically going to do is we are basically going to have two subnets. We are going to have an internet gateway, but from the main routing table, we are going to not associate that routing table to our subnet 1. Right? We are going to create a separate routing table for our subnet 2, right? Which is not going to be associated with the internet gateway. So all in all short, in the first routing table, the main routing table, we are going to remove the subnet 2 and we'll only have subnet 1, which is basically going to access internet. And we are going to create one more routing table so that our second subnet can associate with it and then be able to talk to the first instance or the subnet 1 instance. Okay, so let's go ahead and implement an architecture like this. So what we need to do in our existing VPC is here nothing will change. Subnet level, nothing will change. In the routing tables, what we're going to do is, this is my demo 1 routing table. Let's say this is going to be my public routing table, since this already has the internet gateway attached, right? Let's create one more routing table. Let's call it as demo 1 routing table, but this is private. Okay, and this will be associated to VPC demo 1 VPC. Let's create it. Okay, this is created. Now in the demo 1 public routing table, we are basically going to go ahead and edit subnet associations. And I want to remove subnet 2 from over here, which is this. Let's remove this. So only subnet 1 I want to associate. So I'll just click on save. So now only one subnet is associated, which is subnet 1, which basically means if I try to access my instances, now let's try to SSH. This is subnet 1. Let's try to SSH into it. This is working perfectly fine. Okay, this should not work. Let me check what has happened. So this is the routes. This is basically having an internet gateway for this subnet. which is fine. Then we have this routing table. Okay, so in this, I will have to edit. I will have to select the subnet, save it. Okay. And now you can see that this instance has stopped working. I can just quickly go ahead. And try connect to the subnet 2 machine, which is this IP. You can see I'm not able to connect now, right? And why am I not able to connect? Because for my second subnet, it is now not having any route for the internet gateway, right? But for my first machine, it is having a route for the internet gateway. So that's why if I exit this and try to connect again to my first machine, the subnet 1 machine, I'm able to connect, but for this machine, it is giving me an error now, or it is not connecting. Why? Because this machine no longer has internet access. Okay, but what we can do is we can try connecting to this machine, the subnet 2 machine, from within the VPC, which basically means that if I come back to my diagram, okay, so in this now what is basically happening is that from the internet, I am from the public route table, I'm able to connect to subnet 1 machine, but from the internet, I'm not able to connect to subnet 2 machine. So what I can do is and observe, the reaction over here, that I will be able to go inside this VPC and I will be able to connect to subnet 1. From subnet 1, I will be able to connect to this machine, right? Now from this machine, I can basically go through this route table and then connect to this machine. Do you understand this network architecture, right? So from this route table, obviously I cannot connect to this subnet because this route table does not have any details regarding this particular subnet. Okay, but this particular route table, the private route table, has basically allowed connections between these two subnets, and because of that, what we can do is we can basically go ahead and connect to this machine, and from this machine I can SSH into this particular machine, but it obviously has to be using the private IP addresses. Okay, so let's try that. Let's try that over here. So what I'm going to do is, first I need on my subnet 1 the key pair. So let me go ahead and copy the key pair. So I'll just go ahead and copy the key pair on this machine. Done. Let me again go inside it. So I'm inside the first machine now, and I have this key pair over here. Let me give it the required permission. It has it. And now let's try to go inside the second machine. And that we will do now using the private IP. And as you can see, I'm inside the second machine now. So you can see the IP address is 192.1.2.96. This IP address is 192.1.2.96. However, if I try to go through the public IP address from my machine into it, I will not be able to do that since there is no internet connection. But because there is a possibility or there is a connection between this machine and this machine, I'm able to SSH from this machine into the subnet 2 machine. Okay, and that is what we have just done. Great. So now we saw how to create a machine with no internet access, and I can show you guys that there is no internet access. So since this is subnet 2 machine, if I try to curl google.com, you can see there is no response, right? It basically just hung. Why? Because google.com is not reachable. However, if I go back to my subnet 1 machine, so I have just exited the SSH of the second machine, and I'm now inside the first machine. As you can see, the IP address has changed. So if I go over here and try to do curl google.com, you can see that I'm able to see some content from the internet. But in this case, I was not able to see any content. Why? Because the second machine does not have internet access and the first machine has internet access. Now, in what cases will it be beneficial? It will be really beneficial in cases wherein the let's say in subnet 2, I have a resource which I do not want anyone from the internet to be able to access. Okay. Why I don't want that? Because probably it's a very critical machine for me. I don't want this machine to be hacked in any sort of way, right? So that's why I do not want anyone from the internet to be able to reach it out. So in that cases, what we do is we create private subnets, right? Now, there is a use case wherein probably somebody from the internet should not be able to reach out to this subnet, but from within the machine, if the machine wants to access internet, that should be possible. So how can that be achieved, right? So that can be achieved, giving internet access to private subnets, that can be achieved using something called as NAT gateways. So what are NAT gateways? NAT gateways are basically resources which help private subnets to use the internet. Now, how does it help it? By basically giving a proxy connection to the internet gateway. So what's going to happen is it's basically going to help us connect to the private or the public subnet, and from the public subnet we will be able to access the internet. So basically you can imagine it like this, that a NAT gateway is going to be a machine which will be deployed in the public subnet, and our system is going to ping that machine to access the internet, right? So that is what a NAT gateway is. So how can you create a NAT gateway? You can basically just go to the VPC menu, and then you can go to something called as NAT Gateways. Here it is. And you can click on create NAT gateway. Let's call it demo1 -NAT. Which subnet do you want it to be used in? We want it to be used in subnet 2. And subnet 2, it needs an elastic IP to work. So let's allocate it. So it has to be, it has to be associated with a public subnet, because this has to be deployed in a public subnet. And then we will try to reach out to this NAT gateway from our private subnet, right? So we will deploy it in subnet 1, which is basically having internet access. And then we are going to click on create NAT gateway. And now what is going to happen is basically it is going to create a machine in the public subnet. And this machine we are going to reach out from our subnet 2. for internet. Okay, so NAT gateway was created successfully. So if you can see, the state is pending. It will take some time to get deployed.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So let's give it that time. You can refresh. State is pending. So now what we need to do is, once it is deployed, we can go to route tables. We'll go to a private route table, go to routes, and now we can just click on edit route. So now what we want to do is we want to add a route to the NAT gateway so that they can connect to each other. So we'll click on add route. We will give all connection to what? To the NAT gateway. And since it is being deployed, it will take some time. So let's give it that time. If we go ahead and again check our NAT gateway. Still in pending state, it will take some time. So it usually takes around 3 to 4 minutes to deploy. So let's give it that time. Because like I said, this is a machine which is launched, right? So this machine is launched and the software is deployed on it. So it takes some while to get deployed. And once it is deployed, you will be able to see it in your route tables. So if we look at the details for this NAT gateway, you can see that this is the private IP address for this NAT gateway. Oh, I think we have deployed it in some other VPC, guys. We have deployed it in custom VPC. Sorry for that. So we'll have to click on create NAT gateway, NAT-demo1, new, and this has to be okay. This has to be a part of 69D. This is the one. So we basically connected to VPC subnet 1. This is some other subnet that I created earlier. We basically wanted to connect it to subnet 1 demo 1. This is our VPC, right? This is the public subnet for us. And let's allocate an IP address. Click on create NAT gateway. Okay, really sorry. So I selected the wrong VPC in this case. So this is the one which is being created now. So you will see that this failed. So why did this fail? This failed because in the custom VPC that there is one more VPC which exists, right? So there is no internet gateway which is connected to that particular VPC, and that's why it failed, right? But if we see ours, it will basically get deployed in some time. So if we select the details for this NAT gateway, now let's verify if everything is correct. So the VPC is VPC-demo1, subnet is subnet1-demo1. This is the IP address. So this IP address is according to the CIDR range of subnet1, which is again correct, right? Okay, this looks good. Okay, so as you can see, the NAT has been created now. And now if I go to route tables, if I go to the private route table, click on edit routes, click on add route. Here, if I go to NAT gateway, I can see the NAT demo1 new. I can add the destination as 0.0, click on save routes. This is done, right? Now, what has changed? So now if I try to access the subnet2 machine, I will still not be able to SSH into it from my terminal, from the outside. So if I try this out, this will still not work. Why it will not work? Because this subnet still does not have outside internet access, but from within it can go ahead and use the internet. So now if I try to SSH into my second machine, this is now my subnet2 machine. And from here, if I now do a curl on google.com, you can see that the internet can be accessed, right? So how is that possible? That is possible using NAT gateways. Finally, let's go ahead and understand what is VPC peering. Now VPC peering is a very simple concept. Now what it says is, if you have two VPCs and if they want to be able to interact with each other, you basically just have to create a peering connection. That's about it, right? You could create two VPCs, and if these two VPCs want to interact with each other, not on the internet, but using the internal network, you can do that by creating a peering connection. Now, how can you create a peering connection? So first of all, what you can do is, let me go to VPC. Let me quickly go ahead and see the three VPCs that I have. So I have a default VPC, which everyone has when you create an AWS account. So what I'll do is, I'll basically go ahead and launch an EC2 machine in the default VPC. So I click on launch instance. Select the Ubuntu server. And I want to deploy it in the default VPC, which is correct. Select the default security group. Launch it. So this is my default instance, which is there in the default VPC. Now what I want is, this instance should be able to talk to subnet 1 machine and subnet 2 machine via the private IP addresses. So if you see, the private IP address for this is 172.range, right? And the subnet 1 and subnet 2 machine are in the 192.range. So I want these two machines to be able to talk to each other. So right now, if I go ahead and this is my subnet 1 machine now. If I go ahead and try to ping this particular machine, the default machine, using the private IP, obviously I will not be able to ping it. You can see the ping is not happening. However, if I go ahead and connect to this machine using the public IP, I'm able to connect, right? But this machine is not able to ping this machine over the private IP. Now we are going to change this. So how can we change that? Come back to your VPC console, scroll down to the VPC pairing section. Okay, so there is something called as VPC pairing. peering connections. Let's click on create peering connection. And let's say this is VPC, or let's say it's a demo 1 to default. So who's the requester? Let's say demo 1 is the requester. This is the CIDR range. And what I want to go ahead and connect to is the default VPC. And I want to click on create peering connection. Okay, so you can say it says pending acceptance. Okay, and now what you can do is click on actions, click on accept request. And now you can see this peering connection is now active. Okay, but that does not mean the ping is going to work. The ping is not yet going to work. What you have to do is you have to go to route tables. So since this is subnet 1 machine, I'll have to add a route in the subnet 1 table. Let's add a route that anyone should be able to connect to the peering connection. So if I add this range, click on save routes. Okay, 1 second. So 192.1.1.0/24, save routes. And here I think we'll have to add this CIDR range, which is 172.31. Okay, the route has been created. And now same I will have to do in the default route table as well, which is this one for the default VPC. So I'll select this, edit routes, add a route. This will be for 192.1.0.0/16 peering connection. This is the one. Click on save routes. And now you can see the ping has started to work. So now what is it being able to ping each other? So basically this is my subnet 1 machine. My subnet 1 machine is now able to ping the default instance that I created in the default VPC. Why? Because we have created the peering connection. Similarly, from here, I will be able to ping the subnet 1 machine. So it will take some time. Let me check. Okay. I think in the security group I have not enabled, so I'll have to just change the security group settings quickly. This is the default one, demo 1 security group. I'll have to go to inbound rules, and here this small rule I'll have to change, and I basically want to allow everyone to be able to connect. And once this is done, even my second instance is able to talk to my other VPC, which is there in the other instance, right? So guys, this is what VPC pairing means, that two VPCs are now able to talk to each other by creating a pairing connection and having their connection details in the routing table. So guys, this is how you go ahead and create a VPC pairing connection.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So first of all, EMR is called Elastic MapReduce, and it is a managed cluster platform. So this will simplify big data frameworks. So let's say you want to run Hadoop on the cloud. So instead of running a server, downloading Hadoop in that and configuring every single step, you can just go ahead with Amazon EMR, just type in the name of your cluster, choose the softwares, choose the big data tools which you need. Once you've done that, you can give how many nodes you want, that is the master and slaves. So let's say one master, two slaves, you can have that. Once you mention that, you'll have to provide a role, and that's it. You'll just have to click on create cluster and it'll do the rest for you. So that's how simple Amazon EMR is. Now let's look into the benefits of Amazon EMR. So first of all, if you look into this, there is cost efficient. So that, as I told, you'll just have to pay as you go. Then allows AWS integration. You can integrate it with other AWS services. Then comes easy deployment. As I told you, you'll just have to give in few details and hit click. It'll automatically do that. And then comes scalable and flexible. So as I told you, there is auto scaling available. And also it is flexible because you can terminate it, you can stop it whenever you want. It is reliable because they provide you an SLA of 99.9%, which basically means it never goes down. It is always on. And then secure. So obviously AWS provides you a lot of security features. You can use IAM, which is for identity and access management, where you give permissions to users. If they have the permission, they'll be able to use this particular service, EMR. If they don't have the permissions, they'll not be able to use it. And then easy to monitor. So there is a service called CloudWatch. So it is automatically integrated with all the AWS services. So you don't have to even do anything. You can get the metrics automatically. Finally, easy management. You're not going to manage anything. You're not going to patch anything. You're not going to add any code. You're not going to debug it. Everything will be taken care by AWS. You'll just have to set it up, and that's it. So we've seen the benefits as well. Then the EMR architecture. So how exactly it is hosted in the cloud? So that would be your question, right? So let's say in your local system, you would have the Hadoop ecosystem, because you'll be downloading it, and then you'll install it, you will configure it, you will set it up. In the cloud, it is almost the same architecture. So you can see that EMR architecture remains identical to the normal Hadoop cluster architecture. Local file systems of the nodes, HDFS or EMRFS, are used as storage nodes for EMR. So you can use the local file systems of the nodes, that is local file systems in the sense, the local file systems which is hosted in the cloud. So that local file system is basically Amazon S3. So S3 is the backend for HDFS. So as I told you, S3 is used for storage. So S3 is also used for storing HDFS, that is storing files in it. So using the EMR file system, that is EMRFS, Amazon EMR extends Hadoop to add the ability to directly access data stored in Amazon S3. It is not that you'll have to push the data into HDFS and then you'll have to analyze it. Instead, you can store the data in Amazon S3 itself. So directly from S3, you will be able to query and analyze the data. Most often, Amazon S3 is used to store input and output data, and also the results are stored in HDFS. So these are the temporary files are basically stored in HDFS. The input data and the output data both are stored in S3. So this is how it basically works, guys. It's pretty simple. It's a cluster format. If you know about the big data services, it is the same architecture on AWS as well. So if you don't know the architecture, I tell you, so I ask you to go and please go and check that out. Check out HDFS, check out Hadoop, check out MapReduce and all that. So once you get an idea of that, you will get an idea of how it is hosted on the cloud, because it's similar. So let's say it will have a backend server running, and in that backend server Hadoop will be installed, configured, and everything would be set up over there. And once that is set up, guys, Amazon S3, it is pretty simple. I'll show you how to start up with that as well, and then you will be able to set up whatever service you want: Hive, Hadoop, Spark, HBase, anything. So this is the basic architecture. Okay, so the main processing frameworks available for EMR is Hadoop, MapReduce, and Spark. So one more thing, the most popular frameworks are Hadoop and Spark. There are other frameworks which you can use on EMR as well, but the most popular ones are Hadoop and Spark. Okay, so now EMR applications, that is, what are the other applications available on EMR? As I told you, you can see over here, it supports many applications: Hive, Pig, Spark, streaming platform. It supports Yarn, it supports Hue, it supports mostly all the Apache products, that is the Hadoop ecosystem products. So you can go ahead and look into that more. So we'll not be covering this a lot. Now next I'll be doing a hands-on using Hive on EMR. So let's do that. So in addition, Amazon EMR also supports open source projects that have their own cluster management functionality instead of using Yarn. So instead of using Yarn, if you're using your own resource management, then that is also fine. So EMR allows that as well. Okay, guys. So we've seen that. So now let's do an hands-on on Amazon. So first of all, to start off with this, you will need an AWS account. So I suggest you to get an AWS account soon and start practicing. Okay. So right now I'm already in the EMR console. I have logged in, and it's pretty simple. And you can just search EMR over here and click here, and you'll be inside the EMR. Yeah, so I'm here. So just one second, I'll have to show you S3. Okay, first of all, let's create a bucket here. So what we are going to do, we are going to create a bucket to get our output. So our output will be stored in the bucket we are going to create. So this is very simple. Click on create bucket, provide a name. So let me give as YouTube live webinar 1, and I'm going to just create. I'm not going to set up anything. I'm just going to create this. So it is this simple to start a bucket. So a bucket is basically a repository or a folder where all the files are stored. So it's pretty simple, guys. You'll just have to remember that. So a bucket is basically a folder where you can store all kinds of files. It may be video, audio, all kinds of binary files can be stored here. So we've created a bucket. So you can see there's an upload option as well, but we're not going to upload anything over here right now because this bucket is for our output. Okay, now let's start with EMR. But before starting off with EMR, I'll just get a file. 1 second. Yeah, so the file is over here. Yeah, okay, cool. So we're going to create a cluster. So while creating a cluster, I'll be explaining that. So first of all, to start off with EMR, get yourself an AWS account, but there is no free tier in EMR. So there will be a small charge. It will be around, let's say, $0.04, something like that. It'll be a very small amount. So you can go ahead with that. But make sure that you terminate your cluster immediately. So create cluster. So first of all, to start off with EMR, as I told you, get an account. Then you can start off with this. Then come to Amazon EMR. Go to clusters. Click on create cluster. Okay. So now it's the simple setup. It's very, very simple. So first of all, give your cluster a name. I'm going to name it as webinar cluster. Okay. And then let logging be on. Logging in the sense, whatever happens, the setup, let's say the configuration, everything will be loaded and it will be stored in this folder. So it will be stored in this folder in S3. So let it be. That's fine. Next, coming down. So this is going to be cluster. We are going to start with a cluster and software configuration. So this is where you'll have to choose, guys. So here you can see core Hadoop, that is Hadoop, Hive, Hugh, Mahout, Pig, and Tez. So anyway, we are going to only use Hive. So I'm going to choose first one. Then there is for HBase, Presto, and Spark. If you want more options, if you want to choose multiple services, you can click on go to advanced options. And so, and you can see here, you get to see all the available applications. You can choose whatever application you want, example, TensorFlow, Zookeeper, if there is Kafka, then there is Flink, Tez. You can choose whichever you want, and then you can set it up. But right now we are going to go with quick options because it's easier to understand at the start. So it was the same. So I'm not going to change anything. And so you can see, yeah. So I'm going to go with core Hadoop. And this is the most basic instance type in EMR. So let it be. And the number of instances are going to be 3. There will be 1 master and 2 core nodes, which is basically 1 master, 2 slaves. So that will be a master slave architecture. And then I'm going to choose an EC2 key pair. Anyway, we're not going to use this. But if you want to log into the Hadoop system and check out what is happening inside of it, you will need this. But anyway, we're not going to open it. But still, I'm showing you. So key pair, you can learn about the key pairs and how to log in with a key pair from our other AWS tutorials in our YouTube channel. You can check that out. Okay, so this is my key pair, and choose a permission. I'm going to go with default because it's already configured, as we'll be taking the data of pushing the data into S3. So I'm going to go with this. Yeah. Okay, so now you can see this, and if I hit create cluster, it will start. But I'm not going to do, because I'm going to go and do this exact same thing in advanced options. I think I understood this part. If I click create cluster, it will create a cluster. So there is one small step in this. That is, we'll have to mention the input data and the output folder where the result has to be stored. So I'm not going to make any changes. It is going to be the exact same configuration. I'm not going to change anything. The only change we'll be making is adding a step. So our step would be a Hive program, because that's what we're going to do. We are going to include a Hive script. So I'm going to click that, and I'm going to click add step. Okay, so you can see script S3 location. So we'll have to provide the location of where the script is available. Then we'll have to provide the S3 location of the input files, and then we'll have to provide the output location which we created. Okay, and an argument. Okay, so that is fine. Coming down. So this is what I wanted to show you guys. So if you want to check out this, you can just go ahead with the documentation provided by AWS for Amazon EMR. So this is one of the tutorials they provide. So this is the script link. So the script is over here. I'll explain to you about this. This is the script. This is the script link. And this is the input folder. So as you can see, this is the input folder of the S3 bucket. And inside this bucket, there is a sub file called CloudFront. Inside that, there is a sub file called code. And inside that, there is the script file. Okay, that is fine. And then there is the input. Okay, and this is basically a command which AWS told to add in the argument section, so that if there is any keyword mismatch, it will automatically take care of it. Okay, that is fine. Next, coming to summary. So this is the script which will be running in Hive. Okay, so you can see this, and this is pretty much it. What exactly we are doing right now. So this sample shows you how to analyze CloudFront logs stored in S3 using Hive. So we are using Hive on EMR to analyze logs which are generated from CloudFront, but we are not going to do anything in CloudFront. That logs are already stored in S3, but not in mine, in AWS's official sample repository. So we are going to take that data, push it into Hive, and once it is in Hive, this script will run. This script will process the data and give us the output, and we can download it and check the acquired results. So to check that, first of all, you'll have to set it up. And before that, you can see over here, you'll have, so this script is creating a table. So it's creating a date. It's you can see local time, location, bytes, host, OS, and browser. So what we're going to do is we are just going to get the count
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Of the OS inputs. So coming down, you can see total requests per operating system for a given time frame. So what result we are going to get is, for example, there is Mac OS, there is Windows, there is Ubuntu, then there is Android. So all of that operating systems. So let's say in CloudFront, there is an application running. CloudFront is basically CDN. Okay. So let's forget about that. Let's just concentrate on this. There is an application running, guys. So that application could be accessed from all kinds of operating systems, from a Windows system, from a Mac system that is an Apple laptop, or from an iPhone, from a Safari browser, which is an iOS. Then there is Ubuntu. Then there is Android. So that application could be accessed from all these operating systems. So the output we'll be getting is how many hits were from each Windows or Mac or any operating system. So the output would be the operating system and the number of hits this particular application got from that operating system. So this data is already available, so it's not going to be dynamically changing. It is static data. Okay, so I think I've explained to you this part. Now let us start off with configuring this. So first of all, I'll have to provide the S3 location. So this is the S3 location. So I'm going to provide this. Done. Next is the S3 input location, which is this. I'm going to provide this. Next would be our output S3 location. So for this, we can search over here. And this is the bucket which should contain our output files. So I'm going to click it, select. Okay, next is the argument. I'm going to copy this and paste it over here. So now this action on failure is, if this particular code or this particular process fails, it should continue and create this particular cluster, or you can cancel and wait. So basically the cluster will be stopped and then terminate cluster. If this particular script we are running fails, then this cluster will be automatically terminated if you give terminate cluster, but I'm not going to give that. I'm going to give continue. If this step fails, our cluster will still be active. So that's what it means. So now I'm clicking on add. And you can see we've set this up. That is the only extra step. I'm just going to give next, next. I'm not going to change anything. Yeah, so you can review it once. So you can see it is proceed without an EC2 keeper. I'm going to give my keeper and create cluster. So guys, it will take from 5 to 10 minutes to create this. So you can see the steps over here. You can see first this step will be completed. That is, the setup will be completed. Then Hadoop and debugging, everything will be completed. Once that is done, the Hive program will start running within the cluster. Once that is done, we'll be able to see our output in this particular bucket. So if I open this bucket right now, you'll not be able to see. Let me just refresh. Yeah, so I'm inside the bucket. So right now there are no files inside this bucket. Once this is done, we'll be able to see that. So as I told you, it will take some time. So let me click on clusters. Here you can see I already had a cluster which I terminated. So you can see it is my cluster because once I went into advanced options, I did not change the cluster's name. So it was my cluster only. So it's the same. It is right now starting. And once we see complete over here, then this process will start. And once this is complete, this process will start. And only then we'll be able to see the output. So then we'll download the file and see the output, guys. So I think that's clear right now. So this process is still starting. So as I told you, it will take from 5 to 10 minutes to this getting completed. The thing is, we added a step before we launched. You can also add a step once it is set up. So you can see here, you can also add you can also add a step
once you've created your cluster, you can choose a pig program, a Hive, a streaming program, or a custom jar program. So if you want to add another Hive program, it's again the same setup, and you can do that. Okay, so we've seen this, it's still starting, so there is nothing else to do over here. Going back, okay, so while doing this, I'll also explain the other things about this cluster, because there is no need to waste your time as well, because it's everybody's precious time over here. Okay, so coming to hardware, you can see this because we wanted to launch 3 instances. One is one is a master instance, 2 core instances. You can see the 2 core instances are created. The master instance is currently under creation. And so right now we have not enabled any scaling policy. Let me explain to you about the scaling policy. So it is basically for auto scaling. Click on edit, come down. So you can see enable cluster scaling, use EMR named scaling. So come over here. EMR will automatically increase and decrease the number of instances in core and task nodes based on workload. So if the workload increases, it will automatically increase the number of instances. If the workload decreases, it will automatically decrease the number of instances. Okay, let me close this. I'm seeing running over here. Yeah, so the instances are running, guys. So you can check out the steps over here as well. You can see the instances are running, but the steps are still pending. So now this step has completed. So once the instance is run, it got set up in 4 seconds. If you want to check out this logs, just click over here. So right now there are no logs. So once the log is created, you can just refresh and see over here, and that logs will be available in S3, and you can go check out those logs. But this step is still running, and now it is completed, guys. So let's go over here, refresh this, and hope that we get an output. And we got an output. So let me open this folder and let me download this. Okay, sorry, that's not the folder which we want to download. We can download that, or we can go inside and download this. So the thing is, we have 2 nodes. So why do we have 2 nodes is that we'll be splitting work and giving it to each instance. That is, half or some of the work will be given to the first instance, and some of the work will be given to the second instance. So you see 2 files over here. So this file would have been processed in the first instance. This file would have been processed in the second instance. So now let's download. Sorry, I think that's not possible. Let me click download the first one. Click and download. Sorry, I downloaded it multiple times. Okay, so we've downloaded it. I'll go to the folder. So as I told you, the output would be the OS name and the number of hits. And you can see this. Let me open this as well. Yeah. Okay, I think you're able to see right now. You can see Android 855 hits, Windows 883 hits, Linux 813, Mac 852 OS X, which is for the Apple laptops, MacBooks. So it's 799, and in iOS it's 794. So we've got the files, guys, over here. So this actually means that our program ran successfully. We created an EMR cluster successfully. We ran a Hive program on it, and we also got an output. The thing is, this file is very small. That's why we got an output in less than a minute. But if your file is very, very large and it takes a lot of time to process, then obviously it will take around 10 to 15 minutes according to the size of your file. And sometimes it can also take hours, because you might have, let's say, petabytes of data. So going back over here, we have successfully created the cluster. We ran a Hive program, and both of the steps have succeeded. Let me just click here. Yeah, so both of the steps have been succeeded. So it is waiting, because right now there is no process running. If you want to add a process, You can click on step and add another program to run your program and process data. So you can do that. You can see all the interactive jobs over here. If there is any current job running, you can see the job. So for example, we were running this Hive program. So while running, we could have seen that job over here. So the thing is, this cluster can be shared among other users in my AWS account so that all of them can run a job at the same time, and we can check all the jobs running over here. So I think that's pretty much it. So it's pretty simple to start off with this. It's pretty simple to create a cluster, run your own program with your own input data set. The thing is, while running the Hive program, we gave an input data link. So instead of providing that link, you could provide your own data set, and you could provide your own Hive script, and you could provide your own output location. So output location is pretty simple. You can just give any location which you want, but the input script and the input data location should be provided, and that's it. It will automatically run the script and get your data processed. You can download the upload and take the data and do whatever you want with it.
Now what we are going to see is Terraform. So we'll have to understand few things before getting into Terraform. Now, this is my AWS account. Now this is my AWS account. For example, in this case, this guy is a system administrator. And this guy is a system administrator. Okay, who's handling this environment? Who's handling this environment? AWS Cloud. Now what happens? He is the one who set up all infrastructures in our cloud environment. All infrastructures in our cloud environment. Like it can be, he is the one who architected the design, and that a cloud application, cloud environment consists of EC2, VPC, and other services like S3, database, RDS, etc. etc. Now here, in this case, let's consider he is working for 4 years in a company. He worked for a company. He worked for 4 years in a company. Then, if he moves out of the company or the organization, if all of these environments, whatever he has set it up, if it doesn't have any proper, if it doesn't have any proper documentation, what will happen? A new guy who is coming, whoever is coming, will not understand what exactly it is, like how the infrastructure is being created, what is the purpose of what is the purpose of EC2 service, how many EC2 services are there, and everything will be in a mess. Basically, no, but the new guy will not understand how exactly the entire architecture is being designed or created. And the next thing, everything is a manual task. Everything is a manual task in the sense, here if I wanted to create 5 EC2 instances, I will have to create it 5 EC2 instances manually. The same way, if I wanted to create a VPC, I will have to create it manually. And everything is a manual process in creating all of these services using a console. So now whatever we are doing it here is all through console. So whatever I'm creating it here is all through console. Again, if I wanted to create an EC2 instances, what I will have to do? Again, I'll have to go launch an EC2 instance, and again I'll have to create it. Correct? In this case, a new tool called as Terraform comes into picture. It is not a very old tool at all. It was developed in the year 2014, if I'm not wrong. It was developed in the year 2014. Okay. Now, what this tool does it came up with a new concept called as infrastructure as code. Now, what we do, instead of creating it manually over console, so what we do is we create it as a code and we deploy it. Now what happens, anything which you created we'll have a trace of the code, correct? Like whatever, if I've created 3 EC2 instances, and I'll have a code of it, like so that, and moreover, what happens is it brings reusability. Like I explain you all those things, it brings in reusability. So all you do is you write code once and you use it multiple times. And moreover, it brings in automation of infrastructure. Automation of infrastructure. And how this code is being created, so they call it as HCL language. So the whatever the code which we write to create this environment is called as HCL. It's called as HCL language. And how do we do it? How do we create it? And we will see everything step by step. Use of Terraform. Terraform is to code your infrastructure. That is as simple as that. Like instead of creating everything over console manually, so what we do is we create everything using code. And what is that code? And that code is nothing but HCL. An extension of Terraform file is called as .tf files. .tf. Like for Ansible, we save it as .yml file, right? Likewise, any Terraform script will be saved in the form of .tf files. Now, using Terraform, what are all the services we can code? There are lots and lots of services which can be coded using Terraform, like major cloud platforms like AWS, Google Cloud, Azure, IBM, and then other providers, like for example, if you wanted to manage any other softwares. In nutshell, I can show you the list of providers which Terraform supports. Terraform providers. Now, using Terraform, what all we can create it? These many services we can code it. So if I wanted to create, for example, if I wanted to create, what are we seeing here? Let's consider if I wanted to create an SQL server. Using Terraform, we can create it. For example, if I wanted to create a chef cookbooks, I can use Terraform to create it. If I wanted to create Azure Active Directory, Terraform supports. If I wanted to maintain the entire AWS cloud or Azure cloud or Google cloud, everything is done using Terraform. GitLab. So whatever we have seen here. For example, let's consider a use case where I wanted to create a user in GitHub. Now what we do, we manually log into GitHub and then we create user, and then we whatever the permission which we wanted to assign it to the user, we will be able to do it. Now using using Terraform, we can do the similar setup also. See here, if I wanted to create any GitHub repository, I can create it. How we will create it, let's see. But whatever the manual task which we do using a console, which can be achieved using Terraform as well. And the main purpose of it is to code your infrastructure. How does it benefit? It benefits in such a way that we can keep track of every resource which we configure using Terraform, and also if we wanted to reuse the code. For example, I write the code once like function, and then it can be used later everywhere wherever we wanted. Now we need to understand few terms before we get into creating any services using Terraform. Those are here. The first one is resource. Resource is nothing but, for example, if I wanted to create an EC2 instance, let's consider I wanted to create an EC2 instance. EC2 instance. Now, what we define? No, before resource, let me put a few things, few other things also. Providers. So providers are nothing but which one we are going to use it. For example, it can be AWS, or it can be GCP, or it can be Azure, or it can be Redis, whatever it is. So whatever, what we are going to code using Terraform. So which one it is, and the structure, basic structure remains same, but the functionality wise it differs from providers to providers. For example, in AWS we call it as EC2 service. In GCP it is called as VM. Correct? Those terminology differs, but the core concept remains same. And the next one is resource. What is resource? Let's consider we are using AWS provider. We are using AWS provider. Inside AWS provider, I wanted to create an EC2 instance. In this case, what we do, we create a resource. This is called as resource. Any services inside your provider is called as resource. Whatever we are trying to create is then it's called as resource. Variables. So variables are nothing but an input value which can be defined while writing our Terraform script. Output. Now, output is the resultant value. For example, using a provider AWS, I'm creating an EC2 instance. Okay, let's consider an input value I'm giving. So, if I wanted to create an EC2 instance, what all is required? If I wanted to create an EC2 instance, now what we can do is we can input these values while creating our EC2 instance. That is nothing but variable. And the next one is, for example, after creating this EC2 instance, it will come up with some values. For example, instance ID, correct? Automatically it comes up with. Then instance IP address. And these are the output values. So whatever the input values which we are giving it, from that we will get an output value. So that is called as output. Okay. Terraform plan. This Terraform plan is a command. Okay. Terraform plan is a command. In the sense, for example, these code using all of these all of these things, I've created a Terraform script. Now I wanted to test that script before I actually apply it. In that case, what we will do, we will run Terraform plan. So Terraform plan, what will happen is it will just do a dry run before we apply it. That is what Terraform plan. Terraform apply. So Terraform apply is a command which is used to apply all your changes. In the sense, if I wanted to create any EC2 instances, first what will I do? I create the Terraform script. Then to test it, I will run Terraform plan. Then if everything looks good, then what we will do? We will we will then run Terraform apply. Then Terraform apply will apply all your changes in the script. Then Terraform destroy. So destroy will delete all your changes, whatever is there in your, delete all your changes. And the next one is Terraform init. Here, let's consider we are using AWS provider, correct? Now here, let's consider this is your machine from where we are running all of these scripts. Now here, all we would have done is installed Terraform into this machine. Now I want commands which is specifically for AWS, correct? Only then AWS related configurations will work. In that case, after writing all your code, first you will have to run Terraform init. So what it does is it initializes all modules or all the required modules which are essential to run your script. That is nothing but Terraform init, which initializes all your modules which are required to run your service. I mean, run your scripts. That is nothing but Terraform init. Then what else is required? Very important thing is TF state file. Name itself says, in the sense, TF state file is nothing but a state file which holds all configurations of whatever you have created using Terraform. In the sense, for example, I wrote a script where it creates one EC2 instance. Okay. Now, in the same EC2 instance, I mean the same script, what I'm doing it is I'm creating one more EC2 instance. Now, first one EC2 instance configuration is already added. It's already there. Correct. Now I'm adding second one. In this case, what it should do, it should not create the instance which has been already created. All it has to do is it has to create only the second one. How Terraform will know that one instance is already being created and only the second one has to be created? And in that case, state file comes into picture. So any configuration which you run, it first checks with your TF state file whether all of these configurations are matching your TF state file and with the current configuration file which you have written. If anything is missed, then it will create the required services. So that is the function of TF state file. Cool. Now, and this is one of the most predominantly or widely used tool in DevOps industry at this point of time. Till now, any infrastructure related activities are handled manually. Now everything is being coded, and Terraform is one of the important tool which is being used in the industry, and I would really recommend you guys to go through it. So we'll use AWS for our configuration. What is the first step? First step is to install Terraform on your machine. Now what I will do, I will use one of my EC2 instance which I've created. Okay, first what we'll do, let's install Terraform on that machine. So how do we do it? All you'll have to do is download Terraform. You will get the version of it. So all you can do is whichever version you wanted to install. If you're trying it in your local machine, you can use you can download Windows and then try it. Or if you have any Windows machine, just download accordingly. Let me download this one here. Copy and then wget. Yes. Now I've downloaded the file, and then you will see something called as this. Then what you need to do is you will have to move this file to, if it is Linux machine, move Terraform to user local bin. Then what you will have to do, check then cd space user local bin. Then once it is done, Terraform. Why it is not running? Terraform to user bin. Okay, so you will have to move, just download the file, just copying it and just writing it here so that then move the file to move unzip, first unzip, second move the file to move Terraform to user bin. Once it is done, you will be able to you can check and verify with the command terraform - and the latest version is this one. 12.24 is the latest version which is available. Now we are set with this. Now what is the next step? Let's consider we wanted to create an EC2 instance from this machine. In this case, what we will have to do is, now one logical question. Okay, if I wanted to manage this account, what is required? For example, if I wanted to manage this AWS account using an CLI, what is required?
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session. Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue.
So what we need to do is, we need a credential where we can manage the account using our Terraform or whatever it is. For that, what we will have to do, first we will have to go and create one user. If somebody is new to the cloud, so what you'll have to do is go to service, IAM is the service which is used to create your user accounts. Then go to users. Then I'm creating a user with the name Terraform. So all it needs is just programmatic access. So I'm just giving programmatic access and then click next. Here, what we'll do, we'll attach existing policies directly. We'll give administrator access so that using the Terraform account, it can do anything it wants over this account. But in real time, you will have to come up with a best practice solution where we can actually give access to the console in a better way for any programmatic access. Now let me name Terraform, just Terraform, and then click review, create user. And then let me download the credentials and click the close it. Now here what we are trying to do, so we are trying to create an EC2 instance using this. So what I'm doing it is I'm just going to one directory, and then what I'm doing, I'm creating one directory, mkdir, and then as and then I'm going into that. I'm creating one more directory, mkdir. I'm creating DevOps. So in this directory only, we will have all our configurations will be in this directory. Correct. Here, what we'll have to create, we will have to create one file called as main.tf. Let me create one file here. In this, let me get into this file, insert. Now, what is the first step? If we wanted to manage, we will have to define provider and mandatory. So now, first what we will do, we will define our provider here. We will define our provider here. Version is nothing but, earlier they were using 2.2 version 2. With 3 they have included so many other new services also, like ECS cluster, so many other services we also included in version 3 with new features. That's it. Now what I'm doing it, I'm just doing this one. That's it. Greater than or equal to 3 and provider AWS version region. Now it is done. Now what we will have to do, we will have to download that provider into our machine. How do we do it? Which command we use that to initialize all modules? Terraform init. So okay, now we know that we wanted to configure AWS account. Now how AWS, I mean, how this Terraform will know that which AWS account I will have to manage? It will not know, correct? In that case, what we will have to do, we will have to configure credentials of that AWS account with this Terraform. How do we do that? In.tf. So what are the keys which we have created? Just give me a moment. Access key ID. What was that? Now here we will have to give our credentials, whatever we have created. Access key ID, shift insert, pass your access key ID, and then pass your that's it. Good. This is our configuration now. This is our configuration. Now let's create an EC2 instance. Let's create an EC2 instance. Now our Terraform is ready to configure our AWS account. Correct? Now here what we will do, we'll create an EC2 instance using Terraform. So how do we do it? you can either use main.tf, or if you really wanted, no, you can create multiple files also. At this point of time, let's not do that. What we'll do, we'll continue editing our file. If I wanted to create any resource, then what I should use? I should use a resource, correct? I should use a resource. Now let's go and get the what we are trying to configure. We are trying to configure EC2. I'm trying to make it simple so that you understand it. That's it. So this one we have seen, right? Access key and secret key. Now, access key and secret key is unique to each and every account. For example, I have an AWS account. You also have an AWS account, and others will also have their own AWS account. Now, using Terraform, how will I define which AWS account I will manage it? And that is where a access key secret key comes in. Okay, now let's see now what it does. AMI is nothing but, like, for example, AMI is nothing but, like, when we launch an EC2 instance, what we do, like, see, whatever we're doing whatever we're doing it here manually, we are doing it there also. We select an AMI, right? So instead of just selecting over console, so what we do is we give an AMI ID. Every image has an ID. Every image has an ID, and that is what we are giving it here. Okay. Now, what are all the features it supports? Let's consider if I wanted to create an EC2 instance. These are the arguments which you can pass in the sense which availability zone you wanted to pass, like US East 1A or US East 1B, everything. Now, at this point of time, what else is required? As mandatory, what else is required? We need key, correct? We will create key name. So these are the arguments which are being passed to the script so that we can create an EC2 instance. Now let's consider key -name, which is nothing but I have one key which is DevOps, and tag is nothing but the name which we generally we give while creating an EC2 instance. Now name equal to, let's consider Terraform first instance. Terraform instance. Terraform instance. Now our first script is ready. Now what are we are doing? See, this AWS underscore instance is the keyword. Which resource is what which we are creating? Which resource which we are creating here? We are creating AWS instance. This is the name of the resource which we are giving it. Okay, and for this AWS instance to launch an EC2 instance, what all is required? We can pass. See, anything required is mandatory. These arguments AMI and instance type is mandatory. To launch an EC2 instance, these two parameters are mandatory. Other than that, we can customize all other configurations. All other configurations we can customize it. Now, till here we are done. A resource AWS instance, Terraform, AMI we have given, instance type we have given, key name we have given, and then we have given a name for this EC2 instance. Okay. Now, what is the next step? We will have to Terraform plan. Correct. So why do we do Terraform plan? So we run Terraform plan to check whether all our configurations are done properly or not. Let's do it here. Now here, see, it is asking in which region we will have to configure it. You remember? So while configuring providers, there was one option here, region, correct? Which I have deleted it. Region. Now here you can define your default region. US East-1 is Virginia. I have defined it here. Now if I run Terraform plan, US East-1. Wait it is showing error. Because key underscore. Now what will I do? Terraform. Now what it says? It says new mission will be launched. So this will be the configuration. Now what will I do? So how will I create a new machine here? I mean, if I want to apply these changes, what will I do? What will I have to do? Terraform apply. Which command? Apply. Terraform apply. Now you will have to give yes. The moment you give yes, it says error. No subnets found for the default VPC. Please specify the subnet. Now what happens is, since whatever we have given it here, it tries to launch it on the default subnet. Now what I've deleted my default subnet. I will delete it when you look at here VPC. See here, I've deleted the default subnet and I've created my own subnet. With that configuration, what it does is, so whatever we have done here, it tries to create this EC2 instance in the default subnet. Now that is what we got an error. See, for launching source instance, missing no subnets for the default VPC. Please specify the subnet. Now what we will do? We will go configure main.tf, then include one more configuration, which is nothing but subnet. Let's check whether it is right. Subnet underscore ID. That is the argument which we will have to pass. And this is the subnet ID. Now again, what we will have to do after making changes, Terraform plan. Okay, now if you look at here, it will say that subnet ID is this one. Correct? Earlier, when you look at, you would have not seen that. Now Terraform apply. Cool. Now we can see that one resource is added. Let me go to my EC2 instance. Earlier it was one instance running. Now it is two instances. Second this instance is running here, and whatever configuration which we have given, it has come up. Now you can see one thing here. It did not have any public IP address. Correct? It did not have any public IP address. Now in this case, what we can do, what is required if I wanted to connect to this machine, a public IP address is required. Correct? Now let's create a public IP address for this machine and then attach it to it. Now in this case, Terraform apply is already done. Earlier you will not see one file called as terraform.tf state. After you apply your first change, this file will get created, terraform.state file. What is the purpose of this terraform.state file? It maintains all the information about your configuration. This is your instance ID. See, this is your instance ID. The state file maintains all information about the resources which are configured using Terraform. Now let's see. Now what is the second requirement? If we wanted to attach any public IP address to that machine. Of this machine. Okay. Now in this case, what we wanted to do? Any guesses? If I wanted to create a public IP, there is a resource called as AWS EIP. Correct? There is a resource called as AWS EIP. Just go there. Here, what will I do? Create and so this. Now what we are doing? Here we are creating one more resource, which is nothing but AWS EIP, and let's name it as Terraform instance EIP. Now this is nothing but getting a value of, this is how we get value of other machine. So whatever we got it here, see the whatever we are getting it here, what is this? Syntax is the older version syntax. Here we don't need that. This all of these things are not required. Now what I need, to which machine we are attaching this elastic IP? To this machine. Correct? And what is the resource name? Which is AWS underscore instance. And what is the name of the resource? Which is Terraform. It is Terraform. And ID, to understand that, we will have to understand a bit about what are all the values it results. Let's consider, where is the EC2 instance? AWS instance. See, attribute reference is nothing but what are all the values it can result. In the sense, see, what are all the values you get it in your TF state file. Terraform.tf state file. Here, what is that? ID, correct? See, this value, it results from this configuration. What is that configuration? This value holds this machine. Now what we are doing it in this configuration, I'm creating one more service which is nothing but EIP, and this will after creating that elastic IP, it has to be attached to this EC2 machine. How do I know that to which EC2 machine I will have to attach? using this configuration value, AWS instance.terraform.id. This ID actually holds what? The value of that machine, which is nothing but this one. This actually, this one, the value, this one, let's consider if I run this value, what will happen? Terraform plan. See what happens. It creates an EAP and then attaches and gets attached to that EC2 instance. Same way, what will happen? Let's see if I give that value. I'm replacing it with, so these are dynamic values which we can get it. How do we get it? AWS underscore instance underscore dot terraform dot id. Now again, if I run terraform plan, see, we got the same value. Now let me apply it. Terraform apply. Ask for check, select yes. Now you don't see that public IP, any public IP is being attached here. Now if I refresh it here, see, one IP got attached to it. And this is how it works. Now, if using the same concept, what we can do is we can create any number of services which AWS provides with bit of fine tuning that is required. That is required according to a configuration, the best practices which we follow and everything. Now, let's talk about something called as variables. Now, the same concept is same. Variable is nothing but if you wanted to input any variable, then we use concept called as variable. Correct? If you wanted to pass any values from the user or get values from the user, then we define variable. And how do we do it? There are multiple ways to do it. One, what you can do is you can create a file called as variables.tf, whatever it can be. I'll give it as inputs.tf. Inputs.tf. You can create the same method also. I created with the name inputs.tf. So what we can do is, let me get some values from the user. Why do we have to give this value automatically here? If I give, everybody can use it, right? So what we can do is, we can define it as a variable so that it doesn't being exposed. Now what I will do, I will define it in such a way that give var dot access underscore key and then var dot secret underscore key. So in this case, after defining it here, so go to inputs.tf file, we will have to define that variable. So how do I define that variable? Key name is variable and give the name variable. Let's, what is the name I'm giving? Access underscore key. Then open bracket and then go close bracket and then name is, we will have to define which variable type it is. Now what variable type it is? That is string. And there are different types of variables also, like list of string, maps of string, tuple of string, lots of other things are also there. this point of time, let's not get into that level. So the value which we require there is string. And how do we do it? Type equal to string. That's it. The same way, we have one more variable also, secret underscore key, type equal to string, and then close it. Now with this, what happens? Now let me check the configuration, whatever I have done, Terraform plan. See, now here it asks for the value. What is the value? var.access key, which I will have to give it from. And then secret value. And that's it.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
So, introduction to AWS DevOps. The first thing is, why DevOps on AWS? So you can use DevOps on any cloud service or even on your on-premise environment. So if you have a business running, you will have an on-premise environment. You might have an infrastructure for yourself. You can run it on it also. But why AWS DevOps? That we'll see moving on. So first, what is AWS DevOps? AWS DevOps is a set of developer tools which is provided by Amazon Web Services. This allows us to create a CI/CD pipeline from the scratch to the deployment stage, that is from the source. For example, a version control tool, maybe GitHub, maybe Azure repos, maybe AWS code commit. So from the source stage till the deploy stage, we can do everything. It is the same as any DevOps tools, any DevOps lifecycle or any DevOps process, but the tools are provided by AWS. And then, so why AWS for DevOps? What are going to be the benefits of using DevOps on AWS? So the first thing is fully managed services, guys. So we know why do we use a cloud service? Because we don't want to manage our tools or the VMs we have launched, the data we have stored. We don't want to manage it, or we don't have to install softwares on it. We don't have to do anything. It is all taken care by AWS. They take care of our infrastructure. So that is the first reason, guys, fully managed services. And then built for scale. Because AWS DevOps, you will be using it on existing services like EC2 or Lambda. So when you use on them, they already have a scaling feature within them. So obviously it is built for scale. So you can easily scale it up or down. And then programmable. You can write scripts, you can write shell scripts, you can create a program which you can implement inside AWS developer tools, which can actually impact your DevOps lifecycle. And then automation. So DevOps is mainly automation. So automation is one of the main reasons, and automation is available in everything like Azure DevOps, AWS DevOps, even in GCP. If you are implementing DevOps, automation will be available over there. Or if you manually use DevOps tools to create a DevOps lifecycle, even then automation is required. So DevOps main motive is automation. And then secure. Yes, AWS provides security and it is their first priority. And then pay as you go. Pay as you go model is that whatever you use, you only pay for that, nothing else. For example, you launch a virtual machine using code deploy. So that virtual machine is running for 2 hours and then it gets terminated. So you'll have to only pay for that 2 hours time. You don't have to pay for creating a virtual machine and running it. You don't have to pay a month's fee. You just have to pay the money for that particular 2 hours. So moving on. Now we've discussed what are the benefits of having DevOps on AWS. Now we'll see what are the tools provided by AWS. So these are the 4 tools provided by AWS, guys, and these are the most basic tools. There are still more tools for developing, but these are the 4 most basic tools for creating a DevOps lifecycle. So the first one is code commit, and then code build, and then code deploy and code pipeline. So let us discuss them. Let's discuss these developer tools in detail now. So first let us discuss code commit. So the name suggests that code commit is a version control tool. It is like GitHub. So it is like Bitbucket. It is a version control tool, guys, but it is provided by AWS, and it also provides the same features GitHub provides or Bitbucket provides. You can do all of those stuff which is available over there, like committing, pull requests, merging branches. You can do all of it even using code commit. You can also see over here code commit allows 5 active users per month. So basically this is going to be your private repository. So it allows 5 users per month. If you have a startup and you only have 5 members, you can actually use code commit and you won't be charged even a single rupee. And also you will be given 50 GB of space every month. So for example, our repositories maybe maximum of a size of 1 MB or 2 MB, but 50 GB, they provide 50 GB of space for the repository, guys. And also 10,000 Git requests per month, like pull or push requests. So this is code commit. It is a tool. It is like GitHub. It is like Bitbucket. It is the same kind of tool, but it is provided by AWS. And then AWS code build. So the name suggests that this tool is for building your application. So it provides a fully managed CI service, that is continuous integration service. It will compile your source code. You can run tests, you can run unit tests, and also provide software packages and store it in AWS S3 so that you can take out those packages and use it to deploy your application. So you can see here AWS code build, 100 build minutes. That is, if you run a build, it might run for 20 seconds. So like that, you can run any number of builds which come up to 100 build minutes. And also it runs using build.general 1.small compute type usage. So it runs with this, and for every month you get 100 build minutes free. Moving on, AWS Code Deploy. This is one of the important service, guys. This service is used to deploy your application on any service you choose, like EC2 or Lambda. So it is an automated deployment tool which can deploy services like EC2, Lambda, Beanstalk. So even if you launch Beanstalk, it will be launched in an EC2 instance or Fargate, and also your on-premise setup. So these are the 4 benefits provided by AWS Code Deploy. So first is automated deployments, and then minimize downtime, centralized control, and easy to adopt. So the first one is automated deployment. Says when you set it up, whenever there is a change in your repository, it automatically runs again, it builds your code again, and it gives it back. So that's what automated deployment means. It doesn't build and it stores, it actually deploys it again. Whenever there is a change in your code, it deploys and the change will be visible in your website. And then minimize downtime. So whenever the code is changed, it takes very less seconds. Your website will be down for maybe 1 to 2 seconds, and the change will be on your website, guys. So it minimizes the downtime. For example, when you do it manually, you will have to go to your system or your server where your website is launched, and you will have to change your code over there. When you do that, the downtime increases, but using Code Deploy, you can minimize that. So I'll show that in the demo, guys. And then centralized control, you can just use your command line interface of AWS or the management console, and you can control all of the operations happening in Code Deploy, Code Commit, and Code Build. And then easy to adopt, you can see works with any application, and same experience whether you're deploying it on EC2, AWS, or Lambda. That means whatever service you are deploying it to, maybe EC2 or Lambda or Fargate or Elastic Beanstalk, it provides you the same UI with the same experience. So it doesn't change, it is the same thing, but the deployment environment is different. So this is code deploy, guys. And then finally, AWS Codepipeline. So we are going to use Codepipeline. We can use Codepipeline to create a CI/CD pipeline, guys. We can use all those services to do that. So first thing, it is a continuous delivery tool. That's why it is called a CI/CD pipeline. So it is also fully managed by AWS. As I told you, that is one of the benefit. And also you can automate your website, or you can automate your application which is running on code deploy. So when you create a pipeline, whenever there's a change in code, it automatically pushes it to code deploy and the change will be made. So that's how you use Codepipeline, guys. You can see over here, take it as an example pipeline. You have some website over in your source, that is your GitHub. So you build it and you test it using some programs. So after testing it, you can give any number of stages. This is staging. This means you will be seeing this deployed, but you will be seeing it in a IP address which only you might see. You might have given the security group like that. But in production, when it gets deployed in production, then you can view your website using the IP address or the DNS name from any other computer, guys. So this is how you use AWS Codepipeline. And then, so you can see over here, easy to integrate AWS Codepipeline with GitHub or with your own custom plugin. So you can integrate GitHub and Codepipeline easily. You can just click on connect to GitHub. There is an option for that. Or you can use your own custom plugin, like you would have created something in Bitbucket or any other version control tool. You can even use that. And then also it is pay for what you use. It's the same thing, guys. And also there is no upfront costs or long-term commitments. So it is basically free. Whatever services you launch using it, for example, the EC2 instance, so those are charged, not these services like pipeline or code deploy. And also rapid delivery, which basically means whenever there is a change in your code and it is applied to the master branch, it will be applied to your website directly. And then configurable workflow. The workflow, you will have an UI. You can configure your workflow, how it should happen, which is the deployment server, which is the production server, which is the QA server, or you can mention builds or you can skip builds. So you can create a workflow for your own advantage and then get started fast. This basically means it's pretty easy. They have a lot of documentation, guys. You can just go on, create your own pipeline in no other than like half an hour. So it takes only that much time. And then it is easy to integrate. You can integrate AWS Codepipeline with any service. You can integrate with even Jenkins. So this is what they say, easy to integrate. So right now let us move on and let us create a CD pipeline using Codepipeline and code deploy, guys. So let me open my GitHub repository. So let me close this. So this is the GitHub repository which I am going to use, guys. So you can see over here index.html, abspec.yml, readme. This is the readme file, and then I have some scripts. So first I'll show the index.html file. So it is basically a hello world HTML. And then the next thing, the most important thing is abspec.yml. So this is a YAML file. So what it does is, you can see over here, the source is index.html. Destination is this. So this is where Apache 2 installs its
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Index.html file, but we'll be deleting that file and launching our Hello World application. So you can see here before install, script/install dependencies and script/server, start server. So I'll show that what actually is there. I'm going to scripts, install dependencies. So in install dependencies, you can see, guys, it updates the instance. After updating the instance, it will install Apache 2. And also, guys, in your script, make sure to provide -y. This means yes, because you cannot go inside and click enter yes. So whenever you provide -yes, it will automatically take the command as yes and it will install the whole software. So whichever software needs a yes, provide a -y, guys. So if you don't provide, it will fail. And then it will remove the index.html file in. So it will remove the index.html file in this location that will be created by Apache 2, and that will be the Ubuntu default page created by Apache 2, but I don't want that page to be launched. I want my page to be launched. That is my hello world page. So these are the stuff I wanted to show you. Appspec.yml, I'll show why we need that, where it will be used. So now let us start off with our management console. So the first thing we'll be doing is we'll have to create a code deploy, guys. So I'll go to code deploy first, and also I'll open. So if I go to code deploy, basically you can see all of this over here. You can see source, repositories. You can actually create a repository, guys. To create a repository is very simple. You can just provide a name, for example, website. And then if you want, you can provide a description, or you can just create. That's it. But one more thing, you cannot use your repository from your root account. You will have to use it from your IAM user, which you can create, but you cannot use it from your root account, guys. So I'm not going to use this. I'm directly going to use from my GitHub. So this is it's actually pretty simple. And then build is for as I told you, it is for building your application. But right now I'm launching my website, so I'm going to use only code deploy and code pipeline, guys. So first thing we'll have to do is we'll have to create a, here you can see EC2, then AWS Lambda and ECS. I'm not going to use Lambda or ECS. I'm going to use my EC2 instance. So you'll have to click on EC2 and then create application. You'll have to select it over there because we'll be creating a deployment group which will be targeting the EC2 instance which we mention using tags. If you want to use Lambda, you can choose that also, but I want to use my EC2 instance, guys. So now we'll have to create a deployment group. But to create a deployment group, we will need a EC2 instance. But currently I don't have an EC2 instance, guys. So because we'll have to mention EC2 instance over here, I'll have to mention my tag over here. So before moving on with creating a deployment group, I'll create a EC2 instance. So first, what is deployment group? So deployment group is it directs or it targets to which instance should this particular code deploy application should deploy the application to. That is the website. So deployment group. So let me create the EC2 instance first. Let me teach you how to do that, and also how to install code deploy agent in that, because without installing code deploy agent in your instance, you will not be able to use code deploy for your instance, any instance which you use. So I'm going to use a Ubuntu server, guys. So I'm going to EC2. So I think you would have learned how to launch an instance from our other videos which are available in our channel. So currently I'll not be explaining each and every step in creating an instance, but I'll teach how to create an instance which will benefit in using code deploy. So the first thing you'll have to do is you'll have to go to EC2 dashboard and then go to instances, click on launch instance, guys. So you can see over here, choose AMI. AMI is Amazon Mission Images. Basically this means the ISO file. That is, you can see this is Amazon Linux, this is Red Hat, this is SUSE Linux, this is Ubuntu, and also you'll be having Microsoft Windows. So you can choose any of this and launch the server. But I want a Ubuntu server, guys. I'm going to launch my website in my Ubuntu server. So I'll be selecting this. And then these are instance types. You can choose any instance, but I'm going to go with free tier eligible instance, t2.micro, which doesn't cost me any money up till 750 hours every month. So you can use this particular instance. You can run this instance for 750 hours every month. So I'm going to go with t2.micro. Next. And here number of instance, I just need one instance. And then one more thing, guys. This is the most important thing. You will have to include a IAM role. So why an IAM role? Because the code deploy agent should access your EC2 instance, and also the EC2 instance should be connected to your code deploy agent. So to give a connection between these two AWS services, you will have to attach an IAM role. I already have created an IAM role, guys. So I'm just going to go to EC2 code deploy. If you don't have one, you can just go over here. I'll tell the basic how to create a role. So role, create role. You will have to choose the service which you are creating the IAM role for. So EC2, next permissions, and here you will have to provide code deploy. So you can see Amazon EC2 role for code deploy. You can just choose this, and next you can provide a name over here and create the role, guys. So I already have created a role. So you can see over here EC2. So I already have created a role using that particular permission. So I have created, if you want you can create it. If you already have, you don't need to. So I have it, I chose the IAM role. And then also I'll have to enter user data. So what does user data mean? So basically user data is the commands or scripts which you want to run while the instance is being created. Once the instance gets created, these commands and these scripts will be automatically run. So we don't need to open the instance and run all of these. This will be automatically run if you enter the user data over here. So I have the user data over here, guys. You can see over here, basically it will update my instance. It will install Ruby. Actually Ruby is required for code deploy. And then if you want, you can install wget, or wget is already available in your EC2 instances. And then I'm going to this location, and there I'm going to install my code deploy. After installing that, I'm just modifying my permissions, and after that I'm installing code deploy, which got downloaded. After it gets downloaded, now I'm starting code deploy, guys. After installing code deploy, I'm going to start the code deploy service. Only if it is started, then I can connect my EC2 instance and code deploy. So I'll copy these and enter it in code deploy, guys. That's it. So this is what we have to enter, and you can see over here it asks for, I've given -y. So basically -y means yes. So when you install Ruby, it basically asks yes. So providing -y doesn't affect that. It will provide yes automatically. So we've done all of the required things over here, and then adding storage, 8 GB is more than enough. And then you'll have to add a tag, guys. So to add a tag, hit on add tag. Then I want to, the key is going to be name, and my value is going to be web server. So this is going to be my value. Why I am creating this tag? Because I'm going to use this tag to, so I'll have to enter this tag over here so that this code deploy identifies this particular instance, guys. So moving on, next, configuring security group. So already SSH is available, but I actually don't need to SSH into my instance. But right now I'm going to allow an HTTP rule, because I need HTTP, because I'm launching a website, guys. My website needs HTTP. Without HTTP, my website will not be able to be seen using a URL, and also it can be seen from any IP address across the world. If they are using my IP address from any browser from anywhere in the world and through internet, they can see my website, guys. So reviewing and launching it. This is just for making sure if everything is right. So I'm good with it. And you'll have to choose the key pair, guys. If you already have a key pair, you can just choose the existing key pair and move on and click on launch instances. And now your instance has been launched. So you can just go to view instance. You can see my instance is being created right now. It's in pending state. So only if this is running. So right now I think I can see it over here. So right now just I'll go back. And now let me start creating this deployment group. So my instance, let it get created. So my deployment group name is going to be web server deploy. So web server deploy 1. And one more thing, you'll have to enter a service role, guys. This service role allows this code deploy to connect with EC2 and other services like S3 or whichever you mention. So I have this service role. You can also create a service role for code deploy. So I showed you how to create a service role for EC2. So this shows how to create a service role for code deploy, guys. And then let it be in place, and then environment configuration. In environment configuration, you will have to mention whether you're going to connect your auto scaling group or your individual EC2 instances or your on-premise instances. I'm going to connect my EC2 instance, which is running right now. It is initializing, guys. So right now, if I just hit name, and you can see many values. My value was capital W web and capital S server. So I'm going to choose that. So now you can see there is one matching instance. If I click here for details, you can see over here, and my instance is showing. So this is the instance and it is showing, so that I have connected this code deployed group. So it is connected with this particular instance, guys. My deployment group targets to that instance. So now I'm good to go. And here you can see deployment settings, deployment configuration. So one at a time, half at a time, all at once.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Why should you become a cloud engineer? Now guys, let's start off with a basic necessity. What is the salary that a cloud engineer actually earns, right? So let's talk about that. So what we have done is we have basically collected data from a lot of sites which basically do job postings. We have done it from ZipRecruiter, we have done it from Indeed, we have done it from Glassdoor, and this is what we have seen. So in the US, a cloud engineer, an average cloud engineer basically earns $128,000 per annum. In India, an average cloud engineer earns around 7 lakh rupees per annum. And in the UK, you have around 60,000 pounds per annum. Okay. So guys, this is an average salary. Now, based on your experience, let's say you have a 10 or 12 years of experience in the IT domain and you plan on to shift onto the cloud sphere. In that case, you might even get a salary up to 20 plus lakhs per annum in India, right? I'm just talking about with the limited experience that I have. So I have friends who have salaries for 25 plus lakhs per annum, but that given that they also have a very strong background in the IT domain, right? I also have seen people who have basically shifted from non-IT domains and they have started in the cloud sphere. And even in that case, given that, you can implement what you have learned in your past experience in the cloud domain, they easily can grab a salary of around 12 to 15 lakhs. Based on their experience, right? So these are the two things that I talked about. The other thing is it also depends, like I said, on your experience. And if you're a fresher and you're just starting out, and you're thinking of basically starting off with the cloud domain, you can easily earn around 4.5 to 5 lakhs per annum if you are a fresher, given you don't have any experience in the industry and you are just starting off as a cloud engineer in this space, right? So this is the salary that you get when you basically become a cloud engineer, and based on your experience, you can expect a different or a varied salary exposure. Okay, moving forward, guys. Now let's talk about the things which are important for you to get a higher salary. Now, how do you differentiate yourself from the people who are also there appearing for the same profile and are there in the interview room? So what differentiates you is your certification. So what are you certified with? Are you certified from AWS? Are you certified from Microsoft? Or are you certified from Google Cloud? Now, these are the top 3 cloud providers in the market right now. And each and every company who works on cloud would have their product on any of these cloud, right? And basically that is the reason any company who is basically expecting a cloud engineer in their firm, they would expect you to have a certification from either of these 3, right? And once you get certified, that basically tells the company, okay, so now you're certified in this particular domain. We now know that you know cloud up till a particular proficiency, and then they start asking questions from that particular level. Now, this might not be helpful for some people who have a hybrid kind of a profile wherein they are working as a software developer full time and they also work on cloud for some part of their project, right? But if they try to shift their domain, they might get a job even without getting certified. That is also possible. But usually certification helps you when, let's say, you are working in a domain where cloud is not at all used, right? Let's say you're working as a system administrator and let's say you're working for a company like IBM which have their own private cloud. So what you don't have experience in, or what you cannot put in your resume, is that you have worked on AWS, you worked on GCP, you have worked on Azure on certain projects. That you cannot put. So for people like these, for people who don't have the working experience in these domains that are AWS, Microsoft Azure and Google Cloud, if you are planning to become a cloud engineer, you would be to get certified in these cloud domains, right? So once you get certified, that basically tells the company, even though this person has not worked on production for these clouds, this guy has been basically certified by a parent body of the cloud provider. For in our case, let's just talk about AWS. So in case of AWS, the parent company is Amazon. So Amazon certifies this guy that he's proficient in their cloud infrastructure, right? And this is what the certification tells me. Now, on this certification, obviously, you'll have to also do some projects that you would be doing independently, and that you'll have to add to your resume. And that is how you will tell the company that you're appearing for that I have done some projects in cloud, although I did not get the time while I was working in my company in the production environment. But this is what I've done in the side time of mine, right? I've done these projects and I've also got a certification from this company that I am a solution architect or a developer or an administrator, whichever certification you do, right? So a certification is very important, and with the certification you can expect a salary hike, right? And the average salary which we have discussed, this 139,000 is just a number, but whatever we discussed, you can aim for those salaries given you don't have the experience in a current company with the certification. So you will have to get certified if you want to become a cloud engineer and you don't have the relevant experience right now. Okay, moving forward, guys, now let me tell you some of the average salaries based on the certifications. So if you are an AWS certified solutions architect in the US, you can expect around $130,000 per annum. If you are a AWS certified developer, you can expect around $130,000. And if you are a Microsoft Azure certified solutions architect, you can expect around $121,000. Now, all these salaries are basically the average salary. So what I can tell you is from $120,000 to $130,000 in the US, you can earn once you get certified by these companies and given you have the relevant experience. Okay. Now, you might have noticed over here that you have something called as a solutions architect, or you have something called as a developer, and all of these are basically certified by AWS. So what are these? Now guys, for the people who are from the IT domain, and if they want to make a shift to the cloud, and you also want to bring along with you the experience that you have in the IT industry, what you can do is, let's say you are a developer right now. Okay, and what you want to do is you want to become or you want to do development in AWS with, let's say you have an application on Node.js and you want that Node.js application to interact with some services on AWS. So what will you have to know? You'll have to know some SDKs, you'll have to know how to interact with AWS APIs. So all that knowledge is basically gained by a person who is a AWS certified developer. When we compare him with a solutions architect, the solutions architect job is not to code. So most of the people that I've trained or that I know basically are solutions architect. The reason for that is when they started off in their IT journey, they did not know much about cloud. And they started off as a normal software engineer or a system admin or something like that. And now for the people who don't know coding, right, and they still want to be in cloud, people can easily crack the solutions architect profile. The reason for that is in the solutions architect profile, what you have to know is how to plan things. What you have to know is how to architect applications without knowing the actual implementation of the code. So that is what the solutions architect profile is. But mind you guys, this profile is super tough as well as you progress in your career. So you will find architects who were developers before, who were system admins before. They have the complete knowledge of the inside and out of the product. They can code also, and they also know how to plan. So those kind of people are also solutions architect, and obviously their salary are on the higher range. If I talk about a solutions architect who knows coding, who knows in and out of the application, and knows multiple clouds, his salary can go up to 40 plus lakhs per annum as well in India, right? So that is the kind of scope that you have when you get yourself acquainted with AWS. It's a journey that you'll have to start with, right? But you will even find solutions architects who are sitting at 4 or 5 lakhs per annum. And those people are basically freshers who have joined the industry and they just know AWS, right? You will also find solutions architects who are around 14 or 15 lakhs based on the experience that they had and now they have shifted to cloud. So based on your experience, you can go up the ladder, right? The Certified Solutions Architect Associate is just a certification, but what matters is what experience you're bringing to the table, and that just makes everything change, or that makes the dice rolling when you're basically applying for a job. Okay. Moving forward, guys, now let's talk about what is the cloud engineer role. So we have talked about why you should be a cloud engineer, where I talked to guys about. We have talked about the money aspect. Let me also give you one more aspect, guys, that Forbes or some independent body, we are going to discuss about it in the future, in the next couple of slides. But they have predicted that whatever revenue cloud is earning right now in 2019, by 2023, that revenue itself of the whole cloud industry is going to double, right? So that basically means whatever number of job postings that I'm going to show you today, they are going to basically double or triple by the year 2023 or 2025, right? So that's the kind of growth that cloud is going to see in the future. And if there is any time to shift to the cloud domain, it is right now. Right? So if you are thinking about moving to the cloud domain, or if you want and are intrigued with what cloud is and you want a job in the cloud domain, right now is the time that you should migrate from your current job role to cloud, right? Now, what will you do when you become a cloud engineer? What exactly will be your role? Let's discuss that. Now, guys, a cloud engineer, or like for my friends who are not acquainted with what cloud is, guys, cloud is nothing but, in the most simplest terms possible, it is the use of remote servers on the internet. Okay, so if you have remote servers on the internet and you use them from the comfort of your own laptop, you are basically on cloud. You're basically using servers which are not there in your premises. You're using servers which are away from you. So that means you're using the cloud. So don't get confused with what cloud means. Cloud basically means you don't know where the server exists. You just have an IP address, you have the username and the password, and you just type that and you can see the desktop of that machine and you can do anything you want. That is cloud, right? In the most simplest terms. But it gets a little complex when we talk about, so I talked about a server that you would be existing on cloud that you can connect with, right? Now you have specialized servers in cloud which can do a particular task. For example, you have backend servers, you have front-end servers, you have database servers, and you can do a mix and match of these servers and create a whole ecosystem of application around you. So this is what a cloud engineer knows. He knows how to use the services provided by a cloud provider in the most optimum fashion possible and create a highly available and highly reliable application out of it, right? Doesn't matter if you code the best application in the world, but if your infrastructure is not supporting your application, you won't get the kind of performance you want out of your application, right? And that is exactly why you need cloud engineers, because they know how to deploy your application. They know which server to deploy it on, or which service to use on cloud provider to deploy a particular application. If I were to give you an example of how it works from the top of my mind is, there are two backend languages. I'm not sure if everybody of you would have heard of it, but just hear to the example and you'll know what I'm talking about. So there is a programming language called PHP, and there's a programming language called Node.js. Now Node.js basically works on single thread, while PHP works on multi-thread, right? So what happens is, when you have to choose between PHP and Node.js for your application, let's say you work in a company and that company has made an application, the development team has made an application, and now they come to you asking, or they are planning to make an application and they come to you asking which programming language should we use? Should we use PHP or should we use Node.js? Now you as an architect, you tell them that, if you're using PHP, it's a multi-threaded language. If you use Node.js, that's a single-threaded language. Now this is something that you will find in any of the documentations. But what an architect needs to know is what are the advantages of using single-thread language and what are the advantages of using a multi-thread language. When you use a single-thread language, you cannot give that language processing intensive tasks. For example, if there is one task that requires a lot of processing, that would not function well on Node.js, given it's a single-threaded language, right? While on PHP, if there are multiple threads which can run at a single time, that particular language can accept process, an application which involves a lot of processing, right? But if your application does not have that much of a processing, it's just about doing CRUD operations on databases, right? In those kind of scenarios, you can use Node.js because it performs way better than PHP. Now, this knowledge which I just told you is a knowledge that an architect should know, right? Or a person who is handling a team or who is going to deploy your application on a particular infrastructure or in a particular environment should know. And this is similar to this knowledge in infrastructure, a cloud engineer should also know, right? For example, if my application is process intensive, if it requires a lot of processing, how much of RAM or how much of CPU would a single server require? That I have to plan. Which service on the cloud? Like for example, in AWS, there are 3 types of compute services. Mainly, right? You have EC2, you have Elastic Beanstalk, you have Lambda, right? So where to put which application you have to know. For example, Lambda requires backend or basically does backend processing for you, right? So backend part of your application would go on AWS Lambda. Now, obviously, if it's going on AWS Lambda, you'll also have to make it highly available. So AWS Lambda handles it for you. But when we talk about your front end, where a lot of users are going to ping your website, that task will basically requiring a lot of scaling up and down because the traffic is not the same at every time. What I basically mean by that is, let's say you are running a company and at around 4 p.m. you get the maximum traffic, right? So in that case, you need a server capacity of around 9 or 10 servers at that time. And at 6 p.m. the traffic drops. Okay, at that time you don't need those many servers. So how to configure the auto scaling properties in cloud providers, right? That and all this knowledge is what an architect gains when he basically gets certified or when he roasts himself by doing work day in and day out as a cloud engineer, right? So guys, a cloud engineer role, to sum it up, is to know what application would go on what service of the cloud and what would be the best practices of deploying an application. That is what a cloud engineer should know, right? Now, he has to work on planning, he has to work on architecting, then he also has to work on managing the infrastructure once it's deployed. And obviously, he also has to look at how we can monitor and support this particular application. All this planning, all this implementation is done by the architect or the administrator or the developer, but essentially they are known as cloud engineers. And this is what your role would be when you shift into the cloud domain. So to sum it up, if you are applying the best practices and whatever principles you have learned in cloud, then that profile would sum up to become a cloud engineer profile. Now, moving forward, guys, let's talk about the skills that a cloud engineer should have, right? So a cloud engineer or a person, if I'm a company and if I'm hiring a cloud engineer, I would expect certain skills out of a person. So I would expect he should know some programming language. I would expect he would know some Linux scripting skills that he should have. I would expect him to have some troubleshooting skills, and I would expect him to know multiple cloud domains. Now, this is not what I think the companies would expect. This is basically the research that we have done, and I'll show you in some moment, guys. I'll show you some job descriptions from companies who are basically hiring cloud engineers, and I'll show you what kind of skills that they ask, right? So how to become a cloud engineer? So I told you guys some companies expect some skills. Now, how to get yourself acquainted in those skills? But before that, let me show you actually what are the requirements and skills that are expected from a cloud engineer. So guys, a job description is what we will be looking at. So in this particular section of job roles and responsibilities, I'll be showing you some job descriptions from multiple companies, and then we'll sum it up and see what are the required skills which the industry is demanding right now to become a cloud engineer. Okay, so let's start off with the first job description. So this is a job description which is by Cisco, right? And they are basically hiring a cloud infrastructure engineer. And what they expect this guy to know is DevOps. He should know how to resolve customer issues. That is, he should be customer centric, right? He should know how to deploy cloud applications on AWS. He should know about VPCs, which are basically services in AWS, EC2, again a service, etc. Right? So these are the skills that they expect from a cloud engineer. You would be wondering, what is DevOps over here, right? So I will explain that in a few moments. But as you can see, these are all the skills that they expect from a cloud engineer in the Cisco company. Now let's go ahead. Let's talk about Amazon. So Amazon is also hiring cloud engineer, and what they expect is they should know troubleshooting. They should have experience with AWS, Google Cloud, Rackspace, software layer management, etc. They should know a programming language among Java, Perl, Ruby, or Python. And they should have experience in managing full stack applications, right? This is the expectation from a cloud engineer by Amazon company. Then there is a company, McAfee, which I'm sure all of you know. Now, in this, you are expected to know AWS, you're expected to know Azure, you're expected to know Google Cloud, right? You're expected to know CloudFormation, which is basically a service in AWS. You are expected to know Puppet, Ansible, and Chef, which are basically DevOps tools. You're expected to know Python, right? So all these skills are required. So what I'm trying to tell you is it will not work if you just know one cloud provider. It will not work if you just know one programming language. You have to know a combination of multiple things, and only then this cloud engineer profile can be taken on. Okay, and more skills and more relevant you become with the job descriptions. For example, I'm not focusing on any one company. What I've done is I've generally taken out skills from multiple cloud engineer profiles, and then I've accumulated them together. Let me show you how that looks like. So the required skills are these. So if you were to sum it up, if you want to become a cloud engineer, you should have knowledge of AWS, Azure, and GCP, right? Then you should have an experience in any of these programming languages: Python, Java, Go, R, Clojure. I would recommend you, if you are planning on to learn a programming language, you should basically either learn Python or Go, basically, because they are huge when it comes to the demand that they have right now. You should have a little experience in Linux operating systems. Not a little, actually. I'll say you should be an intermediate in your Linux skills. Then you should also know tools like Puppet, Chef, Git, Docker, Kubernetes, Nagios, Terraform, etc. Right? So don't get scared, guys, with all these big words. I'm not only telling you the problem or what the companies expect. I'll also give you a solution as to how you can prepare for this. Okay? So, and you should also have an understanding of APIs and web services. Okay? So these are all the skills that are required to become a cloud engineer, and I would say even if you gauge around 60 to 70% of these skills, you can apply for a cloud engineer job. This is basically job description for a generic company which is out there. Now, how relevant you become to become a cloud engineer is this list. The more and more you know this list, the more and more you become relevant, and you can apply for any cloud engineer job as you move along. Okay, now let's talk about what are the skills that we have summarized. So I've told you guys that you should know Linux. So first off, when you start on the journey of becoming a cloud engineer, you should start off by learning Linux. If you know Linux, you can skip this. But if you don't know Linux, first you should learn this, right? Then you should start off with all the cloud providers, that is AWS, Azure, and GCP. You should start learning that. Once you are done with Linux and cloud providers, you now know how things work on cloud. Okay. Now what you have to know is how companies implement or upload or basically help their development team to integrate their development tools with cloud, and that is exactly what DevOps is for. If I were to give you an example, let's say there's a developer in a company, and what he knows is basically a place where he can upload your code, right? For example, a developer's best friend is basically a version control system. Let's assume he's using GitHub, right? So all he knows is how to code and how to upload it on GitHub. But from GitHub, how do you test that application? And if the test is complete, how do you make it available on production? That life cycle is basically what DevOps caters to. Okay. Now, how does cloud fit in DevOps is when you have deployed an application on, let's say, your production server, most of the companies now are basically using cloud, right? Which basically means they don't have any infrastructure of their own. Probably the developer's machine would be there in the company, but the server on which the application is deployed is not in the company, it's on the cloud. So I think you got the idea that whenever your applications are either getting deployed on testing server or on the prod server, these servers are nothing but these are servers which are deployed on the cloud, which could be either AWS, Azure or GCP. So how to create the DevOps lifecycle on the cloud is what you'll have to learn. And that's why you also have the DevOps tools as a skill when you want to become a cloud engineer. Then you should also know a programming language. The reason for that is, I told you guys, a cloud engineer should also know how to code. The reason for that is, let's say an application stops working, right? And now the developers have no clue why it's not working. So it's your job to understand the code and understand where exactly the problem is occurring. And that's why it is recommended that you should know a programming language. Otherwise, if you're planning to aim for the cloud developer role, in that case, what you'll be doing is you basically will be implementing your application with the cloud, right? And if you're integrating your application with the cloud, which basically means you have to interact with the services of the cloud, then you have to know how to implement SDKs, right, in a programming language. And that exactly would be covered when you know a programming language, right? And finally, because today, in today's world, we are no longer working with monolithic applications. What are monolithic applications? There is no one code which will basically run my whole application. You basically have different parts of the application deployed separately, and these different parts interact with each other. And these are what APIs are in the most simplest terms. Okay. So if you did not get that, let me just tell you in a brief sentence that earlier all the applications had one single code base and they were deployed and the application used to work. But what happened was, as we progressed in the software development journey, we realized that, let's say I'm using the Uber app and I have to add a feature in the payments section. So I'll have to open the whole code base again. I'll have to go to the payments section of the code and I'll have to make changes and then upload the whole code again. This unnecessarily broke something or the other in the whole code base. And now what we follow is a microservices architecture. And in the microservices architecture, what we do is we basically break the application into multiple parts, and then these parts interact with each other using API endpoints, right? So as a cloud engineer with the modern applications that we deploy, you should also know what are APIs. Okay. So these are the required skills for you to become a cloud engineer, and you should follow this particular fashion when you are basically preparing for a cloud engineer role. Okay. Now, I told you guys how you can prepare for a cloud engineer role, right? Now, if you were to do it on your own, this is the way. If you want help from us or from any e-learning company, I'll tell you a way as to how you can learn that as well. Okay. But before that, I'd like to tell you guys the present is good. I mean, if you want to become a cloud engineer right now, it's the best possible time you can become. If you become right now, what is the future that lies in front of you? It should not be like that in 2-3 years, the demand goes down, right? So let me tell you the future of a cloud engineer. So guys, these are basically some statements that I have picked up from these companies. Like Forbes says, cloud engineer or cloud architect profile is in the Forbes top 15 list of highest paying tech jobs right now, right? Forbes says around $146,000 is the median salary for a cloud professional, which is basically a jump because when they did the survey in 2016, it was $22,000 less than the figure that you see right now. So as the number of years are passing by, the obviously the inflation is also there, but $22,000 is not the kind of inflation that you would see, guys, right? So it's a huge jump in the median salary, in the average salary of a cloud engineer. Then according to Glassdoor, in the last month alone, right, we are talking right now in August 2019. So in July 2019, there were 5,765 jobs posted in India just for a cloud engineer. And there were 33,272 jobs which are posted that were in the US. Okay. So this is the huge demand that you can see that is there for a cloud engineer profile. Similarly, there's a company called Canalys. So they say AWS, which is the biggest cloud provider in the market right now, it owns around 31.5% of the cloud market share. Now you would think that, 31.5 is not a huge number, but when you compare it with Azure, which is the second largest cloud provider, it has around 14 or 15% of the cloud market share, which is actually the half of what AWS owns. And it is the second largest cloud provider, Microsoft Azure. So as you can see, AWS has a whole lead. And the reason for telling you this is when you're planning to learn about the cloud providers, which I basically told you three, which are AWS, Azure, and GCP, you should always start with AWS, given you don't know AWS yet, right? The reason for that is once you learn AWS and let's say, you plan on going on with the other skills like the DevOps skills and the programming languages skills, you can actually skip Azure and GCP for a while, because when you apply for jobs, 31 out of 100, 31 companies would be using AWS, 16 companies would be using Microsoft Azure. And if I were to go by my memory, around 8 to 9% or 6 to 7% is actually by the GCP. So out of 100, 31 companies AWS, 16 companies Microsoft Azure, and 6 to 7 companies would be Google Cloud. So this is the current figure. So if you go by probability, you are likely to get a job as a cloud engineer if you know AWS, then if you know Microsoft Azure and GCP. But our aim is to know all the three. But if you were to plan as to how to learn all the skills that we have discussed today, you should start with AWS. So this point is specifically for that. And finally, according to Report Linker, so this was the fact that I was talking about in the beginning of the session, that right now the cloud industry has the revenue of around $258 billion annually, right? So by 2023, this is going to become $623.3 billion. That's more than the double of what the cloud industry is gaining right now, right? So this basically just tells us how much the cloud industry is going to grow in the future. All right. Moving forward, now let's talk about the job roles that you have in cloud. So I told you can become a cloud engineer, but actually a cloud engineer is basically a generic profile which companies post on the job portal. It is basically built up with a combination of job roles. So what are those job roles? So the first profile is solutions architect, which I told you about, wherein you have to plan, you have to know the in and out of your application. You should know which part of your application should be deployed on which service of the cloud. That job is basically the solutions architect job. Then you have the cloud developer. So cloud developer is a person who knows how to develop applications and also how to write SDKs so that the application can interact with the cloud services. So that's a guy who is a cloud developer. Then you have a person who is a SysOps administrator. A SysOps administrator is a person who basically manages the infrastructure once it has been deployed by the architecture, right? So once the infrastructure has been either designed or applied by the architect, the SysOps guy's job would be to implement that architecture or handle that architecture according to the norms that has been specified by the solutions architect. So this is what a SysOps administrator is. So for all my friends who have an experience in development and they feel that, I want to stay in development right now, I don't want to become a full stack cloud engineer, I basically want to be in development, but I would want some of my job to include cloud, then your profile that you're aiming for is cloud developer. For my friends who are already system administrators and they basically want to skill up themselves by becoming system administrators for a particular cloud provider, they can basically aim for the SysOps administrator profile. And for the people who want to move up the ladder, they basically have around 14 to 15 years of experience either, or basically they are from a non-IT background and they want to shift in the cloud domain. You should start off with the solutions architect profile. Okay. There are some more profiles which are basically cloud network engineers. So people who are focused on just networking aspect of cloud, if you want to become a network guru, then in your case, you should opt for the cloud network engineer profile. And then you have the cloud DevOps engineer, which is basically a profile which basically expects you to know cloud in and out, which expects you to know DevOps in and out. And this is basically the profile that I was telling you about that you should aim for, right? You should know all the skills that are basically expected from a person who is a cloud engineer and basically then would become a generic cloud engineer who can apply to any company. So this is that guy. So your aim is this. If you want to start off from a particular point, your point would be this. You become a solutions architect first, get yourself certified in that, then work your way up for cloud DevOps engineer. And similarly, you can become a cloud developer or a SysOps administrator, and then you can get certified in cloud DevOps engineer. Similarly for cloud network engineer as well. Okay. Now we discussed all the jobs which are there in cloud. If you want to become a full stack, if you want to implement cloud in your job, I just showed you some profiles which you can get certified in. Now, some of my viewers today would be wondering, like, the current job that I am in right now, can I implement cloud in that? So let me show you some stats. So guys, the top 15 tech jobs which have the cloud related skills in the job description, that is what we are going to discuss right now. So guys, a software engineer, if you go by the generic job descriptions that we see every day, more and more software engineer job descriptions are expecting the software engineers to know cloud, which basically means if you are a software engineer right now and you are aiming for the future and you still want to be a software engineer, then almost 8 to 9% currently job description expects you to 8 to 9% of your job description. That means, let's say you have 100 skills, out of those 10 skills should be in cloud, right? So this is what the 7.92 number means. Then you have the senior software engineer profile, which basically again expects you to have around 6.7% skills in cloud. Software architect expects you to have 6.21%. So basically the aim is to show you guys that all the profiles that you see over here, although they do not coincide with any cloud profile, still they have some elements of cloud skills in their job description, which basically means most of the companies which are related to IT today are doing something or the other thing on cloud, and that's why they expect all their employees to know cloud, right? So what I'm trying to tell you from this slide is, whatever profile you are in, if you want to be relevant to the industry, you should know or you should start upgrading yourself with cloud today. Okay, then these are some of the other profiles that you can have a look at. For example, a cloud engineer profile, a generic cloud engineer profile, a data engineer profile, a Java developer profile, system engineer, data scientist, then a system administrator, Java developer, .NET, front-end developer, back-end developer. All of these people, they have some element of cloud skills in the job description, and that is what you should aim for. If you are currently sitting in these profiles and you don't have this cloud skill, you should get started today.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session. Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
So what I'll be doing is, first of all, let me go ahead and show you how a network like this is possible, where you do not have internet connection in one part of the network and you have internet connection in the other part of the network. Okay. So first of all, you'll have to sign up on AWS. Okay, so let me just quickly log in. And when you have signed up on the cloud, this is how your dashboard is going to look like. This is how your dashboard is going to look like. These are all the different kind of services that AWS offers, and we are going to make use of some today to do what we have to do. All right, great. So now that we are on this management console, the next thing that I'm going to do is I'm going to choose a service. So when you want to deploy any kind of server, if you want a machine from AWS, the kind of service that you have to make use of is called Elastic Cloud Compute, right? So the short form of this is EC2. So you will have to make use of a service called EC2. So EC2, you can choose, you can go to all services under compute, you will find the EC2 service, just click over there. And this is the management console that you will get. Okay. Now my job is to deploy a server. I will do that. But first I need the network that we were talking about, since the past 15-20 minutes. we need the network ready first, where we will be deploying our servers. Okay, so the EC2 service is for deploying your servers. Now for getting your network or deploying a network on cloud, there's again a service, and that service is called VPC, which is called Virtual Private Cloud. So we are going to type in VPC, and you will get isolated cloud resources kind of a service over here. Just click over it, and here you can deploy the kind of network that you want. Okay, so now let me brief you about what we are going to do. So first of all, whenever you talk about networks, guys, networks, uh, the word network is can be a very big architecture, but networks have subparts to it as well, which are basically called subnets. So if I have let's say your office network, so you guys must be working in offices, you might be in colleges. So your office will have one network. Then in that one network, you will have, let's say, a network for the HR department. You will have a network separate for the developer department. Then you will have a separate network for, let's say, your leadership team. So everyone will have different access to the different part of the network, and every network will have its own access. Okay, so first of all, let's deploy the big network. Let's deploy a network for our whole application, right? And our whole application, I'm not restricting it to say that this whole network will have internet access or not. This is the overall network that we are deploying right now. And inside this network, then we are going to create subparts where we are going to uh, uh, define the functions that each subpart can have. For example, some parts will have internet access, some parts will not have internet access. So that is something that we are going to do now. Okay, so first let's go ahead and create a network. For example, let's create a network for your office. So let's call this network as Netflix. Okay, this is where all my resources are going to be. So I'm going to name it as Netflix, and let me give an address. So everything that you deploy on a network has an IP address. For example, right now, if you're accessing the internet, your computer has an IP address. Why? Because you are connected to a network which is called internet. Similarly, if you are connected to your office network, you also need to have a separate IP address which will make you recognize on that network. Okay, so now what we're going to specify in this IPv4 CIDR block is the range of IP addresses that I'm going to have. That is, let's say if your computer connects to my network, what is the kind of IP address which will be assigned to you? So let's say I specify over here that anyone who's trying to connect to this network will have an IP address which will look something like, let's say this. So this is the range that I'm specifying over here. So here in this range, so your IP address will always begin with 10.1, and then this number will change according to what your network configuration is. So this is the range that I'm specifying over here, and this range is where my application is going to be deployed in. Okay, so let's click on create. And what you have now done is you have created an office network, or you've created a network for your application. Okay, now inside this network, I'm going to create subparts. Okay, because some resources I want to give internet access, and some resources I do not want to give internet access. So let's see how we can go ahead and specify that. Okay, so I have created a network called Netflix. Now inside this network, let's create some subparts. So for creating the subparts to a network, what you do is you create subnets. Okay, so I'm going to click on subnets. So let's create some subnets for my Netflix network. So I'll click on create subnet. Let's say what I'm creating right now is for a network which is going to have internet access. So let's call all the networks which will have internet access as public, and all the networks which will not have internet access as private. Okay, So let's call this network as public. And when you're deploying servers in AWS, you can deploy it in many data centers. Okay. So right now, what we are dealing with is the Oregon region. So Oregon is basically a place in the US where AWS has many data centers. And how many data centers are there? There are almost 4 data centers that you can choose from. So let's create, a public subnet in 2A data center. Okay, and let's call this public subnet as 2A. And this subnet will be deployed obviously inside my main network, which is Netflix. So let me select that, right? And it is going to be deployed in the 2A data center. And let me specify the IP address range, which is going to lie obviously between this particular IP range that I specified earlier. This will be the IP range where I will have, my resources will be assigned the IP address from. Okay, so let me specify it as 10.1.1.0/24. So these numbers that you see /16, they basically denote a range. 20. If I specify something called as /24, that's a smaller part of a range which is /16. Right? For example, if I specify, so just assume it like this: if I specify /16, there are going to be around 65,000 IP addresses that I can give using this range. Okay. Now, when I specify something as small as /24, I will have an IP range of around 256 to 256 servers. So I've just created public 2A, which is basically a part of my Netflix network, and it is deployed in the 2A data center, right? Similarly, let me create one more subnetwork. Let me call it as public 2B. This is going to be a part of the 2B data center. It is going to also have internet access. It is going to be a part of my Netflix. What do you say? It will going to be a part of the Netflix network, right? And the range is going to be 10.1.2.0/24. Okay, let's go ahead and create it. Okay, so now what we have done is we have created 2 subparts in the data center 2A and in the data center 2B. Now let's go ahead and create private subnets which are not going to have internet access. So let's create them. So let's call this as private 2A. It's going to be part of my Netflix main network. It's going to be a part of the 2A availability zone. And this is going to basically have this IP range. Okay. Now, similarly, let me create a private 2B as well. /24, and let me go ahead and create it. Okay. So, okay, there's a small change over here that I'll have to do. So once you have deployed it, guys, you can verify if it has been deployed in the correct data center or not. For example, private 2A has been deployed in 2A data center. That is great. But when we talk about public 2B, it has again been deployed in 2A data center itself. So what I can do is I can delete it quickly and I can create public 2B once more. Okay, so let me create public 2B, and VPC is going to be my Netflix network. It's going to be part of my 2B network, and this is going to be 10.1.2.0/24. Okay, so now I have private 2A, I have private 2B, I have public 2A, I have public 2B deployed, and these should be now in the respective data centers. If I've named it 2A, it's in 2A. If I've named it 2B, it's in 2B. If it's in 2B, it's in 2B, and 2A is also there in the 2A data center. Great. So I have my network deployed. Now let me go ahead and define their functions. So what I've decided is my public subnet will have internet access and the private will not have internet access. Okay. So what I'm going to do is first I need internet connection to my network. So how can I give internet connection to my network to these public subnets? Let me go ahead and tell you. So for example, if you need a Wi-Fi at your home or if you need internet at your home, what do? You contact an internet service provider. They basically bring a modem to your home, and then that modem you connect to your Wi-Fi router, and by connecting to your Wi-Fi you're able to use your internet, right? Similarly, if I want to give internet to my network, what I'll have to do is first I will have to go ahead and request for something called as a internet gateway. So let me create an internet gateway. Let me call it as Netflix network internet gateway. Let me create it. Okay, so it has been created, and now you'll see it in a list. So I've created the internet gateway. Now I will attach it to my Netflix network. So here you can see, you can find something called as attached to VPC. Let's click over here. Let's select the VPC that we want to connect to, which is Netflix. Let's select it and let's click on attach internet gateway. Okay, so my internet gateway is now attached to my network. Okay, but still the resources that are going to be in my network, they will not be able to access it. The reason for that is whenever you deploy a resource in a cloud, it is not directly deployed in the main network that you created. It is always deployed in a sub part of the network, which is basically nothing but the subnets that you created. So the subnets that you have deployed, you have to configure them to connect to this internet gateway. Okay, now internet gateway is part of your network, but your subnets are not knowing about that internet network. So uh, in a simpler way, if I were to tell you, you have Wi-Fi at your home, but you are not connected to your Wi-Fi. So your laptop does not know if it can connect to that Wi-Fi or not. Okay, so what I'll be doing now is I will go ahead to something called as route tables. So route tables basically specify which IP addresses can connect to a particular resource in the network and which IP addresses cannot. Okay, so let me go ahead and show you guys how the route table is basically going to be configured. So right now, there is one route table which is automatically created for your Netflix network. Let's call this route table as the internet route table. So whichever subnets or whichever part of the network are going to be connected to this route table will have internet access. And let's create a route table which is called non-internet route table, right? And let's also deploy it in the Netflix network only. So this route table that I have created over here is going to have all the resources which do not have internet access. Okay, so to this non-internet route table, let's go ahead and attach the subnets which will not have internet, and to this internet route table let's attach the subnets which are going to have internet. Okay, so first let's attach subnets to the internet route table. We'll click on subnet associations, and here as you can see there are no subnets attached to it as of now. We'll click on edit subnet associations and we will attach all the public subnets where we need internet to this route table. Okay, so now the route table have been attached, the subnets have been attached to this route table. And now what you will do is you will specify a route to the internet gateway in this route table. And then what will happen is all the subnets which are connected to this route table will be able to see that internet gateway. Or in other words, whichever laptop is at your home will be able to connect to that Wi-Fi. Okay, so let's click on edit routes. Let's click on add a route. And here, let's say everyone in this network should be able to connect. So when you have to say everyone, you give a destination or IP address like this. Okay, so all the IP addresses which are there in this subnet should be able to connect to my internet gateway, which is this, right? And let's click on save routes. So now what have we done? Let's revise. So we connected two subnets to this route table, which basically I named them to be public subnets. And these public subnets, I have given a property to them that they can connect to the internet by using an internet gateway. Okay. So now that we have one network which is going to have internet with us and the other network which is not going to have internet with us. Now what I'll be doing is, so I think I've not connected the subnets to my non-internet route table. Let me go ahead and connect. I'll go to subnet associations of my non-internet and let me connect the private subnets to it. So private 2A and private 2B. Let me connect. Okay. So now I have the two route tables configured and I have my network configured in the fashion that I've just explained to you guys. And now one final setting that we will have to do is we will go to subnets. Now the resources which can talk to each other on the internet or which will basically have internet access, they will need a public IP address as well. If they don't have a public IP, be outside from the Netflix network will not be able to talk to them. Okay, so how do we configure our resources which are being deployed in the public subnet to have a public IP address? This is a small setting that you have to do. So you will be clicking on your public subnet. You will be going to actions. You will have to go to modify auto assign IP settings. Click on enable auto assign public IPv4 address and click on save. So now all the resources which are going to be deployed in public 2A are going to have a public IP address. Public IP address is basically an address which can be reached out from the internet. Okay. All the 10.1 IP address ranges that I specified earlier are basically going to be a part of the local network, that is the Netflix network. But when we talk about the internet is also a network, right? So internet also has its own IP addresses which are given to people when they want to connect to each other, right? So for example, if I am connected to the internet, if I go ahead and see what is my IP address, this is the IP address that I have, right? And this IP address is basically given to me by my internet service provider. So similarly, if I want to deploy a resource on AWS which is connected to the internet and to which I want to connect to, it should have this public IP address. Okay, so that is what we have configured, that all the resources in the public 2A will have a public IP address, and even in public 2B, I will specify that they can have a public IP address. Okay, great. So now all the resources that I'm going to deploy in public 2A and public 2B will have an IP address. And now we can simply go ahead and go to my service EC2, which we talked about earlier, which is going to rent me servers. I will go to that service. And let me deploy some servers now. So what I'll do is I'll click on running instances. And let's click on launch instance. Okay. So the moment you click on launch instance, now let's see what are the kind of options that we see on the screen. So now when you want to rent a server from cloud, the first thing that you need to decide is what is the kind of operating system that you want to run on that server. Okay, so let's say I want to run a Linux server. So let me select Ubuntu. I want to run the Ubuntu operating system on my server. Okay, so I'll select it. And now it will ask me what is the kind of processor, what is the kind of RAM do you want for your server. So here's a list that you can select for. Now, if you want your server to be a part of free tier, you can see this green highlighted text over here which says free tier eligible. Select that. It will give you 1 core CPU and it will give you 1 GB of RAM. Okay, let's go ahead and click on next. Next thing it will ask you is what network do you want to deploy this resource in. So I want to deploy it in my Netflix network, right? And since this is going to be a public uh, instance that I'm deploying, because first what I want to do is I want to configure my server that I'm deploying on AWS, and later I'll shift it to a private network where we will not be able to access it from the internet. Okay, so I am going to deploy it in the public subnet as of now. And what I'm going to do is rest, I'm going to leave everything at default. I'm going to click on next. Now it will ask me what is the kind of space or what is the hard drive space that I want for my server. So when you deploy a Linux server, it has minimal requirements. So a Linux server with 8 GB of RAM will work. 8 GB of storage space will work. So I'll just click on next again. And now this is the place where people were referring to, will it have any firewalls? So when you talk about firewalls, you basically are referring to security groups in AWS. Okay, so my instance will basically, or my servers will be governed by a firewall which is called security group, and I can create a firewall or I can choose an existing firewall as well. So when you create a new network, what happens is automatically there's a firewall which is created, which is basically called the default firewall. So it's called the default VPC security group. Okay. If you select that firewall, what are the kind of things that you can configure over here? Let's see. So first of all, what you can configure is the kind of traffic which is allowed in this firewall. Okay. So right now it says all traffic is allowed. Good. What protocol is allowed? All protocols are allowed. Okay, so we'll have to restrict this firewall in a little while. We'll do that. What port range is allowed? Any port from any traffic is allowed. Okay, and who can connect to this firewall? Only the people who are part of this security group can connect. So this we will have to change, since I want to connect to the server to configure it. So I will have to put my IP address over here in the source. We'll do that in a little while. But for now, this is the firewall that you all were referring to, right? And this is something that we are choosing as default over here. You can create it as well. If you create it, you will again get the same options, but you will have to configure them. Okay, so let's click on review and launch. And now you can just review all the settings that you have done. If everything looks good, you can just click on launch. Now, AWS as a security option, it does not give you a simple password based authentication to your server. What it gives you is a file which you can use to connect to your server. Okay, so that file is basically called a private key file, which you will have to download from over here, right? So I have a file that I already created. It's called Mac Oregon, so I'm going to select that. I already have it on my system. If you don't have it, you're creating it for the first time, you will have to choose create a new key pair. Let me create it since we are doing it over here. Let's specify as Netflix demo. This is the file that I will be using to authenticate to my servers. Once you specify the name, just click on download key pair. This will be downloaded to your system, and then later you can use it to connect to your server. Okay. Now I click on launch instances. And with this, my server has now just been launched. Okay, and I've launched it inside a public subnet. Okay, so now I've just launched a server, right? And this server is now a part of my public subnet, which means this has internet access. So let's see what all things we have available for this server. So let's call this as Ubuntu server. Okay, so this has a public IP address. Great, I can use this IP address to connect to this server, right? It has the private IP. Private IP is basically the IP which is given inside the network. So as you can see, the range is 10.1, which is exactly what we specified, right? It is a part of the 2A data center, which is good. The firewall attached to it is default. So we will have to change the default rules for this firewall. And others you can verify whatever you configured, exactly those configuration you can see for your server over here. Okay. Now what I'll be doing is I will be selecting the security group, which is the default security group. And let me change the settings over here. So first of all, I'll be changing the inbound rules. So the inbound rules of my firewall right now are these. So let me change this. So I click on edit inbound rules. And now, first of all, let me tell the server that only I can connect to it. So I will specify my IP. And as you can see, this is my IP address that has been specified. So only my system will be able to connect to this server. And right now you can see this is the public IP that has been attached to my firewall. Okay. So any kind of traffic from my IP address will be allowed to this server. Okay. So this is the setting that I'm specifying right now. I'll click on save rules. And this setting is done. Now, this will be changed later when we will be deploying our full stack application. But for now, this is the IP range that I have specified. Okay. Now I'll go back to my dashboard, go back to my server, select the server that I want to connect to. So this is the Ubuntu server. So you will notice I have some other servers, EC2 demo, which have been created over here. So this account is used by a lot of people. So you don't have to worry about the other servers which are being launched. Just select the server that you want to use. So in my case, it's Ubuntu. Now I'll be connecting to it. Okay. So this is the IP address that I'll be connecting from. Let's copy it. And now to connect to it, I will make use of my terminal. Okay. Now here is something that will be different, that can be different on your system. What is different on mine? So I am using a Mac operating system. So I have something called as a terminal, right? So this is a bash terminal that I'm going to use to connect to my server. Okay. Now, when you might be on a Linux, sorry, you might be on a Windows system. So in that case, if you want to connect to your server, you will have to basically make use of a software called Putty. Okay. So there's a software called Putty, which will basically make you to connect to your server, right? So what we basically make use of is the SSH protocol to connect to a Linux server. So this tool, the Putty tool, will help you connect to your server using the SSH protocol. So just click on the first link that you see. You can see it says you can download Putty over here. Just click over it. And here you can download, the Putty version. So you have to download the 64-bit version. In case your processor is 64-bit, if you have 32-bit architecture, then you will be selecting the 32-bit version. Okay.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Once you download it, there is one more software that you have to download, and that is called Putty Gen. Okay, download this as well on your system. Now, once you have Putty Gen and Putty downloaded, what you have to do is, you remember the key pair file that you got? This is the PEM file This is the key pair that you got, and this is only for Windows system that I'm telling you right now, guys. So this PEM file is not compatible with your putty software. Okay. So what you have to do is you have to convert this PEM file into PPK, and that can be done using this PuttyGen software that you will be downloading. Okay. So how you can use the PuttyGen software? Let me show you some screenshots. So this is how your software is going to look like. You don't have to enter any values in key comment key phrase. So what I'll do is, okay. So this is how your PuttyGen will look like when you open it for the first time. So what you have to do is you have to click on load. Okay, it will open a dialog box. Select the PEM file that you downloaded. Click on OK, and then click on save private key. Okay, what this will do is it will save a PPK format file on your system, and that is basically the file which you will be using now to connect to your server, right? So PEM files are compatible with Linux systems, but PEM files are not compatible with Windows systems when you're using the Putty software. So you have to convert it to PPK. Okay, so with that done, once you have the PPK file, next you will be opening your Putty software. So your Putty software will look something like this. Okay, this is the UI that you will get. So the IP address of your server will go over here in hostname. So this is my Ubuntu server. This IP address will go over here in this dialog box, the hostname. Okay. So once you put the IP address over here, next what you have to do is you have to click on SSH, right? And once you open SSH, you will find something called as auth under it. Click on auth, and then you will get a browse window over here. Okay, so if you click on SSH, you will click on auth, you will get a browse button over here. Click on this browse button, select the PPK file that you downloaded earlier, and then all you have to do is click on open. That's it. So once you click on open, you and I will be on the same user interface as what I'm going to show you as of now. Okay, so this is the only difference that is going to be there while I am doing this demo and while you will be doing this demo. So first step, you have to convert PEM to PPK using the PuttyGen software. Put the PPK file over here in browse section of SSH auth, and then put the IP address over here by going to session, click on session, put the IP address over here, and finally click on open, right? So now a terminal will open just like this, and then I'll tell you what has to be done from there. Okay, so now what I'll be doing is, let me pass in the command. So this is the command that you will be using when you're on Linux. Okay, so people who are there on Linux, first you have to go to the folder which will basically have your PEM file, then pass in this command. So ssh-i basically means the server that you want to connect to. Sorry, the PEM file that you want to connect to. This is the PEM file that I'll be using to connect. And then now people on Putty, you will see a dialog box which will ask you for login as. It will ask you for username. So if you have launched a Linux machine which has Ubuntu operating system, the username would be Ubuntu. Okay, Ubuntu @ now when you just have to specify Ubuntu, hit enter, you will be logged in. People on Linux, you have to specify username @ of IP address of your server, and then hit enter. Okay, so it will ask you whether you trust the server. This will also be the same for people who are going to work on Windows. You have to type on yes, hit enter, and Windows people will be able to connect then and there to the server. People on Linux will find this kind of a warning which will say unprotected private key file. Okay, so you will have to pass in a command sudo chmod 500, which are basically going to change the permissions of your file, right? And then just change it with 500, and This should do the trick. Now pass in the same command. And there you go. I have connected to my Ubuntu server on AWS. So people who will be doing it on Windows, you will also see the screen as you are seeing right now on my screen, right? And this is how you connect to a server which is deployed on AWS. Okay. Now that we have connected to our server, what I'll do is I will basically make it a web server. And then once our website is ready, we will deploy it in my private subnet, which is not going to have any internet access. Okay. So when you want to create a web server, first thing that you have to do is anything that you want to install on a Linux machine, first you update that machine. Okay, so I'll just type in sudo apt get update. It'll take like a minute to update the machine, or even less than a minute. So it took 10 seconds to update the machine. Now what I'll be doing is, so this is the command that I passed to update the machine, sudo apt get update. Next thing that I'll be doing is I will be installing a web server. So sudo apt get install Apache 2. So this is a web server which is now getting installed. Okay, so I just choose yes. Okay, so web server is now being installed. And after this, we'll do a very cool exercise, guys. So you will be able to see that if I go to the IP address of my server now, so I just type the IP address over here in the browser. You can see I can able to access this page in my browser. Okay. Okay. So now what I'm gonna do is, guys, I'm gonna basically go ahead and define a web page over here. So let me show you how we are going to go ahead and define our web pages. Okay. So what I'm going to do is, this is the architecture that we are going to deploy now. So I will have a separate web page for streaming servers. 1 second. So I will have a separate web page for my video page, and I will have a separate web page for my home page. Now let me show you why we are going to do like this. So let me go ahead and open the website called netflix.com and just see what is the behavior. So if I go to netflix.com, I automatically go ahead and get routed to netflix.com/browse. Okay. And if I select the account that I want to use, it's still the URL over here. It's netflix.com/browse. So netflix.com/browse is taking me to the homepage of Netflix. I hope everybody is clear here. Okay, now what happens if I play a video? Okay, so let me play this series over here. So now what you can see is the URL changed to netflix.com/watch, and then you have some numbers over here, which probably would be the numbers for your video. Okay, so you have connected to netflix.com/watch. 1 second. You have connected to netflix.com/watch in order to get to this page where it is playing this video. Okay, now let me show you what happens when you play some other video. So I'll again click on back. Let me play some other video. So let me play, let's say, this Space Force.
Can you still see? It's still netflix.com/watch. And then you have these numbers which are after this URL. So these numbers basically are referring to the video which is playing on this page, but this page is same all the time. The page is always netflix.com/watch, which is basically referring you to this video player. And then to this video player, what you're doing is you're providing this number, which is basically now going to play the video that you are launching over here. Let's see if we remove the track ID, what happens. Okay, so this is the number which is associated to the video that you are playing, right? And this is the page that you're going to. You're always going to netflix.com/watch. So if you go to netflix.com/watch, you open the video player, and to that video player you tell, okay, so this is the video that I want to play, and that is what is being played over here. So let's see if I just type in watch, what happens. Okay, you can see they have.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
Routed me to something else because they do not want me to, just access the web, the video player. So when I go to netflix.com/watch, they basically reroute me to some other URL. But you now understand the working of Netflix. What they do is, if you go to netflix.com/browse, they are routing you to the home page. And if you go to netflix.com/watch, and some video ID if you specify, it will take you to that video which is being played. Okay, so now let's see how we can mimic this architecture on our system. So what I'm going to do is, if I go to netflix.com/home, I will be taken to the home page. And if I go to netflix.com/stream, or let's make it watch. So if netflix.com/watch, if I go to, it will take me to the video player. Okay, so this is something that we are going to configure now, and this we are going to do using the AWS infrastructure. Okay, so first of all, let's create a home page. Let's create a page that we will be routed to if you go to /home. Okay, so what I'm going to do is, this is my web server where I'm able to go and see this page. Let's change this page to look like a home page. So what I'll do is, so once you have an Apache 2 server which is running, you can go ahead in this path /var/www/html, and this will have a page called index.html. Okay, so this index.html page, if you change this, your HTML will change over here. Okay, so for now, let me first delete this index.html page, and now let's create a new index.html page which says, let's say, welcome to home page. So I will create an HTML page which will, this is a very simple HTML code that I'm writing over here, which will says welcome to the home page. Okay, so this is what I've created, and if I refresh over here, you can see it says welcome to the home page. And even you guys, if you refresh, you will be able to see this particular web page which says welcome to the home page. Now our web page, our web server, our home page is now ready, and now what I'll be doing is I'll be deploying this inside a private subnet. So let's see how we can do that. So for doing this, I will first go to my dashboard,
and this is the server that I created. So let me create a copy of this server first, and then that copy I will deploy it in the private subnet that we created earlier. So I'll just select the server that I created, click on actions, then you have something called as image. So let's create an image. Image is nothing but it creates a copy of your server which can be deployed multiple times then. So we'll create an image. Let's call this image name as homepage, home, Netflix -home. Let's specify this. Right, let's click on create image, and now my image is getting created. Okay, and that image will basically have this web server already deployed. Great. So now that it is happening, I think it will take a minute or two to create that image, and you can see that image in the under the image section in AMIS. So if you go to AMIS, you can see that a Netflix home image is being created, and it is in the pending state as of now. So I think if we refresh it a couple of times, you can see it will change to available. So let's wait. So while this is happening, let me explain you how the other things are going to work out. So as you must have noticed, right? So if you want to have a home page which is going to be separate, and if you want to have a watch page which is going to be separate, you will be dealing with two servers, right? And if you're dealing with two servers, you obviously will have two IP addresses, right? But as you can see from the behavior of the Netflix website, the URL always remains the same, right? Only the web page is changing. So how do we accomplish that? So we can accomplish it by having a common medium in the middle, which can connect to both my watch page and my home page. Okay, so this resource, which is the elastic load balancer that we're going to deploy in a minute, is going to have a URL which is always going to be the same. And this load balancer we can configure to understand if the URL is /watch or /stream, it is always going to route my request to the streaming servers. Whereas if my request is /home, or let's say just slash, or just say no URL at all, in that case it will be routing my request to the home page. So this is possible using the elastic load balancer, right? And this is something that we are going to go ahead and deploy now. Now I think we are ready to now understand how our architecture is going to be deployed. So now what I'm going to do is all my servers, they are going to be a part of my private subnet where I do not have internet access, right? But as we have known from the previous from our previous understanding, we know that everything within our Netflix network will be able to interact with each other. Okay, so in my Netflix network, I have a public subnet, I have a private subnet. So private subnet does not have internet access, public subnet has internet access. So in my public subnet, I'm going to deploy my load balancer, right? In my private subnet, I'm going to deploy all my servers, right? And these servers can only be accessed by the load balancer and nothing else. Okay, nobody else will be able to connect to these servers directly. Only through my load balancer they will be able to access my servers. And this is a very good architectural practice when we talk about having security for our servers. Why? Because you can control which protocols can you interact with in your load balancer. For example, let's say a hacker wants to go ahead and make use of servers. They want to pass some commands, as I did on this terminal. Okay, so if you want your load balancer, to restrict that, your load balancer will only allow HTTP traffic. What is HTTP traffic? HTTP traffic is the traffic that you get from your web browser. So only the web browser's traffic will be enabled through your load balancer. If somebody is trying to pass some command, if somebody is trying to connect through some other protocol, it will not be allowed. Okay. And even in that case, your load balancer will only allow some URLs. So only if you type in /home, you will be allowed. If you are typing something else, you will not be routed to my server. That again is a very good security aspect, that if your URL is pointing to netflix.com/home, only then you will be reaching my home server to access that content. You cannot access my content and from any other medium from that particular server. Okay, so this is how you can restrict hackers or restrict attackers from accessing your server, and it's a very good architectural practice to have your architectures deployed like this. Okay, as I said earlier, we are inside one network, and the Netflix network that we created, right? That is the big network that we created. Inside that big network, we created small networks, which were public and private. Public had internet access, private did not have internet access. Okay. So all these resources which are a part of the big network, which is Netflix, all the resources can talk to each other. Now imagine this rectangle is my private subnet. Okay. And this rectangle is my public subnet. And what is the difference that I told you between the two is the public subnet has internet access. The private subnet, it does not have internet access. Okay. So if I connect to a server which is there in my public subnet, right? Because I'll be able to connect to it. Why? Because it has internet access. If I connect to a server in the public subnet, I can then connect my private server through this public server, right? If I connect to this Ubuntu server on my terminal like this, and then in this server which is there in the public subnet, if I enter the SSH command again, and I enter the IP address this time, the private IP address of the private server which is deployed in the private subnet, will I not be able to connect to it? Okay, if I have a private machine which is deployed in this private subnet, if I have to connect it from my machine, what I'll be doing is I'll be launching a machine in the public subnet, and through that I will be connecting to it. So coming back, now we have our homepage image ready, right? Now let's create an image for our streaming server as well. So what I'll do is, again, let's create one more image from this server itself. Let's again go back to this directory. Let's change the index.html, and this time let's say welcome to the streaming page. Save it. Okay, and now if you go to this IP address, you will see it will now say welcome to the streaming page. Okay, and now let's create an image out of this as well. So again, we'll go to EC2. So in our Ubuntu image, we'll go to image, we'll go to create image, and let's call this image name as Netflix stream. Okay, so now the image will be created for that as well. Now what I'll do is I will go ahead and launch my home page in my private subnet. Let's see how we can do that. So I click on launch instance, and I will choose my AMIs over here. I'll not choose any operating system now. I'll just choose my AMIs. And now I will choose the Netflix home image, which I created earlier. Let's select it. I want to launch it in the free tier server. Everything is going to be the same that we did earlier. Just that now I will be selecting a private subnet which I'll be deploying it in. So I'll be choosing the private 2A network. Let's deploy it over here. And this is our home page that we're deploying. Security group, we will select again the default security group. And we're going to restrict it. Don't worry about that. We're going to restrict that security group. And let's choose the same key pair that we used earlier, Netflix demo. Acknowledge that we have it and click on launch instances. So this is now getting launched in US West 2A. It's going to be launched in the 2A data center. This is basically now called Netflix-home. This is the home server that you have launched, home page that you have launched, and it will take a little while. And as you can see, it is now running. Now, if you have a look at the settings of this server, you will see that it will not have a public IP address, right? Why? Because we deployed it inside a private network, right? But it will have a private IP address. But this private IP address can only be reached out within the network. It cannot be reached out from outside of the network. Remember this, okay? So this is the IP address that we will be connecting through from our public instance, which is nothing but this instance that we connected to earlier. All right. Okay. So we have launched our home page. Now let's go back. Let's see if our streaming page is ready. So even streaming page is now ready. Let's launch this as well. So I'll just select the streaming image, click on action, click on launch. This is another way of launching it, right? This is the server that I want to launch. I want to launch it under the free tier. It will be deployed in the Netflix network. And this time I'm going to deploy it in private 2B data center. Okay. Everything else going to be the same. Security group, I'll select the default one. Click on review and launch it. Select the same key pair that I selected earlier, acknowledge that I have it, click on launch instances, and with this, my streaming page.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Has also been launched. Okay, great. So now I have two servers which are now deployed inside private subnets, and as you can see, I do not have a public IP address over here. Okay, and hence I will not be able to access them from the internet. These are not having any internet access, and I will prove it to you in a little while. Okay, so I have the home page which is now running. I have the stream page which is now running. I have let's name it as proxy server. So I have a proxy server which is running in the public subnet which has internet. Now what I'll do is, using this proxy server, I will be connecting to this home page and the stream page server. So let's see how we can do that. So first we need to copy the PEM file that we have on this proxy server. So let's copy it. So the way you can copy it is, use a command called SCP, which is called secure copy. So first you will have to authenticate yourself using, the proxy server's PEM file. Then you will have to specify the file that you want to copy. So the file name is again this PEM file I want to copy, right? Where do I want to copy it? I want to copy it on the proxy server, which is this IP address. And I want to copy it in this particular file location, which is /home/ubuntu. Hit enter. Since I specified sudo, it is asking me for my computer's password. Specified that. And now the file has been copied successfully.
So now if I SSH into my server again, you can see that the file has been copied, netflix-demo.pem. It has been copied onto my proxy server or my public server that I launched earlier. Okay. Now people on Windows, if you want to do the same, what you can do is follow a simpler method. You can download a software called FileZilla. Okay. So FileZilla helps you to copy files from your local system to your specified server, right? The next thing that I will be doing is I'll be connecting to my private server. Now, where is my private server? My private server is this. Let's connect to a Netflix home server. Okay. So Netflix home server, this is the IP address, the private IP address for my Netflix home server. Let's try to connect to it. So I will be typing in SSH-I and then the PEM file, the username, and then the private IP address. So as you can see, earlier my IP was 10.1.1216. Now it has changed to 10.1.3.193. And that is the IP address of my Netflix home server. As you can see, the private IP address of my Netflix home server is 10.1.3.193. So this basically means I have successfully connected to my private instance. Now, for some of you who still have a doubt whether, if I pass this on my local machine, what will happen? So right now I'm inside the AWS server, right? But let's say, this is the terminal for my local machine. If I pass the same command over here, okay, first let me go to the folder which has the pen file. Okay, so if I pass in the same command over here, you will be able to see it will not recognize what this address is. Can you see it's not connecting? It's not doing anything. Why? Because it does not know what this IP address means. Why? Because my local machine is not a part of the Netflix network, which is there on AWS, right? But this machine is, and that's why when I passed this command, it was able to connect to this Netflix home server. Now, what I'll do is I'll just check if the web server is running. Yes, so it is active, it is running. That means if I curl, so this is something that I'm just doing for my checking, guys. If you don't understand, it's fine. Okay, so that means my Apache server is working on Netflix home, which is great. So let me just exit. So I've exited, and now I'm back to my public server. You can see the IP address changed. And now let me log into my Netflix streaming server as well. So I'll just change this IP address to my stream server. So my Netflix stream server has the IP address as 4.167. Let's specify that. So as you can see, I have connected to my Netflix stream server now. And if you check if the web server is running over here, yes, it is running over here as well. Great. So both my servers are running fine, and I've just showed you how to if some maintenance is required, how to do maintenance on your private machines. Right now, what I can do is once maintenance is done, I can just delete this proxy server, and then I'll not be giving any access to my uh, private machines. One thing that I forgot to show you was, let's say this is my public machine that I've launched on right now, right? This is my proxy machine that I've connected to, right? This has internet connection. How do we know that? First of all, we are able to SSH it from my local machine. At the same time, if I type in curl google.com, you can see that there is a response that I get, right? But if I, let's say, go to my private machine, right? And if I do a curl google.com over here, you can see that I'm not getting any response over here. Why? Because this machine does not have internet access. Okay, and this proves that. Great. Let me exit. And now that our web servers are ready, they are ready inside, a private subnet. Let's configure our load balancers to connect to this machine. Let's create a load balancer. So I'll just scroll on my EC2 console and I will be able to see something called as load balancers over here. Let's click over it. So let's click on create a load balancer. And I will be creating an application load balancer. So application load balancer basically works on the application layer, and it basically helps us to do path-based routing, that which is something that we are trying to accomplish, which is if I go to netflix.com/stream, I should be going to my stream server. If I go to /home, I should be going to my home server. So we'll be creating an application load balancer. Let's name it as Netflix-demo. This is going to be an internet facing load balancer, right? And the protocol that we are going to use is HTTP protocol. Okay, so here, as you can see, this is very important. So the only protocol that this load balancer is going to allow is HTTP protocol, nothing else. All right. Which VPC will this load balancer be a part of? It will be a part of the Netflix VPC, and this has to connect to 2A and 2B servers, private servers. So if they have to connect to private servers in 2A and 2B, this load balancer has to be deployed in public 2A and public 2B. Only then it will be part of the network, and then it will be able to connect to your machines. Okay, so what is the configuration that we did here? So you have configured your load balancer to connect to your private machines only using the HTTP protocol, nothing else. Okay, let's configure the firewall for this. So firewall, we'll be using the default firewall only, will not be making any changes. Let's specify routing now. So for routing, you will have to specify which servers to connect to, right? So right now, let's go ahead and specify a target group. Let's name it as public-server. And now let's go ahead and specify the public server IP address. So the way I can do that is by specifying the the servers that I'll be able to connect to, right? So what I'll do is target group is nothing but the set of servers that you can connect to, right? So let's specify the name of this to be, let's say this is the home page server, right? Let's click on next. And now what I can do is I can select the home page that I want to connect to. So this is the home page that I want to connect to. And let's click on next again. So this is the target group that I've just created for my home server. I'll be creating one more target group. Don't worry about that. So let me first create it and then I'll explain you what I've just done. So let's create this load balancer now. Okay, so load balancer is now created. Next thing that we will be doing is we will be creating one more target group. So we have created one target group for homepage server. Let's create one for streaming server. Okay, this streaming server will also be a part of the Netflix VPC. And now let's go ahead and click on create. Okay, so now my target group has been created. So I have a homepage server and now I have a streaming server as well that I would want to connect to. And in this, so homepage server should have the homepage server connected to it. So it is not connected. Let's connect the homepage server over here, which is Netflix home server. Let's register it to this target group, save it. And similarly, in my streaming server target group, let's connect our stream server, register it, and click on save. Okay, so both of these now have the targets attached to them. And now what we can do is, now we will be specifying the rules for our load balancer. So let's go back to our load balancer. And now what I can do is, so now I have to specify this routing rule, which is if I go to /stream, then it should connect to the target group of my streaming server. And if I go to /home, it should connect to the servers of my home server, the server of my home page. Okay, so let's see how we can configure that. Okay, so you will have to go to listener, and then you will have to specify rules. So let's go ahead and edit these rules over here. Okay, so right now what is happening is anything which is going to this server, it will be routed to the home page server. Okay, so let's add a route over here. Let's click on insert rule and add a condition. So we'll be adding a condition for a path, and the path will be if it goes to /stream, or let's say /watch, right? It should then forward this request to the streaming server. All right. So if the path is /watch, the request will be forwarded to the streaming server. Okay. If there is no path specified, it will be routed to my homepage server. If there is, let me specify one more thing. Let me first save it, right? And let us add one more rule. So if the path is /home, okay, let's try and see if this works for us. So if I'm going to /watch, yes. So the star was missing over here. So now if I'm going to my load balancer /watch, I'm going to the streaming page. And similarly, what I'll also have to do is, let me exit and let me go to my home server as well. Okay, so here as well, I will have to add a home directory. Let me quickly do that. Okay, and now if I go to my load balancer, let's say I'm going to /home, you can see I'm being routed to the welcome to the home page. And if I'm just going to the URL, then also I'm being routed to welcome to the home page. Okay, so now what we'll be doing is, now we will be connecting a custom URL to our load balancer. And so first things first, what you need is a URL first. So what you need to do is just go to your Freenom website. So there's a website called Freenom. It basically gives you free URLs.
Okay. So just sign up on Freenom. Okay, I'm connected. Let's go to my domains. So right now I have some domains, but I'll be showing you once you sign up, how you can create your own domain. So what I'll be doing is, as you can see, these are some domains that I have. I'll be creating a new domain, just like you guys would be doing when you sign up. So I'll just go to register a new domain, go to services, go to register a new domain. And in register a new domain, just specify the name of the domain that you want. So in my case, I want Netflix-demo. Let's check the availability. So as you can see, these are all domains which are free and I can get them. So let's get this domain, check it out, continue. And just agree to the conditions and click on complete order. So with this, your order has been confirmed and you can now go ahead to my domains. You have the Netflix demo domain registered to you. You can just click on manage domain. And here you will have to go to click on management tools and then click on name servers. Okay, and what you have to type in is custom name servers. So these are some name servers that you have to fill in. Now, how can you fill these name servers? Again, go back to your AWS management console, click on services, type in route 53. Now, once you're inside route 53, you will have to choose a hosted zone. Let's click on create hosted zone. And over here, just type in the domain name that you created. So it's Netflix-demo.tk. Give the same name over here, click on create, and this will create a hosted zone for you. Now, as you can see, these are name servers that you will have to enter over there in Freenom. Okay, so just select this, copy these name servers one by one. Go to the second name server, again copy it from here. Third name server, again copy it from here. Fourth name server, again copy it from here. Okay, so that's all the changes that you have to do on Freenom. You can close it now. Now in route 53, you just have to do one small change. Click on create record set, right? And now what you'll be doing is you'll be pointing. So what have you done so far? You have mentioned these name servers in your Freenom website, right? So now your domain will be pointing to these name servers, which are basically the route 53 service that you have. Now this route 53, you will have to point to your load balancer. So how will you do that? You will find this section called alias, click on yes. And here you have to select your Netflix demo load balancer. Okay, click on create. So entry is made over here. Similarly, one more entry you have to create with the similar settings, just that in name you will have to enter www as well. Click on alias yes, select the load balancer, click on create. Okay, so with this, now your route 53 is ready. And now what you can do is just go to a browser, type in netflix-demo.tk, hit enter, and it will now route you to the home page directly. And now if you go to the URL /watch, it is now pointing you to the streaming page. And this is exactly what is happening on your Netflix website as well.
So let me quickly show it to you. Okay, so if we go to netflix.com/browse, it'll take you to the home page. If you type in netflix.tk/home, it'll take you to the home page. If you type in netflix.com/watch and then the video title, it will take you to the video player, which will play the video file for you. And similarly, if here you go to netflix.com/watch, you will be taken to the streaming page. And guys, this is how you mimic the architecture for Netflix on AWS.
What's new in AWS? First, AWS is the number one cloud provider according to the market share and the growth rate. AWS basically hosts 1 out of 3 websites on the internet. That basically means any company you're looking into might be using AWS and you can get a job easily. It provides a high salary as well. So now let's start with the main part of this session, which is what's new in AWS. So the first thing I wanted to talk about is the availability zones, because whenever a company wants to go global, when they're using a cloud service, they'll basically look for a cloud provider who has an impact globally, who can reach every single country in the world. So that is done exactly by AWS. So AWS has 77 availability zones in 24 different geographical regions. So geographical regions in the sense different countries and different locations in countries, and they have 77 different data centers running across the entire globe. Okay, so this basically means if you are having an application and want to host it from your country, let's say you're in India and you're hosting an application for India, but right now your application is growing pretty well and you want to move your customer base into a little bit of Southeast Asia, let's say Singapore and some areas of let's say Japan or something, so you can move your applications architecture to those data centers as well. And right now, as of 2020 December, they have 77 availability zones and they are continuously growing. Next is the Gartner report on cloud services. So I already told you Amazon Web Services are the top leaders in the cloud provider platform. So now, according to the Magic Quadrant of 2020, AWS are in the top right corner, which basically means that they are the best in what they do. So they are leaders and visionaries. Basically, what they are telling is that in terms of execution and in terms of completeness of what exactly they have to do or their vision, they are the top among all the other 7 vendors which are named over here. So Amazon Web Services is the top right. Next comes Microsoft, then Google, then Alibaba Cloud, Oracle, IBM, and Tencent Cloud. So now again, this is the 2020 Magic Quadrant and AWS tops that as well. And coming to the next part, which is something exciting, which are local zones. So local zones is not a 2020 thing, but the first local zone was launched in December last year, that is 2019 December in Los Angeles, and in August of 2020 another local zone got launched in Los Angeles itself. So first of all, let me give you a brief about what is a local zone. So you have an idea about a region and an availability zone, right? So a region is a location in which AWS has its data centers. In that particular region, the AWS has multiple data centers. It can have 3 or more data centers in the same location. So now local zones are not basically covering a huge area. Local zones are a type of AWS infrastructure deployment that basically places all the available resources provided by AWS like compute, storage, databases to select services close to large population industry and IT centers. So basically the local zones especially concentrates around the city and around a large population where there is an industry or there are IT centers which they can collaborate with to bring the application speed really up. So they just wanted to reduce the latency of the applications. While you're using a local zone, the people in the city can actually use the application in really fast speeds. So that is the main motive of an AWS local zone. So now you can basically extend your VPC into a local zone as well. So let's say you are having your AWS VPC in one region, let's say North Virginia in USA, and right now you want to move it to a local zone. So you can do that by enabling AWS local zones in your console, and you can build your applications and run them on both the actual data center and also the local zone to give a faster access to the people in that city who are constantly using that application. Okay, so this is a new feature and it's getting popular right now because they already opened 3 in December 1st. So they're going to launch 3 more and it has already been done, and they are going to bring 12 more new local zones in 2021. So local zones are increasing. So right now they are concentrating on USA, and once it is successfully established in USA, they'll bring local zones to other countries as well. Now the best services came out in 2020, best AWS services which came out in 2020. So there is Amazon Honeycode, there is Code Guru, there is Snowcone, and IoT Sitewise. Now coming to Honeycode, it basically allows the customers or the clients to basically build mobile and web applications. So you don't need to write any code, but it helps you build mobile and web applications. So it basically helps you bypassing hiring developers. Instead, you can just do the simplest tasks. Let's say you want to email your Excel files to someone and automate that. You can do it with Honeycode, and you can do it without the help of a developer. You can do it by yourself. That's exactly the purpose of Honeycode, and it's a new service which came out in 2020. Next is Code Guru. So it's basically powered using machine learning. So it basically helps the developers to create better applications by providing automated recommendations. So basically, let's say you have your Java code or your Python code or whatever code it is on Code Guru. So now while you're having that code in Code Guru analyzes it and gives you recommendations of how to improve your code or how to remove certain lines of code which could be expensive for the application. Next comes Snowcone. So there was Snowball and Snowmobile previously. So Snowball was a bigger box where you can load data from your own on-premise setup and you can just ship it to AWS and they'll upload it in the AWS data centers. And there was Snowmobile, which was basically a truck with servers and storage units within it, and you can upload your entire on-premise data into that and it'll again get shipped to the AWS architecture. So like that, AWS have introduced a new tool called Snowcone. So it is basically the smallest member of the Snow line. So there is Snowmobile, which is the largest one. There is Snowball, the intermediate, and right now this is the smallest one, which is Snowcone. So it's basically, again, it's a portable device and it has rugged edge computing. It can be used for collecting, processing, and transferring data to the AWS cloud from disconnected environments outside traditional data centers. So basically you can buy or order this from AWS, and once it arrives, you can basically copy the data from your traditional data centers and send it back to AWS, and they'll basically take it and upload it to your AWS storage. Next, finally comes IoT Sitewise. So now IoT Sitewise is a managed service. It basically collects data from sensors and industrial equipments, whatever it is, whatever service or whatever tool you name it, it will collect data from it, and it will basically help the customers who are using IoT Sitewise to make better business decisions. So basically it's a recommendation engine for IoT. So now customers can use AWS IoT Sitewise to also monitor the operations occurring at those IoT facilities, and it can prevent costly equipment issues and also the production gaps, because it provides you data in real time and you can understand where the problem exists and you can correct it in real time. So these are 4 new exciting services provided by AWS in the year 2020, which are going to get carried over to 2021 because Honeycode is still in beta and soon it will become the official version. Code Guru, IoT Sitewise, Snowcone are already available, which are currently in usage, and these are some of the new tools, there are also so many other new services. There are so many other new features within applications itself. For example, EC2 released new set of instance types, so you can go check that out because they keep releasing new instance types each and every month. You can just go check that out, and I'll show you exactly where you can check it out as well. So now the monthly spending on EC2. So this is just the spending on a single AWS service, EC2, and I've just put in the top 4 companies who are using EC2 right now. So Netflix is using EC2 and they're paying around $19 million per month just using EC2 because Netflix uses more than 100,000 servers at any given point in time. So they'll be using 100,000 servers plus in any given point in time because they have a large customer base and they'll have to provide fast and quick streaming services to every one of them. So next comes Twitch. Again, it's a live streaming platform and obviously it needs a lot of server compute power, and in that case they are paying $15 million. LinkedIn, a huge job portal and also connecting multiple people across the same or different skills, so it pays $13 million. And Facebook, we already know what Facebook is, and it pays $11 million for EC2 each month. So these are the top competitors, or these are the top companies who are using AWS EC2, and obviously use other services as well, because if they're using EC2 they would need other services to accommodate it, and they're obviously spending a lot on AWS, and that basically means AWS is worth it instead of an on-premise setup.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now let's continue with the session.
So the first question says, what is the difference between an AMI and an instance? So guys, an AMI is nothing but a template of an operating system. It's just like a CD that you have of an operating system which you can install on any machine on the planet, right? Similarly, an AMI is a template or is an installation of an operating system which you can install on any servers which fall into the Amazon infrastructure. All right, you have many types of AMIs. You have Windows AMI, you have Ubuntu AMIs, you have CentOS AMIs, etc. There are a lot of AMIs that are present in AWS Marketplace, and you can install them on any servers which are there in the AWS infrastructure. All right. Coming on to instances, what are instances? So instances are nothing but the hardware machines on which you will install AMI, right? So like I said, AMIs are templates which can be installed on machines. These machines are called instances. And again, instances also have types based on the hardware capacity. For example, a 1 CPU and 1 GB of machine is called T2.micro, right? Similarly, you have T2.large, you have T2.extra large, then you have IO intensive machines, you have storage intensive machines, you have memory intensive machines, and all of these have been classified in different classes, right? Depending on their hardware capability. So this was the difference between an AMI and an instance. Our next question asks us, what is the difference between scalability and elasticity? Alright, so guys, scalability versus elasticity is a very confusing topic, and if you think about it, so scalability is nothing but increasing the machine's resources. For example, if your machine has 8 GB of RAM today, you increase it to 16 GB. Therefore, the number of machines are not increasing. You're basically just increasing the specification of the machine, right? And this is called scalability. When we talk about elasticity, we are basically increasing the number of machines present in an architecture. We are not increasing the specification of any machine. For example, we choose that we require a 3 GB machine with say around 8 GB or 10 GB of storage, right? So any replica which will be made or any auto scaling which will happen, it will only happen to the number of machines. It will nowhere be related to the specification of the machine. The specification of the machine will be fixed. The number of machines will go up and down, and this is called elasticity. On the other hand, scalability is basically termed as the change of the specification of the machine. That is, you're not increasing the number of machines, you're basically just increasing the specs of the machine. For example, the RAM, the memory, the hard disk, etc. And this is the basic difference between scalability and elasticity.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Moving forward, our next question is, which AWS offering enables customers to find, buy, and immediately start using software solutions in their AWS environment? Now you can think of it as, say you want a deep learning AMI, or you want a Windows Server AMI which specific software is installed on it, right? So some of them are available for free, but some of them can be purchased in the AWS marketplace. So the answer for this is AWS marketplace. It's basically a place where you can buy all the AWS systems that you, or all the AWS or non-AWS softwares that you require to run on the AWS infrastructure, right? So the answer is AWS Marketplace. Moving on, our next question would fall under the domain of resilience architecture. So all the questions that we'll be discussing henceforth in this domain will all be dealing with the resiliency of an architecture. All right. So a customer wants to capture all client connection information from his load balancer at an interval of 5 minutes. Which of the following options should be chosen for his application? All right. So I'll read out the options for you. The option A says enable AWS CloudTrail for the cloud balancer, for the load balancer. Option B says CloudTrail is enabled globally. Option C says install the Amazon CloudWatch logs agent on the load balancer. And option D says enable CloudWatch metrics on the load balancer. All right. Now, if you think about it, CloudTrail and CloudWatch are both monitoring tools. So it's a bit confusing, but if you have studied it deeply, or if you understand how CloudTrail works and how CloudWatch works, it is actually not that difficult. All right. So the answer for this is A, that is, you should enable AWS CloudTrail for the load balancer. Reason being, option B is not correct. CloudTrail is not enabled by default, or is not enabled globally to all the services. Option C says install Amazon CloudWatch. So option C and option D you will not even consider, reason being that you're talking about the log of the client information, right? What all people are connecting to the load balancer, what IP addresses are connecting to the load balancer, etc. CloudWatch deals with the local resources of the instance that you are basically monitoring. For example, if you are monitoring EC2 instance, CloudWatch can monitor the CPU usage or the memory usage of that particular instance. It cannot take into account the connections which are getting connected to your AWS infrastructure, right? On the other hand, CloudTrail deals with all these kind of things, wherein client information or any kind of data which can be fetched from a particular transaction, all of that can be recorded in the logs of CloudTrail. And hence, for this particular question, the answer is enable AWS CloudTrail for the load balancer. Moving on, our next question is, in what scenarios should we choose classic load balancer and application load balancer? All right. So for this question, I think the best way to answer this question would be to understand what exactly is classic load balancer and what exactly is application load balancer. All right. So a classic load balancer is nothing but, it's an old-fashioned load balancer which does nothing but round-robin based distribution of traffic, which means it distributes traffic equally among the machines which are under it. It cannot recognize which machine requires which kind of workload, or it requires which kind of traffic. Whatever data will come to a classic load balancer will be distributed equally among the machines which have been registered to it. On the other hand, application load balancer is a new age load balancer which basically deals with identifying the workload which is coming to it, right? It can identify the workload based on two things. It can either identify it based on the path. For example, you can say that you have a website which deals in image processing and video processing. So you can say it might go to intellipaat.com/images or /videos. So if the path is /images, the application load balancer will directly route the traffic to only the images servers, right? And if the path is /videos, the application load balancer will automatically route the traffic to the video servers. And this is application load balancer. So whenever you are dealing with multivariate traffic, that is traffic which is meant for a specific group of servers, you would use application load balancer. On the other hand, if you have servers which do the exact same thing, right? You just want to distribute the load among them equally, then in that case you would use a classic load balancer. Our next question says, if you have a website which performs two tasks, that is rendering images and rendering videos, both of these pages are hosted on different parts of the website but under the same domain name. Which AWS component will be apt for your use case among the following? Alright, so this I think is an easy question, reason being we just discussed this, right? So the answer for this is application load balancer. Reason being the kind of traffic which is coming is specific to its workload, and this can be differentiated easily by an application load balancer. Okay, so we are done with the resilient architecture questions. Now let's move on to the performance architecture domain, where we'll be discussing about how to about architectures which are performance driven, right? So let's take a look at the first question. So the first question says you require the ability to analyze a customer's clickstream data on a website so they can do behavioral analysis. So your customer needs to know what sequence of pages and ads their customers clicked on. This data will be used in real time to modify the page layouts as customers click through the site to increase stickiness and advertise click-through, which option meets the requirement for captioning and analyzing this data. Alright, so the options are Amazon SNS, AWS CloudTrail, AWS Kinesis, and AWS SES. So let's first start with the odd one out options, right? So we have Amazon SNS, which deals with notifications. So obviously, because we want to basically we want to track user data, right? So SNS would not be the apt choice for it, because sending multiple notifications in a short amount of time would not be apt. Similarly, SES would also not be the apt choice, because then we will be getting emails on basically the user behavior, and this would amount to a lot of emails. So hence it's not an appropriate solution, I think. Then we have AWS CloudTrail and AWS Kinesis. Actually, both these servers can do this work, but the keyword over here is real time. Right? You want the data to be in real time. So since the data has to be in real time, you will choose AWS Kinesis. CloudTrail cannot pass on logs for real-time analysis. Kinesis is specially built for this particular purpose, and hence for this particular question, the answer will be AWS Kinesis. Moving on, then our next question is, you have a Standby RDS instance. Will it be in the same availability zone as your primary RDS instance? Okay. So the options are, it's only true for Amazon Aurora and Oracle RDS. Second option is yes. Third option is only if configured at launch. And the fourth option is no. Alright, so the right answer for this, I want you to think about it like this, that whenever you want a standby RDS instance, it will only be there when your RDS instance stops working. Now, what could be the reasons that your RDS instance could stop working? Probably it could be a machine failure, or it could be a power failure at your at the place where your server has been launched. It can also be probably a natural calamity which would have struck your data center where your server exists. So all of these could be reasons which could lead to disruption in your RDS service, right? Now, if your standby RDS instance is also in the same availability zone as your primary, these conditions cannot be tackled, or these situations cannot be tackled. All right. So it is always logical to have your standby machines in some other place, right? So that even if there is a natural calamity or if there is a power failure, your instance is always up and ready. And because of that, AWS does not give you the option of launching your standby RDS instance in the same availability zone. It always has to be in another availability zones. And that's why the answer is no. Your RDS instance will not be in the same availability zone as your primary instance. All right. So our next question is, you have a web application running on 6 Amazon EC2 instances, consuming about 45% of resources on each instance. You are using autoscaling to make sure that 6 instances are running at all times. The number of requests this application processes is consistent and does not experience spikes. All right. So the application is critical to your business and you want high availability at all times. You want the load to be distributed evenly between all instances, and you also want to use the Amazon AMI for all instances. Which of the following architectural choices should you make? Alright, so this is a very interesting question. So basically, you want to run 6 Amazon EC2 instances, and they should be highly available in nature, and they would be using an AMI, of course, because they are autoscaled. So which among the following would you choose? So you have the options: deploy 6 EC2 instances in one availability zone and ELB, deploy 3 EC2 servers in one region and 3 in another region and use ELB. You should deploy 3 EC2 on one AZ, that is availability zone, and 3 in another availability zone. And you should deploy 2 EC2 instances in 3 regions and use an elastic load balancer. All right. Now, the correct answer for this would be C. The reason being that AMIs are not available across regions. Right? So if you have created an AMI in one region, it will not be automatically available in another region. You will have to do some changes and only then, or do some operations and only then it will be available in the another region. So this is reason number 1. So the region options mentioned over here get casted out because of this reason. Second, if you look at the first option, which says deploy 6 EC2 instances in one availability zone, that defeats the purpose of high availability, because like I said, if there is any natural calamity or a power failure at a data center, then all your instances will be down. So it's always advisable to have your servers distributed. But since we have that limitation of using an AMI, and therefore and also the limitation that it is not accessible across regions, we would choose distributing our instances among availability zones. And I'd say we just had the option of 2 availability zones, right? It could be 3 availability zones and we could deploy 2 servers in each, and this would also amount to high availability. All right. And of course, because you want to load balance traffic, if you apply an ELB on top of 3 availability zones, it will work like a charm. Regions, across regions, it can become a problem, right? And but in availability zones, it definitely works and it will work perfectly. All right. So the answer for this question is you would be deploying EC2 instances among multiple availability zones in the same region across an ELB. All right. So our next question is, why do we use elastic cache and in what cases? All right. So the answer for this is basically related to the nature of the service of elastic cache. So elastic cache, as the name suggests, is basically a cache which can be accessed faster than your normal application. For example, if you talk about...
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
A database instance from which you are gathering information, right? If you're always dealing with the same kind of query, for example, you're always fetching the password for particular users, right? So if you're using an elastic cache, that data can be captured or can be cached inside elastic cache. And whenever a similar request comes in which is asking for that kind of data, your MySQL instance will not be disturbed. The data will directly be relayed from elastic cache, and that is the exact use of elastic cache, right? So you use elastic cache when you want to increase the performance of your systems, right? Whenever you have frequent reads of the similar data. So if you have frequent reads of similar data, you'll probably be querying the same kind of data every time, and basically that will increase the load on your database instance. But to avoid that, you can basically introduce an elastic cache layer between your database and your front-end application, and that would not only increase the performance but also decrease the load on your database instance, right? So this was all about performant architectures, guys. Our next domain would deal with secure application and their architecture. So let's go ahead and start with the first question of this domain, which talks about a customer wants to track access to their Amazon simple storage service buckets and also use this information for their internal security and access audits. Which of the following will meet the customer requirement? So basically you want to just track access to the S3 buckets. Now if you want to track access, let's see what are the options. So you can enable CloudTrail to audit all Amazon S3 buckets. You can enable server access logging for all required Amazon S3 buckets. Enable the requester page option to track access via AWS billing, or you can enable AWS S3 event notifications for put and post. All right. So I would say the answer is A. And reason being, why is the answer not B? Because server access logging is actually not required when you want to deal with tracking access to the objects present in the S3 bucket. Requester pays option to access via AWS billing. Again, it's not required because there's a very simple feature of CloudTrail which is available to all the buckets across S3. So why not use that? And using notifications for S3 will not be apt. Reason being, there will be a lot of operations that would be happening. So rather than sending notifications for each and every operations, it is better that we log those operations so that whatever information we want out of that log, we can take, and rest we can ignore, right? So the answer for this is Amazon using AWS CloudTrail. Okay. Our next question is, imagine if you have to give access of AWS to a data scientist in your company. The data scientist basically requires access to S3 and Amazon EMR. How would you solve this problem from the given set of options? Okay, so you basically want to give a particular services access to an employee, and we want to know how would we do that. Okay, so the options are we should give him credentials for root. Second option being create a user in IAM with a managed policy of EMR and S3 together. Create a user in IAM with managed policies of EMR and S3 separately. Give him credentials for admin account and enable MFA for additional security. Okay, so a rule of thumb, guys, never give root credentials to anyone in your company. Even yourself, you should never use root credentials. Always create a user for yourself and access AWS through that user. All right. This was point number one. Second, whenever you want to give permissions to services or permissions of services of particular services to people, you should always create or use policies that pre-exist in AWS, right? So when I say that, I basically mean never merge two policies. Okay, so for example, if you are using EMR and S3 together, that basically means that you create a policy that gives you the required access in one document. That is, in one document you mention the access for EMR, and in the same document you mention the access for S3 as well. Well, this is not suggested. Reason being, you have policies created by AWS, which are basically created and tested by AWS. So there is no chance of any leak in terms of security aspect. Second thing is, see, needs change, right? So if tomorrow your user says he doesn't want access for EMR anymore, he probably wants access for EC2. Right? So in that case, what will you do? If you had the policy in the same document, you would have to edit that document, correct? But if you created documents separately for each and every service, all you have to do is remove the document for EMR and add the document for the other service that he requires, probably EC2. You just add the document for EC2 and your S3 document will not be touched, right? So this is more easier to manage than to, writing everything in one document and editing the code later to give permissions of specific services that he requires now, right? So that is something that is not much manageable. So the answer for this is create a user in IAM with a managed policy of EMR and S3 separately. All right, let's move on to the next question. So how would a system administrator add an additional layer of login security to a user's AWS management console? So, okay, so this is Simple question. The answer for this is enable multi-factor authentication. So a multi-factor authentication basically deals with rotating keys, that the keys are always rotating. So every 30 seconds, a new key is generated, and this key is required while you're logging in. So once you've entered your email and password, it will not straight away log you in. It will again give you a confirmation page for a code that you have to enter, which will be valid for those 30 seconds. Now this can be done using apps. So you have an app called, if you have an app from Google, you have apps from other third-party vendors as well, right? So these apps are basically compliant with your AWS, right? And you can use them to have access to the keys which are changed at every 30 seconds, all right? So it is better. If you want to enable multi-factor authentication, it is the best way of adding a security layer over the traditional username and password information that you enter. All right. So our next domain deals with cost optimized architectures. So let's discuss these questions as well. So our first question is, why is AWS more economical than traditional data centers for applications with varying compute workloads? All right, so let's read out the options. So we have Amazon Elastic Compute costs are billed on a monthly basis. Okay. Amazon EC2 costs are billed on an hourly basis, which is true. Amazon EC2 instances can be launched on demand when needed, true. Customers can permanently run enough instances to handle peak workloads. All right. So I'll say, because this question is talking about the economical value of AWS, option B and option C are correct. Reason being, you're charged according to the hour, and at the same time you can have them on demand. If you don't need them after 2 hours, just pay for 2 hours, and then you don't have to worry about where that server went, right? So this is very economical as compared to the fact that when you buy servers and their need finishes, say after 1 or 2 years, when their hardware gets outdated, so it becomes a bad investment on your part, right? And that is the reason AWS is very much economical in terms of reason being that it charges you according to the hour, and also gives you the opportunity of using servers on the basis of on-demand pricing. All right, so this would be the answer. So option B and option C would be the right answer for this particular question. Moving further, our question says you're launching an instance under the free tier usage from EMI having a snapshot size of 50 GB. How will you launch the instance under free usage tier? So the answer for this question is pretty simple. It is not possible, right? You have a limit on how much of snapshot size you can use that would fall under the free tier. 50 GB is not the size, is basically a size which will not fall under the Amazon free tier rules, and hence this is not possible. All right. Our next question says your company runs a multi-tier web application. The web application does video processing. There are 2 types of users which access this service: premium users and free edition users. The SLA for the premium users for the video processing is fixed, while for the free users it is indefinite. That is a maximum time limit of 48 hours. How would you propose the architecture for this application, keeping in mind cost efficiency? All right, so to rephrase this question, basically you have an application which has 2 kinds of traffic. One is free traffic and one is premium traffic. The premium traffic has an SLA that the task should be completed in say 1 hour or 2 hours. The free traffic, they do not guarantee it when it will finish, and it has a maximum SLA of 48 hours. So if you were to optimize the architecture for this at the backend, how would you design the architecture that you get the maximum cost efficiency possible using this architecture? All right. So the way we can deal with it is there is a thing called spot instances in AWS, which basically deals with bidding. So you bid for AWS servers in the lowest price possible, and as long as the server prices are in the range that you specify, you have that instance for yourself. So all the free users who are coming to this website can be allotted to spot instances because there is no SLA. So even if the prices go high and the systems are not available, it does not matter, right? You can wait for the applications for processing if you're dealing with free users. But for premium users, since there is an SLA, you have to meet a particular deadline. I would say you use on-demand instances. They are a little expensive, but I think because premium users are paying for their membership, that should cover that part. And spot instances would be the cheapest option for people who are freeloaders or people who are coming free on your website, because they do not have any urgency of their work and hence can wait if required if the prices are too high for you. Alright, so our next domain will talk about operationally excellent architectures. So let's see what all questions are covered in this particular domain. Alright, so imagine that you have an AWS application which is monolithic in nature. So monolithic applications are basically which do not which have the whole code base in one single computer, right? So if that is the kind of application you're dealing with, it's called a monolithic application. Now this application requires 24/7 availability and can only be down for a maximum of 15 minutes. If had your application been not monolithic, I would say that there would be no downtime. But since it's a monolithic application, the question has mentioned, there is an expected downtime of say 15 minutes. How will you ensure that the database hosted on your EBS volume is backed up? Now, since it's a monolithic application, even the database resides on the same server as that of the application. So the question is, how will you ensure that your database is backed up in case there is an outage? So for this answer, I'll say the answer is pretty easy. You can schedule EBS snapshots for your EC2 instance at particular intervals of time, and these snapshots would basically act as a backup to your database instances which have been deployed on EC2. So hence the answer is EBS instance snapshots. Alright. Our next question is, which component of AWS global infrastructure does AWS CloudFront use to ensure low latency delivery? Now, AWS CloudFront is basically a content delivery network, which basically means if you are in the US and the application that you're accessing has servers in India, it will probably cache the application in a US server so that you can access that application faster than to send traffic packets over to India and then receiving them back. All right. So this is how CloudFront works. It basically caches the application to your nearest server, and so that you get the maximum the minimum latency possible. And it is possible using AWS edge locations. Okay, so edge locations are basically the servers that are located to near your place or near a particular availability zone, which basically cache the applications which are available in different regions or are at far places. We are going to discuss the top DevOps interview questions that can be asked to you in your next DevOps interview. Continuous development, and let's see what our first question is. So our first question asks us, can we explain the Git architecture? Now this is fairly an important question, reason being only if you understand the underlying basics of how Git works will you be able to troubleshoot a problem when you face it and when you are working in a company as a DevOps engineer. All right. So let us try to explain what Git basically is and how its architecture is. Now, most of you might know that Git is a distributed version control system. Now, what is a distributed version control system? Let us explain it using a diagram. In a distributed version control system, basically your repository is distributed among the people who are contributing to that repository, and that is why it is called distributed. So that means that anyone who wants to make a change in the code that is present in this repository has to first copy this repository on his local system, commit the changes to the local file system of this repository, and only then he can push this repository onto push the code changes or the feature additions and everything to the remote repository, right? Nobody can work directly on the remote repository, and this is the main principle of how Git works, and that is the reason it is called a distributed version control system. Right? If you were to talk about the life cycle as to what are the steps to implement if somebody wants to say upload or change some code present in our remote repository. So the first thing that I have to do is pull the repository from the remote system. Once they have pulled the repository, it becomes their local repository. Change whatever files they want to change, and then once they have done with the changes, they will have to do a git commit, or they'll have to commit the files to the local repository. Once the files have been committed, they will have to be pushed to the remote repository so that it becomes visible to anyone and everyone who will pull this project the next time. All right, this is how the whole Git architecture works. Now I hope you guys understand what is the working of Git and what exactly is the architecture of Git. Moving forward, now let's talk about the next question, which says, in Git, how can you revert a commit that has already been pushed and made public? Right, so basically you have done some changes in the code, you committed those changes to your local repository, and now you have also pushed the changes to the GitHub repository. Now, if you have a CI/CD pipeline in place, which basically means that the moment you commit to Git, it automatically takes the code and deploys it on a server. If that is the kind of configuration that you have done, then probably the code that you have pushed has also been deployed on a server. And that is when you come to sense that the code is wrong, and you quickly have to change the code so that everything becomes working again. Right now, this is a very hot fix, or this is a very quick fix that probably every DevOps engineer employs whenever there is a problem in the production server. Right. So what is that quick fix? The quick fix basically says that whatever last commit was working perfectly, just roll back to that so that everything becomes normal until and unless you have fixed the new commit. That is basically the intention behind the revert procedure. Now, how can you implement the revert procedure? It can be implemented using the git revert command, and let me show you a quick demo of the git revert command so you know how you can implement it in a computer. All right. So this is my terminal, guys. Basically, I will SSH into an AWS server, and I'm in. So I have a GitHub repository that I have created for demo purposes. So like we discussed, the first stage in the lifecycle of Git is to clone the repository. So we'll just copy this address. So we'll just copy this address. 1 second. Yes. So we'll just copy this address, and then we'll come here and we'll type git clone and then the address. Okay. Now this project is basically a website that I created. It's a small website that I created. Now, in order to see that website, we will have to paste this code inside our Apache folder. So let us go inside our Apache folder, which is present in this directory. All right. Now I'll do a quick git clone along with the repository address, hit enter. And now if I do an ls, you can see that there is a folder called DevOps IQ, which has been created inside this folder. I will go inside DevOps IQ and do an ls. And you can see there's one more folder called DevOps IQ. All right, so let's go inside that. And now if I do an ls, these are the two files which are present inside my code base. Okay. Now, if you were to see what this website actually looks like right now, I can just go here and I can type in the IP address. So it's 18.222.123.58/DevOps IQ and /DevOps IQ. All right. This is how the website looks like for now. Now I have to make some changes so that the background becomes a little more better. So what I can do, I'll just go back here. I'll go do a nano and change the code of the website and say I'll change it to, I have an image in the images folder. Let me change it to 1.jpg. All right, let us save it. And once you've saved it, the next thing that you have to do is commit the changes to your local repository. And let us do that. So first I'll have to add the files to the repository. Now I'll have to commit the changes, and the message should say changed background. All right. So the changes have been committed, and now I'll push these changes. to the remote repository. So it's HSHAR and the password is this. Now before making these changes, let me quickly show you the code that you are currently going to see before I push anything on this repository. So can you see the code is images/2.jpeg.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now let's continue with the session.
I've changed the code to be 1.jpeg. So let me hit enter and let's see if our code gets changed over here. So now if I do a refresh, let me do a refresh. You can see the code has been changed just now. So it says 44 seconds ago, the code was changed. Awesome. So now because my code has been changed, if I go to this website now and hit enter, you can see the background is now changed. It is now a different background. Now what I want to do is I realize that this change that I did is probably wrong and I want to revert to a particular commit, to the older commit that was actually working. All right. So what I can do is I'll just come back to my terminal. Let me clear the screen. First thing that you do is do a git log. So now you get a log of all the commits that you have made to this particular repository. Now this is the particular commit that you have particularly applied right now, and this is causing you a problem. So just copy the commit ID for this, and now just go ahead and do a git revert. So git revert and then give this ID which you just copied. Okay, and hit enter. So once you do that, it will tell you the information about this particular commit ID, right? So just review everything and then you can see that the commit has been reverted. So now I've not pushed the changes, but then if I come back here and if I hit enter, you can see the older website comes back because the code has now been changed. And if I want to make these changes to the remote repository as well, all I have to do is git push origin master, and it'll ask me the credentials, and the changes have been pushed. Right now if I come here and I just see the code again, if I do a refresh, you can again see that the code has changed back to 2.jpeg, which was our earlier code which we made changes to. All right, so guys, this is how you can do a revert on a basically a commit and a push that you have made to your remote repository as well, right? So if you encounter any problem during working while working as a DevOps engineer, you should remember this session where I taught you how to revert a particular commit. All right, so with that, let's move on to our next question, which says, have you ever encountered failed deployments and how have you handled them? Now see, any DevOps engineer in the world will have faced a problem in which, probably the things that he had planned, the things didn't go according to his plan, right? That absolutely happens. And if somebody is asking you in a DevOps interview, have you committed mistakes? So you should, just to impress them, probably never say yes, right? So if you have never committed mistakes, that's awesome, right? But then I know that every engineer or every DevOps engineer who has worked in the industry would have faced a problem while working and would basically account to a mistake that he made while deploying things. All right. Now, the important thing or the important key takeaway from this kind of a learning should be that whatever mistake you make, you learn from it, right? And you never commit it again. And that is basically the intent behind this question as well. The interviewer would want to know, if you made the mistakes, what did you learn from those mistakes? Okay, so if an interviewer was supposed to ask me this question, I'll say, obviously I have encountered failed deployments, and what have I learned from them? I'll just give you the best practices that I think are viable for any DevOps engineer who is working in the industry. So the first thing that everyone should follow and should make it a thumb rule is that you should automate code testing. Not only does it save time, because now your tester does not have to wait for your developer to basically push the code and then check it. The developer can check it in real time because you have written a script for his application, and all the major tests which are to be done, which are pretty common, can be done using automated code testing, right? Now, like I said, it's not only for time saving, but also it removes the part where a human error can occur, right? So if you are working, when you work with people commit mistakes. But if you can write a code which will basically test each and every functionality, that code will never make a mistake. And that is why you should always automate things as far as possible, right? So like in my example, what happened was that there was basically a commit to the repository, which was basically a feature addition, right? And the tester did not see all the functionalities, or forgot to see some of the functionalities that could impact the other components of my product. And because of that, when it got pushed onto production, basically a disaster happened. Everything stopped working, right? And that was only because the testing did not happen properly, right? So for all the critical processes of your website or your product, you can basically create a code which will test that website. And basically that would basically close down most of the doors to mistakes. All right. The next thing is you should always use Docker for same environment, right? And this is basically the ideology behind DevOps, that these kind of problems where a developer used to work and the tester could not run his code on his computer, but the developer said that everything is working fine on his system. Docker basically solves that problem, right? So use Docker as much as you can for the same environment problem that you might face. Then we should always use microservices. Now, when you are working in a company, it could be that the product is in the legacy phase and hence it's on a monolith kind of a thing, but you should never encourage this kind of an architecture, right? Reason being, say you did a bad commit or you did a bad push on the production server, but it should not impact the other components of your product, right? If probably you have done something to search, and if it's a bad commit or a bad push, the only functionality that should be impacted should be your search functionality and not the other functionalities. And that is the sole reason behind why we should use microservices. That is, we should divide our application into different small products which we would deploy on servers, and these products should be independent of each other. When you talk about the monolithic architecture, all these components are coinciding with each other, have the dependency upon each other. But when you talk about a microservices kind of an architecture, you remove that dependency so as to, even if one component fails, it does not impact the whole application. Fourth point being, you should always overcome risks to avoid failures. Now, this basically means that if there is a code change, or if there is a feature addition which works sometimes and sometimes it does not, and you're not able to figure out why is exactly that thing happening, it is better to wait and troubleshoot it than to push it just to meet your dates, right? Because the latter can cause you a big problem in production when you're in a company like probably like Airtel, or in a company like Samsung or Ericsson, where their products, each second of their website's uptime brings in money, right? So if your website is down for 30 seconds, that could amount to a huge loss, and that would be on you, right? So for you to not face that kind of a situation, always be 100% sure before you make a change or a release onto the production server. All right. So this is the end to the domain of continuous development. Let's go ahead and now talk about virtualization and containerization. All right. So let's start with the first question of this domain, which says, what is the difference between virtualization and containerization? Now, this is a very important question, guys, because most of us get confused between virtualization and containerization. So let's see what are the differences between these two things. So virtualization is nothing but installing a new piece of operating system on top of a virtualized hardware. What does that mean? So basically there are softwares like Hypervisor or any other software which specializes in virtualizing hardware. So if you have a server which has around 64 gigs of RAM and 1000 TB of hard disk space, with a software like Hypervisor, what you can do is you can take that space and divide it among multiple operating systems, right? You can deploy multiple operating systems on the same hardware by virtualizing the hardware so as to the operating system will feel that, say, if you virtualize 1 GB of RAM from this whole system and say around 100 GB of storage, the operating system will think that, it only has 1 GB and 1 GB of RAM and 100 GB of storage space available to it. It cannot go beyond that. Reason being, it does not know of the hardware which is beyond or which is ahead of the hypervisor software. All right. So in virtualization, basically you have an hypervisor which sits on top of your operating system and virtualizes the hardware beneath it, right? Then you have a guest operating system. So basically once you have virtualized the hardware, you install guest operating systems on top of that. For example, the best example for this would be VirtualBox, right? You install VirtualBox and then you can install operating systems on the VirtualBox with a given spec that you will decide, right? And once you've installed the guest operating systems, on top of that, there would be the binaries or the libraries that you probably would be downloading or that came with the operating system. And on top of that, you have the applications which would be running, right? So the key takeaway from virtualization should be that it's the whole operating system is installed from the kernel level to the application level. Everything is fresh, everything is new. Now let's talk about containerization. So the thing in containerization is that the host, on top of host operating system, you install a software called the container engine. Now the container engine is just like any other software, like you have an hypervisor, you have a container engine. Now the container engine does not encourage installing a whole operating system. For example, if you want to run a container for Ubuntu on, say, a Mac machine, you can do that, right? But it will basically, in that container, you will have basically the bare minimum libraries that amount to become the Ubuntu operating system minus the kernel, right? So in a container, you do not have a kernel. The kernel is always used of the host operating system. And this is the main difference between virtualization and containerization, that in virtualization, you have a separate kernel present of the virtual operating system. But in containerization, you do not have that. And that is the reason the containers are very small. They have the bare minimum libraries required for that container to behave as a particular operating system, but the container itself does not contain any operating system. It basically is based on the same kernel on which the host operating system resides. All right, and this is basically the main difference between virtualization and containerization. Moving forward, now the next question says, without using Docker, that is without using Docker to get into a container, can we see the processes that are running inside the container of the Docker container engine? All right. So this basically is relating to the same fact that if you want to see the processes of a container which are running inside the Docker container engine, if you can see them from the outside, basically that means that the processes are running in the same kernel of the host operating system, right? The processes that are running in the Docker container engine would be basically as an addition to whatever is running on the host operating system as well. And you can see that using the ps aux command. right? So for the host operating system, it's just like any other software or any other process that it has to run. But for the container, it basically thinks that it is running inside an operating system, which it actually is not. Right? So can you see the processes? So the answer is yes, you can see the processes which are running inside a Docker container. And how can you see that? How can you basically see these processes? Let me demonstrate it to you. Okay, so we have come back to our AWS server. Let me clear the screen. All right, so if I do a Docker PS right now, you can see that there are no containers which are running on this system as of now. Now what I'll do is I'll run a container for Ubuntu. So I'll do a Docker run -it and then -d and then Ubuntu. All right, so this ran a container for me. And if I do a Docker PS now, you can see that there's a container running, which is basically of the Ubuntu image. So if I go inside this container now, so I'll do a Docker exec -it and then bash. Docker exec -it and then I forgot the container ID. So the container ID and then bash. So if I do that, I'm inside the container, right? And there's no process running inside this container as of now. Now, if I were to duplicate this, let me quickly again do an SSH. So I'll do an SSH into the same server again so that I'm on $. Okay, great. So if I do a PS AUX, these are all the processes which are running inside the operating system right now, right? But let us make it a little simpler. What we can do is, let me see all the processes which has the word watch in them, right? So let me make it more clear for you. So these are the processes which have the watch keyword inside of them. Okay, so there are basically 4 processes which are running and which have the keyword watch inside of them. Now what I'm gonna do is, inside this container, I'm gonna launch a watch process. So what is that watch process? That watch process is basically going to watch a particular command in a set interval of time. And what is that command? I basically want to say, let's see the ls-l command. Okay, so what is it doing? It is keeping a watch on the command ls-l in every 1 second, right? You can see the time over here. It is incrementing every second, and basically it's keeping a watch on all these files which are there inside the container continuously. Okay, now again, so this is the $ prompt. that we are outside the container right now. Now if I again do the same command, that is again I search for processes which have the word watch in it, I can actually see that there is a new process which is running over here, and this process is running inside the container, which I'm able to see from the host operating system level, right? So the host operating system is basically treating this particular process as if it was running on its own system. That is, the container and the host operating system, because they are sharing the same kernel, the host operating system is taking this process as if it was running inside of it, right? But if we look closely, this watch command is running inside the container, right? Let me just quickly stop it. You can see we are still inside the container and we have stopped the watch command. And if I go here and if I refresh, you can see that this watch command is again gone, which was being mentioned over here before. And this is exactly what we wanted. We basically wanted to see a process which was running inside a container from outside the container, that is from the host operating system, and that is exactly what we just did. All right. So the question that without using Docker, can you see the processes that are running inside a container? So the answer is yes, you can do it. All right. So the next question is, what is a Docker file used for? What do you basically use a Docker file for? So a Docker file is nothing but it's basically a text document to create an image using an older image and adding some files into it. All right. So it's basically like a script that you run in Linux, which can do all the things for you that are required. For example, I might need an Apache image and I want my website to be put inside the var/www/html folder inside this particular Apache container. Now, in order to do that, if I were to do it without a Docker file, I would have to first download the Apache image. So I would probably type docker run -it-id and then Apache. Once I've done that, I will exec into the container and then go to the directory called var www.html. Probably I'll do a git clone of the website that I want, and then my website will be available in that container, and hence I'll be able to use it, right? This is one way. Second way is I can create a Docker file which will basically build this image for me without me having to do all these things, all these manual things which I just told you. All right, so let's see how we can do that. So let me just exit this container and let me remove the container which are just running inside my system right now. Okay, so if I do a docker ps now, it's clean. Now what I want to do is I want to run this particular container, docker run -it-p. I want to basically expose the port 83 to this container's port 80, and I want to run it as a daemon so that it runs in the background, and that is it. Okay, so I have the container running, which is this, and what I want to do is I want to basically copy the website into this container. So let me do a docker exec into this container -it. This is the container ID, and then container ID and then bash. So I want to go inside this particular folder. So if I do an ls over here, you can see that there is an index.html and an index.php which are running, right? So it's exposed on port 83, which basically means if I go to a browser and if I go to the server's IP address on port 83, I should be able to see this Apache page, and this is basically the container which I just ran over here. Okay, what I want to do is inside this particular directory, I would be basically copying the code of my website. Now let's see how we can do that. So let me just exit this container. Let me do a docker ps. Let me do a docker stop to this particular container. So what would this do? So basically, if my Apache was running over here, it should stop once I have stopped this container. Okay, so it is stopped. So if I do a refresh over here, you can see the site can't be reached. This is exactly what we want. Okay, now let me do a git clone of my GitHub. I'll do a git clone. All right. Awesome. Now I'll go inside this folder, and basically I want to copy this particular folder inside the container. All right, so for doing that, let's create a Docker file, and what I want to say is in the image shhar/webapp, I want to add the folder DevOps IQ. And where do I want to add it? Inside the container, I want to add it in this particular directory. Okay, this is where I want to add it, and inside DevOps IQ. Okay, fair enough. And that is it. That is all you have to do. I'll just come out of this editor and I'll now do a Docker build of this Docker file with the name test. So it says successfully built an image and it has been tagged as test. Great. Now if I run this image now, docker run -it -p, say I run it on port 84, run it as a daemon and run the image. Okay, great. So if I go to port 84 now, let's see if the container is working first. So yes, the container is working. Now if I go inside DevOps IQ, what do I see? Great. So I can see the web. So basically my website is now available inside the container by simply writing a Docker file to do that. And this is exactly what we wanted. Awesome, guys. So what is the Docker file used for? It is basically used for creating an image without having to do all the manual stuff of adding your files and everything. All right. Now, once this image of yours is ready, you can push it to Docker Hub and anybody in the world can download it and can basically use your website on their local system. Great. Now, the next question is explain container orchestration. Okay, so till now we have seen that, you know, we can deploy a container, we can use it, we can probably deploy an application on it, and we can use it on the web browser, right? But it is not that simple. When we talk about a website like Amazon or a website like Google, right? It has a lot of components with it. For example, on Amazon, you would see that you have a comment section. Then on the home page, you see that there are a lot of products which have the prices, the ratings. Now, each and every component, the prices, the ratings, the name of the product, the image of the product, the comment section, each and everything is basically a microservice.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following operations retrieves the newest version of the object? A. Put. B. Get. C. Post. D. Copy. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session. Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below. Now, let's continue with the session.
It is a small part of an application which is running independently of all the other parts of the website, right? And all of this is possible using containers. So basically what they would have done is they would have ran each and every component inside a container. Now, the problem over here is, now when you have a website like Amazon, you would be dealing like you would be dealing with minimum like 10 or 11 containers for one particular copy of that website or one particular instance of that website, right? Now, when you're dealing with 10, 11 containers, these containers have to be working in conjunction to each other. They should be in sync with each other. They should be able to communicate with each other, right? And they should also be able to, we should also be able to scale a particular container in case it goes down. For example, the comment section container, it goes down for some reason. Now, if it goes down, we have to keep a watch on it and we have to redeploy it if it goes down. And all of these activities, which I just told you, comes under container orchestration, right? If you were to manually deploy these containers on Docker, you will have to keep a manual check on all these containers. But imagine when you have thousands or 10,000s of containers that you're dealing with, in those kind of scenarios, you need container orchestration. Now, container orchestration can be done using various softwares. So you have a software called Kubernetes, and before that there was a software called Docker Swarm. which basically made our life easier by doing all the manual work for us. That is, it will check the container's health. It could scale them in case they become unhealthy. They could always also notify the administrators by an email in case something happens, right? They can also run a monitoring software for you, which basically gives you a report or the health status of all the containers which are running inside that software. So this is a very small part of what a container orchestration tool can do, right? And basically, if you were to understand what container orchestration is like I said, when you work with multiple containers, you have to take in note a lot of things, and that is possible using the container orchestration tools like Kubernetes and Docker Swarm. Okay, so the next question is, what is the difference between Docker Swarm and Kubernetes? Now, they're both container orchestration tools. We just saw that. But why do we have two? Or if I were to choose between Kubernetes and Docker Swarm, which should I choose? All right, so let's look at the differences between each one of them. So the first difference, which is probably the most important difference, or probably I'll say is the deciding factor whether you should go ahead with this tool, given that you have a short deadline and you have to deploy a project. So installing Docker Swarm is very easy. It comes pre-packaged with the Docker software. So if you have installed Docker Swarm is already installed on your system. You don't have to worry about anything. On the other hand, installing Kubernetes is a very tough job, right? There are a lot of dependencies for Kubernetes. You'll have to see the system. You'll have to see the operating system on which it is running, and a host of other things, right? It has a lot of dependencies, and hence it is very tough to install. But the moment you install it, it becomes very helpful. That is, Kubernetes becomes very helpful because of the features that it offers, which brings us to our second point. Docker Swarm is faster than Kubernetes, reason being that it has less features than Kubernetes, and therefore making it a very light software and hence faster than Kubernetes. So if you want to use Docker Swarm, you should be reading about what Docker Swarm does not offer and what Kubernetes offers. And if you feel you do not need all the features that Kubernetes is offering, you can go ahead with Docker Swarm and deploy your application in a faster manner. But like I said, Kubernetes is complex, and it has a lot of services and features, because of which its deployments are a little slower when we compare it to Docker Swarm. The third point, which is the most important point, is Docker Swarm does not give you the functionality of autoscaling. Meaning, if your containers go down, or if your containers are basically performing at their peak capacity, there is no option in Docker Swarm to scale those containers. On the other hand, because of Kubernetes monitoring services and the host of other features, you have that option of providing auto scaling to your containers, which basically means you can automatically scale your containers up and down as and when they are required. And this is an amazing thing that Kubernetes handles for us. Alright guys, so these were the questions around the domain virtualization and containerization. So moving ahead, now our next domain is continuous integration. So let's shed a light on what continuous integration is. So our first question itself is, what is continuous integration? So continuous integration is basically a development practice, or I'll say it's a stage which basically connects all the other stages of the DevOps lifecycle. For example, you push your code to Git. Like we took an example, when you push the code to Git, you might have provisions which might allow you that the moment the code is pushed onto the remote repository, it automatically gets deployed on the servers as well. Well, if that is the case, basically that would be possible using integration tools that would integrate your Git repository with your remote server. And that is exactly what Jenkins runs. It's a continuous integration tool which helps us integrate different DevOps lifecycle stages together so that they work like an organism, right? This is what continuous integration means. So because we discussed about what continuous integration is, our next question says create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So on every push that you make to the remote repository, the code should automatically get deployed on a remote server. All right. So this is something that we're going to do just now. All right. But before going ahead, let's see what is the architecture for this kind of a thing. All right. So this is how the whole thing is going to work. Basically, the developer is going to commit the code to his GitHub. GitHub basically, once it sees a change in the branch that we mentioned, it is going to trigger Jenkins, which in turn will integrate or will take the website from the GitHub repository and push it onto the build server on which we want the website to be deployed. All right, sounds awesome. Great. Now let's go ahead and do this demo. So for that, we will have to SSH into our server. So let us do that. Okay, so I'm in now. Let me clear the screen. So first let's check if our Jenkins is running on this server. So let me check the status for Jenkins. So if I do a service Jenkins status, I can see that the Jenkins service is active. Awesome. So I'll just go here and I'll go to the Jenkins website, which is basically available on 8080. All right. So I'll enter my credentials. And this is how the dashboard for Jenkins looks like. Now our question is, or our aim is to create a job which basically will push a website that we are uploading to GitHub on a particular server. All right, so let's create a new job first. So let's call our job as a demo job. Okay, and let's name it as a freestyle project and click OK. So this will create a job in Jenkins for us. All right, so our job has now been created. So what we want to do is I want to take code from my GitHub. So I'll have to specify the GitHub repository over here. Okay. And similarly, I'll have to say that I want to trigger the build the moment anything is pushed on my remote repository. All right, and this should be it. Great. So I mentioned that anything that is pushed onto my master should trigger a build on Jenkins. Okay, and what should this build, or what set of commands do I want to run once build is triggered? So first I want to remove all the containers which are running inside my system. So I want to clean up, right? So for that I'll say sudo docker rm-f, then a $. This basically is going to clean all the containers which are running currently in the system. Once this is done, I want to build my website, which is going, or build my container, which is going to have my website. All right, now how can we do that? For that, I'll have to push the code to my GitHub, which will have the Docker file as well. Okay, so we created a Docker file inside. Okay, so here it is. So we have our Docker file created in the DevOps IQ folder, which was there in my home directory. Now what I want to do is I want to push. So what is there inside this Docker file? We saw that we could create a Docker file using, if we write something like this in our Docker file, and this would basically create an image with our code which is there on GitHub. All right. So what we'll do, we'll just push this code to our remote repository. and let's add the message that we have ordered a Docker file. Great. And now let's push it to our remote repo. Great. So it has been pushed to my remote repo. And now if I just go here and check if my changes have been done or not, let me just quickly refresh it. So yes, I have a Docker file in my Git repository right now, which was committed 42 seconds ago. Awesome. Great. So now what I'll do is I'll come to my Jenkins and I will say that build sudo docker build the Docker file. Now where is that Docker file? The Docker file will basically be downloaded in the Jenkins workspace. So that is in var lib Jenkins workspace, and then the name of the job, which is demo job, and that is it. So inside this I will have my Docker file, and it will basically build it and name it as, say, Jenkins. It'll name it as Jenkins. In the next step, what I'll do a sudo docker run -it and then -p and say I want to deploy it on 84 or say 87 port. Okay, and what do I want to deploy? I want to deploy Jenkins. Okay, so this should do these this should basically do all the stuff. So in the first command, basically we're removing any container which is running on the system. In the second command, what we're going to do is we're going to build the Docker file which is available in this workspace, and this workspace will basically have my GitHub project and the link I have specified over here. So it'll basically just copy, or it'll pull the project and save it in the workspace of demo job. So in this demo job, there's a Docker file. So we're building this Docker file and we're naming this created image as Jenkins. And then we are running this image and exposing it to port 87. Okay, so let's save it. Awesome. Now what we have to do is I'll have to go inside. So if you want to configure a webhook, the way to do that, when I say a webhook, basically you want your GitHub to interact with your Jenkins whenever there is a push to a particular repository. So in your repository, go to settings and then go to webhooks. So this is a webhook that I created for my Jenkins, right? So let me create it again for you. So all you have to do is click on add webhook, right? And enter the URL for your Jenkins over here. So in my case, it is this. I'll just enter it over here, followed by this keyword, which is GitHub-webhook. And that is it. Once you specify that, just go down, click on add webhook. And this should basically send a request to Jenkins, and if everything goes well, it will say last delivery was successful. Okay, so any changes that I make to my GitHub now should trigger a change over here. Now let me delete this job, because I think even this job gets triggered when my GitHub, any changes made to my GitHub, right? So let me delete this project. Okay, great. So I just have this job now. Awesome. Now let us see how it actually works. So what I want to do is I'll come back to my terminal, do an ls, and let me go inside DevOps IQ and let me do some changes in the code. So let's say I go into nanoindex.html. So the first thing that I do is I change the title of the website. So I call it as Jenkins test website. Okay. And I change the image from 2 to 1.jpg, and that is it. Let us see if I just push this website onto my server, what will happen. So I'll do a git push. Sorry, first I'll have to add these changed files into my repository. Git push origin master, sorry, git commit, and let me label this commit as test push. Okay, done. Now let's push this to our remote repository. Git push origin master, and let's give the credentials. Awesome. Now if you wait here, it should basically start a job. So as you can see, there is a job queued, which is for demo job, and this got automatically triggered by my GitHub. Okay, so let me refresh this. Okay, so the moment it gives you a red, that basically means that your job has been failed. So let's see what had just happened, why our job got failed. So if you go here, you can see the console output just like this. Okay, so basically we forgot to add a sudo here, and that is causing us a problem. Okay, so we can fix this by just going down and adding a sudo here. Save it, and again we'll have to change the code. Let's call it as Jenkins test 2 website. We'll do a control X, Y, and now let's add our files to our local repository. Git add. Now let's commit it. Test push 2, and now let's push this to our master. I'll enter the credentials, and this should be it. Okay, so let's see. So our second job got triggered automatically, and it gives us a blue. Now blue means that your job was executed successfully. So let's check what happened. So we were deploying it on port 85. So let's check if it has been indeed deployed. So it was on port 85, and the folder was DevOps IQ. Okay, so let's check. I'm not sure if it was port 85. Let's check what are the port that we have specified. So the port is 87. Okay, so let's go to port 87. Okay, so it's giving an error saying unsafe port. So for our troubleshooting, let's check if the container is running. So yes, the container is running on port 87, but it says an unsafe port. So what we can do is let us change it to say 82. And now let's just try to build the job from here. We'll just click on build now. Job has been completed, and the port was 82. Yes, so Apache is working. Now let's try going inside DevOps IQ folder. And there you go. You have your website with this title which you pushed on GitHub. Now for one more time, for testing purposes, let us push our code once more and see what happens. So I'll say that this website is test3 website, and say I'll change the image as well to 2.jpeg. Okay, save it, do a git add, do a commit, and say call it test push 3, and now let's git push origin master, enter the credentials, great. Now let's check what will happen. Okay, so our build has been started and it has been completed. Great. So if I refresh this now, it says Jenkins test 3 website, and the background also has been changed. So congratulations guys, we have successfully completed the demo. So basically, if you change anything in your GitHub, the website is automatically getting deployed on your build server, right? And on top of this, just for making it more interesting, what we can do is we can do a git log, and we can revert on this commit that we saw earlier. Okay, so let's do a git revert and then paste it, agree to everything, and then push to master, enter the credentials, everything has been pushed, job is getting triggered, job is completed, and if I go here again, my website got reverted to a particular previous version. Awesome guys, so we have completed the demo, which basically asked us to create a CI/CD pipeline using Git and Jenkins to deploy a website on every commit on the main branch. So we have done it successfully. Awesome. Let's move on to our next domain, which talks about configuration management and continuous monitoring. Awesome. So what is configuration management and what is continuous monitoring? Let's understand it. So what is the difference between Ansible, Chef, and Puppet? Now, before understanding the difference between Ansible, Chef, and Puppet, these are basically configuration management tools. What is configuration management? If you have say around 200 servers and you want to install a particular software on each of these servers, what will you do? One way what you can do is you can basically go to each and every of these servers, run a script, and that basically will install software on that on these servers, right? The other way to do it is install a configuration management software using which you can deploy or you can install all these softwares, or you can control the configuration of all these servers from one central place. And that is exactly what configuration management means, right? Now in configuration management, you have many tools like Ansible, Chef, Puppet, etc. But these are the 3 top tools which are used in the industry. Now the question is, what is the difference between Ansible, Chef, and Puppet? All right, so let's go ahead and see the differences. All right, so let's first talk about Ansible. So Ansible is very easy to learn because it is based on Python. So you don't have to sweat a lot, or you don't have to sweat much on learning the commands for Ansible because it is based on Python. So if you know Python, Ansible is going to be a cakewalk for you. It is preferred for environments which are designed to scale rapidly. Basically, with Ansible, the thing is that you don't have to install the Ansible client software on the systems on which you want to basically deploy the configuration. Ansible just has to be installed on the master, and that is it. No other configuration required. You can directly control the configuration of the client server given you have the access to it. So it offers simplified orchestration, reason being, like I just told you, that you don't have to worry about installing softwares on the client machines. Ansible can standalone take care of all the complications that come forward when you are dealing with deploying configurations without installing a particular software on the client machines. But this is basically a disadvantage of Ansible, that it has a very underdeveloped GUI. That is, you only get the CLI to work with, right? And it has very limited features when we compare it with Puppet and Chef. Now let's talk about Chef. How is Chef different from Ansible? So it is Ruby based and hence it's difficult to learn. Now Ruby is a language that not many people are acquainted with, and hence people might find it difficult to get versed with the commands of Chef. The initial setup is complicated. When I compare it with Ansible, the setup was very easy because I just had to install Ansible on the host machine, and on the client machine I didn't have to install any software. So, but with Chef you have to do that, and hence it becomes a little complicated. But once all the setup and everything is done, Chef is very stable, right? It has been, since it's a community product and it has been well contributed to, it's a very stable product and it offers you resiliency. So of course, when you're working on production servers, probably working on Chef would be a better idea than Ansible, because Ansible does not have that great community when you compare it with Chef. And of course, Chef is the most flexible solutions for OS and middleware management. Now, middleware basically means the software management part. Chef offers to be a great choice for configuration management. Reason being, it is very reliable and is very mature, because it was probably among the first configuration management tools to come out. And because community has contributed a lot to this project, it is very mature in its development stages as well. Now let's talk about Puppet. So Puppet can be tough for people who are beginners in the DevOps world, right? Because it uses its own language called Puppet DSL, right? The setup part is smooth when you compare it with Chef, but it's a little harder than Ansible, because when you're using Puppet, we use a master and an agent as well. So you will have to install Puppet agent on the client machine, and only then Puppet will be able to interact with the client software, right? Now it has a strong support for automation. So if you're planning to do some configuration management that you want to automate, Puppet is very compliant in that part. You can easily do the automation part using Puppet, and it is not suitable for scaling any deployment. So if you have say around 50 or 60 servers and you plan to add more in the future, probably Puppet would not be the right choice for that kind of an architecture. It is good to have when you have a stable infrastructure where you're probably not adding servers now and then. But if you are working on cloud and you do not know the capacity that you would be running, probably Puppet would not be a good idea to manage your configuration on your clients. Okay, our next question is, what is the difference between asset management and configuration management? So asset management basically deals with resources. It deals with hardware, which we'll have to plan so that our IT workforce can work with maximum efficiency, right? So we'll have to plan the planning of your hardware, of how many resources a particular team might need. Giving the right resources to the right people is what asset management counts in. When we talk about configuration management, it basically employs not the hardware but the software component of what all softwares are required by a particular employee of a team or a particular person in the team. What softwares are required by that person, and for other person what software is required. I mean, rather than taking the radical approach of installing every software in every machine, which should not be done because some softwares are licensed. So configuration management basically means installing the right software on the right system on which a particular person or on which a particular workload is going to run. So our next question is, what are NRPE plugins in Nagios? Okay, so NRPE plugins are basically extensions to Nagios which help you monitor the local resources of the client machines, right? So you don't have to SSH into the client machines to see how much of memory or how much of CPU is being used. Nagios being a monitoring tool, you just have to install the NRPE extension on the client machine, and it will give you a real-time data of the resources that are being consumed on that particular client machine. And obviously, when you're working in production environment, you will be monitoring multiple machines, and with NRPE plugins installed on each of those machines, you can easily monitor the resources of them at one central place. And that is exactly what NRPE plugin is.
Just a quick info, guys. Test your knowledge of AWS by answering this question. Which of the following is the central application in the AWS portfolio? A. Amazon Elastic Compute Cloud. B. Amazon Simple Queue Service. C. Amazon Simple Notification Service. D. Amazon Simple Storage and System. Comment your answer in the comment section below. Subscribe to Intellipaat to know the right answer. Now, let's continue with the session.
Our next question is, what is the difference between an active check and a passive check in Nagios? Okay, so in Nagios, if the data, the monitoring log that you're getting from your clients, if it's being delivered by a Nagios agent, in that case, it is called an active check. Reason being, Nagios is actively involved in taking all the data or in collecting all the data from your clients. But in case when you're dealing with systems wherein it does not allow you to install any other software, or probably the software itself can generate monitoring logs, in those cases what happens is rather than Nagios, the software component pushes the logs to the Nagios master, where it can take the logs and probably create a graph or create the metric for you in the dashboard. So basically, using those logs which are being published by some other software, Nagios will create a report of the health monitoring part of your client systems, right? And that is why it is called a passive check. Reason being, Nagios is not involved on the client side at all. It is basically the software's own services which are basically pushing the log to Nagios master, and hence it's called a passive check. All right, but if you talk about the architecture or the working or the life cycle of how this actually works, between on the master itself, the logs which are published are actually published to a queue, right? And whether it's an active check or a passive check, the logs have to be published to that queue so that the Nagios master can pick them up and create the monitoring metric which is required. All right, so in a passive check and in an active check, the queue is going to be there, but it's only difference between the agents. That is, in an active check, the Nagios agents are involved, but in a passive check, third-party software tools are involved, which publish the log to the Nagios master. All right, so our next question says, create an Ansible playbook to deploy Apache on a client server. So basically, we have to do configuration management. So as to, without, going inside the client system, we'll have to install a particular piece of software inside it. Okay, so let me quickly do an SSH into my AWS machine. And what I'm gonna do is, I have a slave machine which I have already configured, which can interact with my master. That is, if I do a Ansible ping all, you can see that there is a server 1 that I have configured, which has successfully responded to my master's request. Okay, now let me show you the server, which is basically working. So this is the server which is configured with my master, right? This is my client machine, and on this machine I'll have to install Apache. So if I right now go to the IP address of this machine, it says connection refused. Reason being that there is nothing installed on this server, or there is no Apache software installed on this particular server right now. All right, so let's install Apache. Now to do that, you will have to write a playbook. Now what is a playbook? A playbook looks something like this. So it's basically a YAML file that you'll have to create. So I have created one for me. So where do you want to install the Apache software is the part where you'll have to specify in hosts. So basically my client machine is a part of a group called servers that I've created, right? So the hosts are servers, and where can you actually specify what part is your machine, or which group is your machine a part of? So that you can specify over here. So it's in /etc/Ansible and /hosts. Okay, so as you can see over here, this is the group name, that is servers, and inside servers I've specified a server 1 client machine which has the IP address this. So this is the IP address of my slave. So if you can compare, it's 18.223.101.172, and if I compare it with my slave, this is the IP address of my slave, right? And this has been configured over here. So I can refer to my server 1 as servers, or I can refer it to as server 1, right? So if I do, let me do a clear over here, I can say Ansible -m ping, and I can say server 1 as well. It will reach out to my server 1, or I can say servers as well, because it's part of the group servers. Okay, so this is how it works. Now I want to install Apache. So for installing Apache, I'll have to write a playbook which looks like this. Basically it's a YAML file. So you start with the 3 dashed lines, and then you specify hosts. So hosts, I've specified every server, every machine which is inside the servers group should install Apache on it, right? And what is the task? I want to install Apache 2. This is basically a name. You can specify anything over here. Then I've specified apt. Basically I want to use the apt package to install Apache 2, the latest software. Okay, now what I will do, I will type in Ansible -playbook, and I'll type in apache.yaml. I'll hit enter, and now it has started to install everything. So it is installing on the servers group. It is gathering the facts, and it saw that it is able to communicate with server 1, and now it is accomplishing the task of installing Apache. All right, so it has been done successfully. So if I go to my Chrome browser now, and if I refresh the address, you can see that Apache is installed on this server automatically. So I didn't have to basically SSH into the server. It all happened automatically. And if I had like 5-6 computers which were running on AWS, and if I wanted to install the software on it using Apache, using Ansible, this would have been the same way. It's only that in the server group, I would have specified more IP addresses which my Ansible could talk to. Okay, so this was our task of basically deploying an Ansible playbook on a client server without SSH, doing an SSH into that client server and doing it from a central location. All right, so this is done. Now let's move on to our next domain, which is continuous testing. Now what is continuous testing? So we talked about continuous development, which is done using GitHub. We talked about continuous integration, which is possible using Jenkins. We talked about continuous configuration management, which can be done using Ansible. And next online is we have continuous testing. So once the code has been deployed, it has been integrated with Jenkins, it has been deployed on a server. The next thing is automated testing that we discussed in the best practices before, right? And it can be done using a tool called Selenium, a software called Selenium WebDriver, right? So the first question is, list out the technical challenges with Selenium. So the Selenium tool is used widely for automatic testing or automated testing, but what are the problems that you get with Selenium? So if you're using Selenium, mobile testing cannot be done. So if you have developed an application for your mobile, you cannot test it using Selenium. The reporting capabilities of Selenium are very limited. If your application or your web application deals with pop-up windows or it gives pop-up windows, Selenium would not be able to recognize those pop-up windows and work on them. And again, Selenium is only limited to web applications. So if you have an application that probably runs on desktop, probably it's a software that you have designed, you cannot test that software using Selenium. Selenium is only for those applications which can run inside a browser. And if you want to check whether there is some image in your web page and that image should have some particular content, it is a little difficult to implement it in Selenium. Although it is not impossible, it is possible. You'll have to import some libraries and other things like that. But natively, Selenium does not support image testing. You'll have to work around. You'll have to work around with Selenium to import some libraries which could do it for you. But like I said, natively Selenium does not support image testing. So our next question is, what is the difference between verify and assert commands? So let us see the differences. So if you're using assert in Selenium, if the command fails, the whole execution comes to a halt. Whereas in verify, it does not come to a halt. It keeps on continuing the rest of the lines which are written in the code. Now, how can it be helpful? How is it helpful to basically put execution at halt whenever there is an error which occurs for a particular line? It is helpful when you're dealing with critical cases. Like for example, if there are 5 cases and say if case 3 fails, case 4 and 5 cannot execute because they have a dependency on case 3. In those cases, I would say that you would have to use assert with the case 3. But in the same example, if you talk about case 1 and case 2, they do not have a dependency or they do not create a dependency for any other test cases that have to run, right? For example, case 3, case 4, case 5 are not dependent on case 1 and case 2. In those cases, we can run the verify command, which will not stop even if the test case fails, right? And this basically is done to basically see what all is working and what all is not in one shot in a testing program. And for those cases, you would use verify. But in the cases where you are testing critical cases and you do not want to waste your time testing other things, if one of your case fails, in those cases, you will use the assert test. So like I said, it is used to validate critical functionality, assert command, and verify is used to validate functionality which is of the normal behavior kind of scenario, which comes into the normal behavior. That is, it does not create a dependency for other things to not work because it stopped working. All right. So our next question is, what is the difference between set speed and sleep methods? So set speed is basically used for executing tasks at a particular interval that we specify. For example, say I want to echo hello world at intervals of 5 seconds. In that case, I can specify it using set speed. But sleep method basically suspends the execution of the whole program for a particular interval. For example, if you're doing a Selenium web test and the web page takes around 3 seconds to load, and you don't want testing to happen just after each line, you can specify a sleep method of say around 3 seconds, where it waits for 3 seconds for the website to load, and only then it will start executing the tests which follow that particular line. All right. So this is the difference between set speed and sleep.
Just a quick info, guys. Intellipaat provides online AWS certification training in partnership with Future Skills, mentored by industry experts. The course link is given in the description below.